Hey everybody, what's up? Welcome to this video. In today's video, we're going to learn about basic concepts in R programming language. So here is my first example. We're going to learn how to declare and use variables in R. So first of all, we need to be familiar with the assignment operator. So this is the assignment operator, which is this one. So when I want to assign a number to a variable, I use the assignment operator as you see it here. Okay. So this line of code means that x gets the value 10, or we can say number 10 is assigned to the variable x. So this is basically how we can assign a number to a variable in R. Then in the next line, we are having the assignment of number 5 to a variable y. So y equals 5 or y gets 5. So this is how we are assigning number 5 to a variable called y. Then in the next line, we are adding x and y and storing it in a variable called z. So x is 10, y is 5, so we are adding them together. So 10 plus 5, it will be 15, and 15 is assigned to a variable called z. And finally, in the output, we are printing the value of the variable z using the print function. So we use the print function, and in parentheses we write down the name of the variable we would like to be printed. So when I run this code, this is why I see number 15 in the output, because 15 is the output of x plus y, which was initially assigned to a variable z. But if I want to have something more than this, so I could have a variable, for example, x1, and number 12 is assigned to it. I can have the variable x2 and number, for example, 8 is assigned to it, and I have a variable called x3 and x1 minus x2 is assigned to it. And finally, I would like to print the variable x3 in the output. So when I run this code, I see that there is a mistake here. Sorry. So yeah, the assignment operator was not written correctly. So I run the code one more time and I see number 4 in the output. This number 4 comes from the fact that number 12 is assigned to a variable x1 and number 8 is assigned to a variable x2, and we are having x1 minus x2, meaning that 12 minus 8, which is number 4, is assigned to variable x3. And then we are printing the variable x3 in the output, which is this number 4 in the output. So basically, this is how we can have the declaration and using variables in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to discuss logical variables and Boolean values. Okay. So true and false are the two Boolean values in R that we have. So for example, in order to have a logical variable, we need to assign a Boolean value to it. Okay. So for example, here I am assigning the true Boolean value to a variable which is a logical variable called logical underscore var1. Okay, we can have it to be x, for example, for the sake of simplicity. Let me revise this one also, this one y, and this one y. Okay, so the true Boolean value is being assigned to a variable called x using the assignment operator. Also, the false value is being assigned to y variable, which is y logical variable, using the assignment operator. Okay, and then we try to print x and y. So when we run the code, first of all, we see true in the output, and then we see false in the output, which are representing the values for x and y. So x and y, they are logical variables that they have actually the Boolean values true and false that we assigned here. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to talk about basic math operations in R programming language. So I need to first have two variables that I call them A and B. Two numbers are assigned to them, 8 and 3. So number 8 is assigned to variable A using the assignment operator, and number 3 is assigned to variable B using also the assignment operator. So A gets 8 and B gets 3. Now I would like to calculate their sum, subtraction, multiplication, division, and exponentiation, for example, a to the power of b, and to find the remainder of their division. In order to find the addition of these two variables, I have a plus b on the right hand side. Then I have the assignment operator, which is being assigned to a variable called sum. And when I print the sum here in the output using the print function, I see number 11 is being printed in the output. So 8 plus 3, it is 11. 8 plus 3 is 11, is assigned to a variable that is named sum. And then here we are printing that variable, which is here 11, okay? Then we are having the subtraction, which is a minus b on the right hand side, and the result of this is assigned to a variable called difference. It can be y, it can be x. The name, there is no important, the name is not important so we can put whatever we want. So I just put difference because it makes more sense. So a minus b, which is 8 minus 3, is assigned to a variable called difference, and the result will be 5. So when I print the difference function, number 5 is being shown in the output. Then I have the multiplication. So a multiplied by b is assigned to a variable called product. And here I use the print function to print product. So 8 multiplied by 3, it will be 24, and we see it here in the output. Then in order to divide them, so a divided by b, meaning that 8 divided by 3, so it is on the right hand side and it is assigned to a variable called division on the left hand side. So I use the print function to print the division, and we see that this is the output and of the 8 divided by 3. Then I have the a to the power of b, meaning that 8 multiplied by 8 multiplied by 8. Okay, so when we are having 8 to the power of 3, it means that we are having 8 multiplied by 8 multiplied by 8, which is number 512. So this is assigned to a variable called power, and we are here printing power in the output, and the number in the output is 512. And finally, we are having the modulo operator. So we want to find the remainder of a variable divided by another variable. If I want to know actually the remainder of a when it is divided by b, I use the modulo operator, which is this one, okay? So the percentage sign 2 times is being there. So a modulos operator, and then b is going to be assigned to a variable called modulus, okay, and we are printing modulus in the output. So the remainder of a divided by b is number 2 that we are having it here in the output. So basic math operations we learned in this video, how to have the declaration of two variables a and b. So two numbers are assigned to a and b. We learned about basic math operations, namely addition, subtraction, multiplication, division, exponentiation, and finding the remainder using the modulus operator. And then we learned how to print them in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to discuss different variable types in R. So we are having the string variable, we are having numeric variables like integers, we are having double or float variables, and also we are having Boolean variables. So let's start with the string variable. In order to declare a string variable, we are going to use quotes, and inside quotes we are going to write whatever we want to be as our string. It can be a name, it can be a phrase, it can be a sentence, whatever. So on the right side we write down the string in quotes, then we use the assign variable to assign that string to a variable, and on the left side is the name of our variable. So for example, I call this variable name. It can be x, it can be y, it can be whatever that we choose for it to be, in fact. So this is basically what we choose is going to be our variable. So this is the first string that I have here. I can have the name of the string, which is my string, for example, and I use the assignment operator, and then on the right side I write down Reza Shahin, for example, from our programming language course. Okay, so this is the string that I would like to be assigned to a variable called my string. Okay, so this is how we can have a string variable, we can declare it. Then here I'm having an integer variable called age, and number 25 is assigned to it. So here number 25 is assigned to a variable called age using the assignment operator. Or I can have another variable as well here. So I can have, for example, my age, the assignment operator, and on the right hand side I write down 34, for example, or whatever. It can be x, and then I write down 21. So number 21 is assigned to a variable called x. Then we can have double or float numbers also being assigned. So for example, here you see that 1.68 is assigned to a variable called height. Or I can have my number, then I assign 3.14, or my, for example, I can have x2 here, and I assign a number 6.51, for example, to it. So on the right hand side I write down the number, on the left hand side I write down the name of my variable. Then I have the Boolean variables, or let's say logical variables. These Boolean variables are going to be either true or false, depending on what we are going to assign to them. So they are either true or false. These are the only options that they have. So here on the right side, I assign the true Boolean variable to the variable name is student. So is prof, for example, can be the second Boolean variable and it is false. Okay, So this is another Boolean variable. So either true or false. On the right side, on the left side, we write down the name of the variable that we want. So if I want to print them here, I use the print function and then I write down the name of the variable. So name can be there. This is the name of my first variable. Or we can have my string, we can have age, my age, x, height, my number, etc. until the end. So whatever we want to be printed, we write down inside the parentheses. So when we run the code, we are printing first the name variable, which is Alice. So Alice here was assigned to a variable called name. And then we are having it in the output. Then we are printing the age, we are printing the height, which was 1.68, and finally we are printing is the student variable, which was having the true Boolean variable value, so true is being printed in the output. So instead of name, if I add, for example, not instead, let's say I would add another print here and my string is being printed. So if I run this code, you will see that this string is also being printed, Reza Shahin from our programming language course. So I was printing it in the output using the print function, and my string is this variable which was having this string being assigned to it. Okay, so in this video we learned about different variable types. We learned more specifically about strings, integers, doubles, and floats, and we learned about Boolean variables. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about logical comparison in our programming language. So here, first of all, we are having two variables called a and b. So number 10 is assigned to variable a, number 5 is assigned to variable b here. Now we would like to have a logical comparison. So first of all, we would like to have the comparison of a and b. More specifically, we would like to check if a is greater than b or not. So if this statement is true, meaning that a is indeed greater than b, the Boolean variable true, which is this one, is assigned to the variable on the left hand side comparison one. Okay, so this is the assignment operator and this is the logical comparison. So a is greater than b, which means that 10 is greater than 5. Is it true? Yes. Therefore true is assigned to comparison of one variable. So when we print comparison one variable, we see that true is being shown here in the output. Then we are having another logical comparison. So we would like to check to see if a equals b. In order to check equality in our programming language, we need to have two equal signs to make sure that we are checking the equality. Okay, in order to make sure that you're comparing the equality in R, just remember that you need to have two equal signs. Okay, so here I check to see if a equals b, meaning that 10 equals 5. Is it true? No, it's not true. So it's false. So this is false. Therefore false is assigned using the assignment operator to a variable called comparison2. And when I print comparison2, I see false here in the output. And finally, we are having the not equal sign. In order to check not equality, we need to have these two signs, okay? Exclamation mark and the equality sign. So here I'm telling that 10 is not equal to 5. Is it true? Yes, it is true. Therefore, true is assigned to comparison3 variable, and here we are printing this variable, and we see that true is being shown here in the output. Therefore, we see that here in this video we learned how to declare two variables, how to have the logical comparison and how to print their output. But if I change these variables, so now A equals 10 and B equals 50. So if I run the code one more time, this time the results are different. So here we are saying A is greater than B, meaning that 10 is greater than 50. Is it true? No, it's not. Therefore, false is assigned to comparison 1. And when we print comparison 1, we see that false is being shown here in the output. A equals B. Is it true? No, 50 is not equal to 10. So false again is assigned to comparison 2 variable, and comparison 2 variable is being shown in the output as false. And finally, we are checking to see A is not equal to B. Is it true? Yes, because 10 is not equal to 50. So true is assigned to comparison 3 variable, and you see that when we print comparison 3, we see true in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to talk about basic if structure in R. So here I am assigning the variable x to be 5. So number 5 is assigned to x, and I would like to have an if condition there. So I would like to print the value of the variable x only if x is greater than 3. Assume that we don't know x equals 5, and I want to write down a condition to see that, okay, to check firstly if x is greater than 3 or not. If so, I want to print this message, x is greater than 3. So in order to have this condition, I use the if keyword and I put the condition inside the parentheses. So if x is greater than 3, then print x is greater than 3 message for me in the output. So when I run this code, because x equals 5, this message is being shown here in the output. But if I initialize the x to be 2 and I run the code, we see that here it shows no message in the output with respect to this if condition, because we didn't say if x is less than 3, do something. We simply said that, okay, if it's greater than 3, do something. For example, print x is greater than 3. But if it's less than that, it's not going to do anything. So now if I have x equals 7, I run the code, it says x is greater than 3. Now let's see another example. Here we are having the if else condition. So here we are having if with else condition. We are having the age to be equal to 18, and we are having the condition to be checked. If age is greater than or equal to 18, this is the condition, implement this part of the code, which is going to print you are an adult. Otherwise, print this part of the code, you are a minor. So because 18 is greater than 18 or equal to 18, this part of the code is executed, which says that you are an adult. But if I have, for example, age to be equal to 15 and I run the code one more time, we see that this message is being shown here. You are a minor, meaning that this age equals 15. So it checks to see 15. Is it greater than 18? No. Therefore, this part of the code is not executed. It goes to the else part and it prints you are a minor as we see it here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to have some coding exercises with respect to multiple conditions in R. So here I have a variable called score. It is equal 85. It is equal to 85. And we would like to have a grading system, meaning that, for example, if the score is greater than 90, I'm going to have the print of grade. I'm going to assign A to the grade. If its score is greater than 80, I'm going to assign B to the grade. If it's greater than 70, I need to assign C to the grade. And otherwise, if none of the condition above is passed, we're going to assign F to the grade. And finally, we are printing that grade variable in the output. So firstly, the score equals 85. So 85, is it greater than 90? No. So this part of the code is not executed. So 85, is it greater than or equal to 80? yes, it is correct. So it is going to assign b to the grade variable. Okay, so this is why when we run the code, it says your grade is b. So this is your grade is, this is the message that I'm writing here, and then the grade variable which b was assigned to it is being printed in the output. So if instead of having like 85, if I have, for example, 65, and I run the code here, we see that it says your grade is F. This F is assigned. So 65 greater than 90, no. Greater than 80, no. Greater than 70, no. Therefore, we go to the else part, and this F is being printed in the output as we see here. So F is assigned to the grade variable, and then we're printing it here in the output. Now let's have an example of combining conditions with AND operator. Here I have a variable called x that is equal to 10. I'm having a variable called y equals to 20, and I have an if condition here. I check to see if x is greater than 5 and at the same time y is greater than 15. So when we are having the AND operator, both of the conditions must be true in order to have the pass of this condition. Okay, so if x, this part of the condition is true, but this part of the condition is not true, it's not going to execute this part. But both of the conditions must be true. So 10, is it greater than 5? Yes. Y, is it greater than 15? Yes, because 20 is greater than 15. Therefore, print both conditions are true. But if I remove here and remove 0 from the y, so x equals 10, y equals 20. So 10 is greater than 5, yes, and 2 is greater than 15? No, it's not true, because that is not true. It's not going to execute this part of the code. So here, for example, in order to review, x equals 10 and y equals 2. So 10, is it greater than 5? Yes, but 2 is not greater than 15. Because this part of the condition is not true and we are having an AND operator here, the whole condition is not going to pass because we are having an AND operator. And for AND operator, both of the conditions must be true. So if I run the code now, we see that this message is not being shown there anymore. Why? The reason is that x is greater than 5, but y is not greater than 15. So now I revise it and I assign 20 to y, and we see that both conditions are true is shown here in the output. Okay. So now let's talk about the OR operator. In the OR operator, we are assigning, we are checking this condition. X greater than 15 or y is greater than 15, meaning that either if one of these two conditions is true, we can print this message. At least one condition is true. Okay, so because we are having an OR operator, one of them should be true, not necessarily both of them. Both of them could be true, but not necessarily it is required to have both conditions to be true. So 10 is greater than 15. Is it true? No, it's not true. But we're having an OR operator. So let's go and check the second condition. Y is greater than 15. So 20, is it greater than 15? Yes, it's true. Therefore, print this message. At least one condition is true. So this is the difference also between the and OR operator. So in this video, we dealt with multiple conditions example. We learned about the OR operator and operator. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to have an example of vectorized if-else condition in R. So I have a vector called numbers, and these are the elements of my vector. 1, 5, -2 or -2, 0 and 10. So these are the elements of a vector called numbers. And I would like to have the if-else condition to be checked for all the elements in the numbers vector. In order to do that, I have an if-else condition. So if else is there, inside the parentheses, I'm going to write down the conditions and the relevant outputs. So I would like to say if the elements in the numbers vector, if they are greater than 0, print positive, otherwise print non-positive. Note that they are separated by a comma. Okay, I'll say it one more time. If the elements in the numbers vector greater than 0, print positive, and not positive messages in the output. And then all of this is assigned to a vector that is called a result, and we're going to print result in the output. So number 1, is it greater than 0? Yes, so this condition is passed. Positive is assigned to the first element of the result vector. 5, is it greater than 0? Yes, positive is assigned. -2 is greater than 0? No, so not positive is assigned. 0 is greater than 0? No, so not positive is assigned here again. And then 10 is greater than 0? Yes, so positive is assigned. So this is basically how we can have an if-else vectorized if-else condition here. So let's have another example here as well. So I have a new vector called temperature, and we are having these numbers as the elements of this vector: 35, 15, 25, and 5. So we are having a condition being checked here. So there are multiple conditions to be checked actually. So we are saying that if the temperature, if the element in the temperature vector is greater than 30, print hot. If it is greater than 20, print warm. If it is greater than 10, print cool. Otherwise, print cold. Okay? Meaning that if, for example, a temperature is greater than 30, the hot is printed. If it's greater than 20, the warm is printed. If the temperature is greater than 10, it's going to print cool. But if neither of these conditions are true, if neither of them is true, print cold for me in the output. So let me illustrate it with the example. So 35, is it greater than 30? Hot is being printed. So we see hot in the output. 15. Is it greater than 30? No. Is it greater than 20? No. Is it greater than 10? Yes. So cool is being printed. Then 25. Is it greater than 30? No. Is it greater than 20? Yes. So warm is being printed. Finally, 5 greater than 30? No. Greater than 20? No. Greater than 10? No. Therefore, cold is being printed in the output. So all of these if conditions, whenever they are decided, which hot, warm, cool, or cold string is going to be assigned to our vector, whenever they are decided, they are going to be assigned to the weather vector, and we are printing here the weather vector that we see here. Okay, so 35, it's greater than 30, hot is assigned to the weather vector. Then 15, it's cool, cool is assigned. 25, it's in the warm category, warm is assigned to the here. 5, it's great, it's not passing any of these conditions, so cold is assigned to the weather vector. Finally, we are printing the weather vector as you see here: hot, cool, warm, and cold. All of them are being shown here in the output. So in this video we learned about vectorized if-else condition. Thanks for watching. Hello everybody and welcome to this video. In today's video we are going to have conditional assignment in R. So here I'm having number 7 being assigned to variable x, okay, and then I'm having variable y, but in order to have the variable y I have an if condition. In order to define it we need to understand this if condition firstly. So here I have an if condition for assignment of the variable y. And inside the parentheses, so the condition of if is the following: if the variable x is divided by 2 and the remainder of their division, because we are having the modulus operator, the remainder of their division equals 0, y is assigned the even string. Otherwise, odd is assigned to y. Okay, so let me say it one more time. So if 7 is divided by 2 and the remainder of this division equals 0, if this condition is true, assign even string, the string even, to the variable y. Otherwise, meaning that if this condition is not true, assign odd string to the y variable. So when I run this code, we see that here odd is being printed because 7 divided by 2, the remainder of their division is not equal to 0. But if I have the x equals x equals 8, so 8 divided by 2, the remainder of this division equals 0, and I run the code one more time, we see that this condition is true. Even is assigned to the variable y, and we're printing the variable y, which is here, and we see it here in the output. Now let's have another example: conditional variable creation. So I have a variable called value, and number 15 is assigned to it. Okay, so we are having a variable here called category, and we are checking these if conditions to decide the value of the category. Okay, so if the value of this variable called value is less than 10, assign small to category. If that number is less than 20, assign medium to the category. Otherwise, if neither of these two conditions is true, assign a large to the category. And when I run the code, we see medium is being printed in the output because value equals 15. 15, is it less than 10? So no, this condition is not true. Therefore, this part of the code is not executed. So 15, is it less than 20? Yes, therefore medium is assigned to the variable category, and here we are printing category in the output. Okay, so basically this is how we can have the conditional variable creation in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to write a program to check if a number is a positive number and also is an even number. In order to make sure that a number is an even number, we are having the following definition. If a number is divided by 2 and the remainder of this division equals 0, it means that that number is an even number. Otherwise, it's an odd number. So let me write it down here for you. So a number is an even number if that is divided by 2 and the remainder of this division equals 0. Okay, otherwise it is an odd number. So this is the definition of an even number. We would like to check to see if a number is an even number and at the same time it's a positive number, and at the same time is an even number. So in order to do that, to check that, to write that program, we are assigning number 4 to a variable called a, and we are using the assignment operator. Okay, this is the assignment operator to assign number 4 to a variable called a. It could be any name, whatever we want, we can choose it. And then first of all, we need to check if this number is greater than 0, and then check the condition to see if it's an even number or not. And we need to use if conditions for that. So first of all, we are checking to see if a is greater than 0. If a is greater than 0, meaning that this statement is true, this part of the code is going to be executed. Okay, this part of the code is going to be executed. And inside these if conditions, we are having another if condition that is here. So if a is greater than 0, we entered the first condition, but the second condition is that if a is divided by 2 and the remainder of this division equals 0, it means that not only this number is a positive number, but also an even number. How do we check that? To see if a number is divided by 2, the remainder of that division equals 0. We need to use modulus operator, so the percentage sign 2 times. In order to find the remainder of a division, we need to use the modulus operator. Okay, so a, if it's divided by 2, the remainder of their division is going to be found using the modulus operator is equal to 0, meaning that that number, if this condition is true, meaning that that number is an even number. Therefore, we are going to execute this part of the code which says a is a positive number. Okay, so when I run this code, this is why we are having this message being shown there. Okay, it says a is a positive number. We could have one else part here that is going to write down this message. For example, a is a positive number but not an even number. Okay, so when I run the code, I see the same message, but if I have number 5, I run the code one more time, I see this message. A is a positive number but not an even number. Okay, so what happened here? So a it is equal to 5. So 5, is it greater than 0? Yes. Therefore, the first condition is true. It is going to execute this part of the code, but not all of this part. Why? Because we are having another if-else condition. So 5 divided by 2 and the remainder of this division, is it equal to 0? No, it's not equal to 0. Therefore, this part of the code is not executed, meaning that that number is not an even number. Therefore, it goes for the else part, meaning that that number is still positive, but not an even number. Therefore, it is going to print this message. A is a positive number, but not an even number. This message is being shown here in the output here. Also, first of all, we check this part. A is positive, and if A is positive, this part is executed. But what if A is not positive? So I write down this condition here. So print A is not a positive number. So I run the code one more time, but this time I have -5. So when I run this code, -5, is it greater than 0? Obviously not. Therefore, this part of the code is not executed. Okay, but this else part is executed, meaning that it is going to print A is not a positive number. So in this video, we learned about if conditions more in depth. In particular, we learned how to have nested if conditions, meaning that one if condition inside another if condition. Okay, this is what we call nested if conditions. We learned about them and we checked to see if a number is a positive number and at the same time is an even number or not. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to write a program to check if a number is positive and also an even number, and also it is an even number. Okay, so we know that if a number is called an even number is a number that is divided by 2 and the remainder of this division equals 0. So this is a definition of an even number. So let me write it here for you so it would be easier to understand. Hello everybody and welcome to this video. In today's video, we would like to write a program that checks one score, and it is going to see if this score is grade A or grade B or grade C or below. Okay, so first of all, we need to have the score. We are initializing the score variable, and number 75 is being assigned to the variable score. Okay, now in order to check if this score is categorized in grade A, B, C or below, we need to have if conditions, meaning that, for example, if the score is greater than or equal to 90, it is going to be categorized as grade A. However, if it's greater than or equal to 70, it is going to be labeled as grade B, and otherwise it is grade C or below. Okay, so we need if conditions. So in order to define the if conditions with 2 conditions and one else part, we are having the following. So we use the if keyword. We are having the condition in the parentheses saying that score is greater than or equal to 90. So if this condition is true, execute only this part of the code. Okay, so if this condition, the first one, is true, it is not going to execute any other part of the code. Only this part of the code is going to be executed. So if the score is greater than or equal to 90, print grade A. But if the score is greater than or equal to 70, execute this part of the code, okay? Grade B. And how do we check that? If you want to define a new condition apart from the first one, you need to write down else if, okay? So if you want to define a new condition apart from the first one, you write down else if. So else if the score is greater than or equal to 70, print grade B. And otherwise, meaning that if neither of these 2 conditions, this score equal greater than 17, score greater than 90. If neither of them is correct, go to the else part, okay, and print this part of the code, grade C or below. Okay, so when I run this code, so 75, is it greater than 90? No, therefore this part of the code is not going to be executed. So 75, is it greater than 70? Yes, it's true, therefore this part of the code is being executed, grade B, okay, and not any other part. So we see that grade B is being shown here in the output. So now if I, instead of having 75, I have 95, and I run the code one more time, I see grade A in the output. Meaning that 95, is it greater than 90? Yes. So print grade A. And that's it. It's not going to execute the blue part anymore. Okay? Because 95 is greater than 90 and the condition is met. So it's not going to execute any other part. However, if instead of 95, I was having like 65 and I run the code one more time, it is going to check 65. Is it greater than 90? No, therefore it's not going to execute this part. 65, is it greater than 70? No, it's not going to execute this part. And finally, it is going to go to the else part because neither of these two conditions were true. So it is going to else part and print grade C or below. Okay, so we see that grade C or below is being shown here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about if conditions. So we're going to discuss if and else conditions in R. So first of all, we would like to have a program to write to see if a number is a positive number or a negative number, okay? In order to check this, we are having the declaration of variable y, and number -3 is being assigned to this variable y, okay? So we are having the number -3 being assigned to variable y using the assignment operator. Now I would like to check to see if this number is greater than 0 or not. In order to check that, we need to use if conditions. In order to implement the if conditions, it will be like we would like to execute certain part of the code only if a certain condition is true. And if that condition is not true, we may want to execute another part of the code, okay? So for example here, I write down the if keyword and in parentheses, inside parentheses, I write down y greater than 0, meaning that I would like to check to see if y is greater than 0 or not. So if y is greater than 0, then execute this part of the code, okay? So if y is greater than 0, print this message, y is positive. And we are having the else part. Otherwise, if this condition is not true, then execute this part of the code, okay? So either this part of the code is going to be executed or this part of the code is going to be executed depending on the value that is assigned to variable y. So when we write down the conditions here, the if conditions inside parentheses, we write down the conditions. We check that, okay, if y is greater than 0, execute this part of the code which says y is positive. So when I run this code, number -3 is assigned to variable y, and the compiler checks to see if -3 is greater than 0. Is it true? No, it's not true. Therefore, this condition is not met. Therefore, this part of the code is not executed. Then compiler goes to the else part, meaning that, okay, do whatever when the above mentioned condition is not true, okay? So this is why it is printing that y is not positive. It's not a positive number. How do we know that? Because if a number is not greater than 0, therefore it's not a positive number, then it's a negative number. So we print this message, y is not positive. So what if I change the value that is assigned to variable y? Now, this time I would like to assign number 3 to y. So, and I run the code one more time. This time it says y is positive. Why? Because 3 is greater than 0. and only this part of the code is being executed. Y is positive. Okay, so remember this. If conditions is inside the if conditions, it is going to execute only one part of the if condition, either this part or the other part or the other part or the other part. If you're having, for example, 10 conditions, it is going to be executing one part of this whole 10 conditions. Okay, so now y is 3, it is greater than 0, it is printing this part, y is positive. If I write down 30, 30 is still greater than 0, therefore y is positive again, is being printed here in the output. But if I write down, for example, -3 and I run the code one more time, we see that y is not positive message is being shown here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are discussing if conditions in R. So first of all, I have a variable called x. Number 5 is assigned to the variable x. So x gets 5. And we are assigning this number 5 to the variable x using the assignment operator. Now I would like to check something. I would like to check one condition. I would like to check to see if this variable x has a value that is greater than 0. In order to check that, we need to use if conditions, or let's say if statements. In order to implement them in R, we simply write down the if keyword. Inside the parentheses, we are going to have the conditions, meaning that I would like to execute the following if x is greater than 0. So if x is greater than 0, then execute this part. You see the curly braces here? Execute this part. Print x is positive. Okay. So now when I run this code, I see this message, x is positive, meaning that compiler checks the value of the variable x and checks to see if that value, which is 5, is greater than 0. Yes, it is true. Therefore, it enters this part and execute this part of the code, which says x is positive, and we see it here in the output. Now I change the value of variable x. Now 50 is assigned to x. So what do we see here? X is positive. Again, the same thing is being shown. Why? Because 50 is still greater than 0, and this part is being executed. However, if I assign -50 to the variable x and I run the code, we see nothing happens in the output. Why? Because we only defined one if condition saying that, okay, do something only if x is greater than 0. We didn't say that, okay, if x is not greater than 0, do something else. This is why we see nothing here in the output. Okay. So basically in this video, we learned how to declare an if condition and check to see if a variable is greater than 0 or not in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to print only even numbers between 1 and 10. In order to do that, we are going to write a for loop and one if condition. Why? Because we need a for loop to go through numbers from 1 to 10, and then we would like to have an if condition to categorize, let's say, the even numbers only, and print the even numbers only in the output. So this is my output, number 2, 4, 6, 8, and 10. So these are the even numbers between 1 and 10. In order to do that, first of all, we need to define a for loop. So for each I that is inside this range. Okay, so in order to write down a for loop, we use the for keyword, and I is my iterating variable here. Okay, so for each I that is in the range starting from 1 and ending at 10. Okay, we are going to have this for loop that is this part. But inside the for loop, we are having one if condition. This if condition says that if that I is divided by 2 and the remainder of their division using the modulus operator equals 0, then we realize that that number is an even number. This is a definition of an even number, okay? Print I for me, okay? So first of all, in the first iteration, I gets the value of 1. 1 divided by 2, the remainder of this division. Is it 0? No. How do we know? How do we calculate it in the code? Simply, we are having 2 percentages signs, and it is going to calculate the remainder of a division for us automatically. So 1 divided by 2, their remainder equals 0. No, this statement is not true. Therefore, this part of the code is not going to be executed. And we go for the next iteration. Now I equals 2, because we are still in the for loop, okay? So I equals 2, 2 divided by 2, the remainder of this division equals 0. Yes, it is equal 0, because 2 divided by 2, the remainder will be 0, because 2 is an even number. And therefore, we're going to print I equals 2, which is being shown here in the output, okay? Then in the next iteration, 3 divided by 2. So in the next iteration, I equals 3. 3 divided by 2, the remainder of this division equals 0. No, because it's an odd number. Therefore, nothing happens, and we are not going to execute this line. We go to next line. So if we go for the next iteration, I equals 4. 4 divided by 2, the remainder equals 0. Yes, therefore print the value of 4 in the output. Okay, so this is going to continue as long as the I equals 10 in the last iteration. So this is the ending point. 10 divided by 2, the remainder of this division equals 0. Yes, therefore we are going to print the I equals 10 for the last time. So in the last iteration, we're going to print the value of I, which is I equals 10, okay? Which I equals 10. So basically, in this video, we learned how to work with a for loop to go through numbers from 1 to 10. And then also we defined an if condition inside the for loop to print only the even numbers. And the definition of an even number is the following. If a number is divided by 2 and the remainder of their division equals 0, it means that that number is an even number, okay? So otherwise, it's an odd number. And then if it was an even number, we were going to print it in the output. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to have some coding exercises with respect to the for loops in R. So why do we need to have for loops? For example, imagine that you would like to print 5 numbers from 1 to 5. So what you need to do is to write down print 1, for example, print 2, print 3, print 4, and print 5. Okay, this is what you need to do if you want to print numbers from 1 to 5. So you can do it manually for numbers from 1 to 5 because the range is so small, you can do it in less than 10 seconds probably. But if the size of this range increases and you would like to print numbers from 1 to 100, it does not take less than 10 seconds. It consumes a lot of time. Rather than doing things manually, you can use loops in order to have efficiency in writing your codes. So here, for example, in order to print numbers 1 to 5, I simply have a for loop. This is the keyword for declaration of a for loop. For each I here is my iterating variable. For each I that is in the range of 1 to 5, okay, including 1 and including 5. So it's going to start from 1 and it's going to end at 5. For each I in this range, execute this part of the code. And this part of the code is basically printing this message, iteration, and then also prints the I. So when I run this code, we see these prints in the output. So iteration 1, iteration 2, iteration 3, iteration 4, and iteration 5. So in each iteration, I gets one value in this range. In the first iteration, I equals 1. In the second iteration, I equals 2. In the third iteration, I equals 3, and then 4, and then 5. So this is basically how we can print numbers from 1 to 5 simply using a for loop rather than doing things manually. As you see, it's easier to do it in 2 lines only. Then we would like to now learn how to loop through vector elements. So imagine that we are having a vector called fruits, and here my vector has these 3 elements: apple, banana, and cherry. And I would like to loop through the elements of this vector. In order to do that, what I do simply is to have a for loop for each fruit in the fruits vector. This fruit is my iterating variable. It can be I, for example. So I name it I, or I can name it, for example, X. Whatever you want, you can choose it yourself. So for each X that is in the fruits, in each iteration, do this part of the code. Print that element for me, and I would like it to be uppercase. So when I run this code, you see that we are having apple, banana, and cherry. So in the first iteration, X equals apple. So we are having the print of apple, and it's in uppercase because we are calling the toUpper function in order to uppercase our letters. Then in the second iteration, X equals banana. So we see banana here. And in the third iteration, X equals cherry, and we are printing X, which equals cherry, and we are printing cherry in the output. So this is also basically how we can loop through vector elements. And finally, if we want to loop with index and value, for example, here I can have for each I that is in the fruits, but before calling the fruits vector, I call the sekalong function. This is going to help me to have the indices as well. And then in the next line, I'm printing the value of I and also the ith element of that fruits vector. So let's see the output. It would be less abstract. Looking at the output, we see that in the first iteration, I equals apple, okay? In the second iteration, I equals banana, and in the third iteration, I equals cherry, okay? But when we are calling the ith element of the fruits vector, we see this, meaning that, for example, we are having the call of fruits with index, for example, 1, then the call of fruits with the indexed 2, and fruits with index 3, okay? So when in the first iteration, I equals 1, and it is going to call the first element of the fruits vector, which is apple, okay? This is what is being done here, basically. So then I equals 2, we are having the second element of the fruits vector, which is banana, and we're calling the third element of the fruits vector, which is cherry. So this is why apple, banana, and cherry are being printed here on the right hand side. And on the left hand side, we see 1, 2, and 3. So this is the value of I. 1, 2, and 3. So when I equals 1, 1 is being printed here. And then fruits for the first element is called, which is here. So the first element of the fruits vector is called, which is apple. Then I equals 2, the second element of the fruits is called, so banana is there, and I equals 3, then the third element of the fruits vector is called, which is cherry in the output. So in this video, we learned how to loop through a numeric range, how to loop through a vector element, and how to loop through a vector with index and value. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to combine two concepts: loop and conditional statements. So we are going to have for loops, for example, and if conditions that are inside the for loop. So we would like to write a program that is going to print numbers from 1 to 10, and if we reach number 6, we would like to exit the program, okay? So here is my for loop. starting from 1 to 10. So I have for each I in the range 1 to 10, execute this part of the code. So we're going to do the for loop for this part of the code. And if this I equals 6, print this message, reached 6, stopping early, and then break. Break means that get out of the for loop, okay? Do nothing more, okay? And in each iteration here, when I equals 1, for example, the first iteration, I equals 1. So 1 equals 6? No, because here in the first iteration, I equals 1, the starting point. Then we say, okay, I equals 1. 1 equals 6. This is the if condition. No, this part is not true. Therefore, this part of the code is not executed. Simply, we are going to print 1. Then I equals 2 in the second iteration. 2 equals 6. No, this part is not executed. We print 2. So we're going to continue up until 5. I equals 5. Then I equals 6. I equals 6. So 6 equals 6. Yes, this part is correct. When this part is correct, we are going to execute the blue part. We are going to show this message, reached 6, stopping early. You see? And then we are having the break statement there. So we see that after having the break, nothing happened. So we are having the reached 6, stopping early, and then we are breaking. So we are getting out of the for loop. Okay, so we are not printing 6, 7, 8, 9, and 10 anymore because we are writing down the keyword break. When we write down the keyword break, the compilers understand, okay, now I need to execute, I need to get out of the for loop. I'm going to exit the for loop. Okay, this is the usefulness of the break statement. For example, when we reach a certain number, when we meet a specific condition, for example, in our code, we're going to put the break. Okay, we are going to tell the compiler, okay, if this condition is met, break, get out of the loop, and I don't want to continue anymore. So you see that this is why we're having the print from 1 to 5, and then we are having this message being printed, reached 6, stopping early, and then after that, right after that, we're having the break. So we're going to get out of the for loop. So this is why this part of the code is not executed anymore. Okay. So this is the example of the first example of a conditional statement with a for loop. Then we would like to learn about the next keyword. Now I would like to write a program to print numbers from 1 to 10. And if that I number is divided by 2 and the remainder of their division equals 0, it means that that number is an even number. Okay, and in that condition, execute the next keyword, meaning that I'm writing the next keyword, meaning that I'm telling the compiler skip this part. Okay, so in the first iteration, I equals 1. So 1 divided by 2, the remainder of their division equals 0. No. Therefore, this part of the code is not executed. We are having the print of message odd number, and then number 1 is being printed as you see here. In the next iteration, I equals 2. So 2 is divided by 2. The remainder of their division equals 0. Yes. So this part of the code is executed, which is going to implement or execute the next keyword, meaning that skip this part, this number. Do nothing with this part. Okay, so this part is not executed. It goes for the next iteration. So I equals 3 now. 3 divided by 2. The remainder of this division equals 0. No, this condition is not true. Therefore, this part of the code is not executed. So we have odd number, message, and then number 3 is being printed here. So you see here. And this loop is going to continue until we reach the I equals 10. So by putting this condition and the next keyword, what we are doing is that we are skipping the even numbers and we are only printing the odd numbers 1, 3, 5, 7, and 9. So this is also the usefulness of the next keyword. For example, if we reach a certain condition, if we meet a number, for example, in our for loop, we can simply write down the next keyword so the compiler understands that, okay, this is not desirable and we're not looking for this. Just skip this iteration. So in this video, we learned how to combine for loops and conditional statements, let's say control statements. And moreover, we learned how to use the break and next keywords. Thank you for watching. Hello everybody and welcome to this video. In today's video, we are going to learn about nested loops. Nested loops means that we are having a for loop inside another loop. Okay, so we are having one inner loop and one outer loop. So for example, now I would like to print the multiplication table like this one. So you see that here I have numbers from 1 to 3. So 1 multiplied by 1, 1 multiplied by 2, 1 multiplied by 3, 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3, 3 multiplied by 1, 3 multiplied by 2, 3 multiplied by 3. And their corresponding result is being shown out there as well. So I would like to print something like this. Okay. For this, I need a nested loop. So we are having the outer loop and the inner loop. So for each I in the range between 1 and 3, and for each j in the range between 1 and 3 as well, I'm going to print the value of I, and then this sign, which is this one, okay, the multiplication sign, then the value of j, then this equal sign, okay, and after that I'm going to print the I multiplied by j result. Okay, so in the first iteration, let me put it this way. First iteration, I equals 1, j equals 1. So we have the 1 multiplied by 1, so the output is 1. In the second iteration, I equals 1 still, but now j equals 2. Why? Because we are in the outer loop. So I equals 1, then j equals 1, j equals 2, j equals 3. Okay, when we reached the ending point for the j inner loop, we go up in the outer loop and we increment the value of I by 1 unit. So now I equals 2. Then again, j equals 1 to 3. Then again, I equals 3. And then again from 1 to 3 for j. So I equals 1, j equals 1, I equals 1, j equals 2. The result is 2. So we see that 1 multiplied by 2 is 2. Okay. So third iteration, we have I equals 1, j equals 3. So the result is 3 as you see here. So 1 multiplied by 3, the output is 3. Now we reached the ending point of the inner loop, which is j equals 3. So now we need to go up and increment the value of I. So in the fourth iteration, we have I equals 2 now. Again, j equals 1. So it starts from 1 more time, because now we are entering the inner loop with I equals 2. So j is going to take values from 1 to 3. So the result will be 2 multiplied by 1, it's 2, as you see here. Okay. Then we have the fifth iteration, I equals 2, j equals 2. Then we have the sixth iteration, I equals 2, j equals 3. So we see that I equals 2, j equals 2, I equals 2, j equals 3. And now that j equals 3, we go up, we increment the value of I. So now I equals 3, j equals 1, I equals 3, j equals 2, I equals 3, and j equals 3. And their corresponding result is being shown on the right hand side as well. So it is being calculated from this line I multiplied by j. So this is basically how we can have a multiplication table. For example, I can have the multiplication table of number 1. So let me run the code. Now I have the multiplication table of number 1. So 1 multiplied by 1, it's 1. 1 multiplied by 2, it's 2. 1 multiplied by 3, it's 3, up until the end, 1 multiplied by 10. This is basically how we can create a multiplication table using nested loops in R. Now I would like to do the pattern printing. Okay, So this is the pattern that I would like to be printed. So for this one also, we need to have a nested loop. So we are having the outer loop, which is for each I in the range 1 to 5. So because I would like to have 5 rows, okay. And in the inner loop is that for each j in the range between 1 to I. So the starting point is 1, but the ending point equals the value of I, okay. So this way, in the first iteration, we are having I equals 1, okay. Then j equals 1 as well. And in this part, we're going to print 1 star, okay. 1 star is being printed. You see here, 1 star is being printed. Then we are having this part of the code which helps us to go to the next row. So 1 star is being printed and then we go for the next row. So in the second iteration, we have I equals 2. So j equals 1 and j equals 2, okay. So when I equals 2, j equals 1, okay, because j starts from 1 and it continues up until 2. Why? Because in this iteration, I equals 2. So j can get values 1 and 2. So firstly, we are having this part of the code, I equals 2, j equals 1. So we are having the first star being printed because we are having it here. Then we are in the same outer loop, but we change the inner loop. So now I equals 2 and j equals 2 as well. So in this situation, we are going to also print 1 more star here. Okay, so this is why we are having 2 stars here. And then the inner loop is also finished. Then we go to the next line using this \n. So we are here now. So we go to the next line, starting point of the row 3. So now I equals 3. So in the next iteration, second and third, it was second and third iterations, okay. So in the next iteration, I equals 3 and j could take values 1, 2, and 3. Why? So I equals 3 because it's the next iteration, but j can be 1, can be 2, and its ending point is the value of I, which is number 3. So it can also get the value 3 as well. And when I equals 3, j equals 1, we are going to print 1 star, which is here. When I equals 3, j equals 2, we are going to print another star, okay. When I equals 3 and j equals 3, we are going to print another star. So this is why in the third row, we are having 3 stars being printed in the output, okay. Basically, then the number of prints of a star that is out there depends on the number of the entrance in the inner loop, because whenever we enter the inner loop, the only thing that we are doing is that we are printing the stars, okay. And this is going to continue up until I equals 5 and j can get values from 1 to 5. So this is why in the last row we are having 5 stars being printed. So in this video, we learned about nested loops. We did a coding exercise regarding the multiplication table, and we did another coding exercise for pattern printing. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to have a coding exercise with respect to while loops in R. So we're going to use while loops in the situation that we don't know how many repetitions we are going to have in advance. So this is why it is useful to use while loops in these conditions. So for example, here I have the variable called count and it is initialized to be 1. Now what I would like to do, I would like to write down a while loop. So as long as this variable count is less than or equal to 5. So we're going to continue this loop as long as this count variable, which is number 1, initialized to be 1, is less than or equal to number 5. So in order to write down a while loop, simply we write down the keyword while, then inside parentheses we are having the conditions. So my condition is to continue as long as count variable is less than or equal to 5. And when this condition is passed, this part of the code is being executed. Simply we are printing the value of count, and then we are incrementing its value by 1 unit. Okay, so now count equals 1. So while 1 is less than 5, is this condition is true? Is it true? 1 is less than 5? Yes. So print the value of 1. Okay, so print this message count, which is here, and then the value of the variable count, which is number 1. Then increment its value by 1 unit. Okay, so now count equals 2. So we go and check the condition one more time. 2 is less than 5 now. Yes. So print 2 and increment it by 1 unit. So it's now 3. So the count variable is now 3. 3, is it less than, we go for the next iteration. 3, is it less than 5? Yes. Print 3, increment it to be 4. So we are printing 3 and increment it to be 4. Now count equals 4. 4, is it less than 5? Yes. So print 4 and increment it to be 5. So we print 4 and increment it to be 5 by 1 unit. So 5, is it less than or equal to 5? Yes. So print 5, we print 5 and increment it by 1 unit. So it's now 6, count equals 6. So now we go for the next iteration. We check the condition. 6, is it less than or equal to 5? No, this condition is not true. Therefore, we are not going to enter the while loop anymore. So this is why we are going to stop here. We are having the count being printed from 1 to 5 only. So this is how we can work with while loops. Thanks for watching. Hello everybody and welcome to this video. In today's video, we would like to learn about for loops in R programming language. Imagine that I would like to print numbers from 1 to 5. In order to do that, first of all, the first thing that I could do is to print them one by one. So print 1, print 2, print 3, print 4, and finally print 5. So I need to write down the print function 5 times. So when I want to print numbers from 1 to 5, it's easy to write 5 lines of code. However, if we would like to print numbers from 1 to 1000, it would be very difficult to do it manually. This is in fact why we do coding in the first place. So this is why we need to use coding, and we need to develop a good code and efficient code to do the work for us instead of us going through a very difficult journey like writing the print function 1000 times. Okay, so now for repetitive tasks like this, so printing numbers from 1 to 5, we can use for loops, meaning that we're going to write 2 lines of code instead of writing it thousands of times to do the work for us. For example, here I would like to print numbers from 1 to 5. I would like to use a for loop, meaning that I would like to have a loop that is going to iteratively get numbers from 1 to 5, and in each iteration it is going to print the value of the taken unit. Okay, for example, here I write down for loop. So I use the for keyword, and in parentheses I define my iterating variable, which is I. So for each I in the range between 1 and 5, so go and execute this part. Okay, print I in each iteration. So in the first iteration, I equals 1 because the range starts from 1. It prints number 1. Then in the next iteration, I equals 2, it prints number 2. Then next iteration, I equals 3, it prints number 3. Next iteration, I equals 4, it prints number 4. And finally, in the last iteration, I equals 5, so it prints number 5 in the output as we see it here. So we see that by defining a for loop and writing down the print function only one time, we get to print the numbers that we are looking for. So instead of 1 to 5, what if I want to have 1 to 50? So for that, I simply change the ending point. Okay, and I run the code one more time here, and you see that from 1 to 50 is being printed here. Okay, so in order to do repetitive tasks, it's better to use for loops. For example, here I wanted to print numbers from 1 to 50, in this case, in the last example. So I use the for loop. I have my iterating variable for each I that is in the range 1 to 50. So before colon, it's the starting point. After colon, it's the ending point. Okay. And for each I that is getting these values, perform this. Okay, print I. And in each iteration, we print the value of I, and we see that it goes exactly from 1 to 50 that we were looking for. Thanks for watching. Hello everybody, and welcome to this video. Hello everybody, and welcome to this video. In today's video, we would like to print the square of each number from 1 to 5. So now that we see that we need to print the squares of numbers from 1 to 5, it means that we need to do a repetitive task. And a repetitive task requires a for loop. Okay. So in order to have a for loop, we simply write down the keyword for, and I is my iterating variable. So for each I in the range starting from 1 and ending at 5, because the problem statement was mentioning that, we're going to start from 1 and we're going to end at 5. Okay, we're going to execute this part of the code. For each I in this range, we're going to execute this part of the code. In the first iteration, for example, when I equals 1, we are going to raise 1 to the power of 2 and assign it to a variable called square. Okay, so in the first iteration, let me write it down here. The first iteration, I equals 1, and we are going to have 1 multiplied by 1, so the output is 1, and number 1 is assigned to a variable called square, and this is the assignment operator. In the next line, we are going to print this message. The square of 1 is, and we are going to print the value of the square variable which equals 1. So this is why we see it here. Square of 1 is 1. Okay. So we use the print function to have this part being printed in the output, and we use the paste function because we are having multiple strings and we would like to join them into one single string in the output. So square of 1 is 1. And then in the second iteration, I equals 2, therefore we are having 2 multiplied by 2, so the output is 4. So here when I equals 2, we are having number 4 as we calculated here being assigned to a variable called square, and in the next line we are printing this message. The square of 2 is 4, so square of 2 is 4. Then we go for the third iteration, which is this one. So I equals 3, so we are having 3 multiplied by 3, the output is 9. 9 is assigned to a square variable, so we see that square of 3 is 9. And then we are having the fourth iteration, I equals 4, so we have 4 multiplied by 4, so the output is 16, so we see that the square of 4 is 16. And finally, in the last iteration, we are going to have the I equals 5, meaning that 5 multiplied by 5, it's 25. So 25 is assigned to the variable square, and we are printing it here in the output. So square of 5 is 25. So in this video, we learned how to print the square of each number from 1 to 5. Thanks for watching. Hello everybody, and welcome to this video. In this video, we are going to demonstrate the use of break statement in a while loop. So here we are having one variable called I, and it is initialized to be 1. And we are having one while loop that the condition is true, meaning that it's an infinite while loop. And if we don't put a break statement, this condition will be always stay true because there is no condition actually there. This is just a true statement in parentheses. So when we are having the true statement in parentheses, we should have a break statement. Otherwise, it will become an infinite loop. Okay, so now I have the condition, the statement, the while loop statement or condition to be true all the time. And for certain situation, I'm going to put the break. So at some point, this program is going to be terminated. And first of all, what I'm going to do is that when we enter this while loop, first of all, I'm going to print the value of I in each iteration. Okay. And if I equals 3, I'm going to break, meaning that I'm going to terminate the while loop using the break statement. It's that simple. Otherwise, if this condition is not true, this part is not going to be executed and this line is executed. So the value of I is going to be incremented by one value. So let me illustrate it with more detail. So first iteration, I equals 1. Okay. So the condition is true. So we're going to enter the while loop. So we print value 1, which is here. You see it here. And we check 1 equals 3. No. So we are not going to enter this part. We're going to increment the value of I. So I now equals 2. Okay. So I now equals 2. So in the second iteration, we're going to have I equals 2. We're going to print 2 that we see here in the output. And then we check to see if 2 equals 3. Is it true? No. So this part is again not executed. We're going to increment the value of I. So I becomes 3. I equals 3 now. So then we are going to have the third iteration. So I equals 3. We're going to print the value of 3 here. And this loop is going to be continued. Why? Because the condition is always true. So we are going to have the print of I equals 3. So we see number 3 here in the output and we check this if condition. 3 equals 3. Yes, this time it's true. So we mentioned that if I equals 3, then break. Okay, meaning that exit the loop when I equals 3. So this break is executed. Therefore, this part of the code is not going to be done anymore. So this increment is not going to be done anymore and the program is terminated. So this is why we are having 1, 2, 3 only in the output. So if I write down instead of 3 number 10 here, it means that we're going to print 1 to 10, but we're not going to have the number 11. Why? Because when we print the I equals 10 here, then 10 equals 10, this condition is met. We're going to break. And we're going to exit the loop when I equals 10 now. And this part is never executed anymore to increment the value of I from 10 to 11. So now if I run the code, you see that the print of from 1 to 10 is being shown here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to discuss while loops. We're going to write a program to calculate the sum of first 10 natural numbers using while loop. So in order to use a while loop, first of all, we need to initialize our iterating variable, which is I, and it is initialized to be 1. And we are having a new variable called sum, and we are going to store the sum of the first natural numbers in this variable. And it is initialized to be 0 in the beginning, but we're going to update it in each iteration in our while loop. So here is my while loop. We're going to continue this while loop as long as I is less than or equal to 10. This is the condition of this while loop. And why this is the condition? The reason why is that we would like to calculate the sum of the first 10 natural numbers. If we wanted to have the calculation of the sum of the first 100 natural numbers, this condition should have been I less than or equal to 100 rather than 10. But this condition this condition comes from the problem statement. Okay, so while I is less than or equal to 10, we're going to execute this part of the code. Okay, basically in each iteration, first of all, we are adding the value of I to the variable sum, and then we are going to increment the value of I by 1 unit. So let me illustrate it with an example. So in the first iteration, we're going to have I to be equal to 1, okay, meaning that sum equals sum plus 1, and sum is initialized to be 0 in the beginning. So the new value of sum is 1, sum equals 1, okay, and then we increment in this line the value of I. Okay, so the new value of I equals I plus 1, and I equals 1 plus 1, it will become, so I equals 2 now. Okay, so then we go for the second iteration. I equals 2. 2 is less than or equal to 10. Yes, so I equals 2. We're going to have sum equals 1 plus 2. Why? So this number 1 comes from the fact that we're going to have sum, the new value of sum equals sum plus I, okay? And the final version, the last version of the sum has the value of 1. So this is why we are having 1 here. And I equals 2 from the previous iteration, so we are having 2 here. So 1 plus 2, sum equals 3. And now I equals 3 as well, okay? So in the third iteration, I equals 3, sum equals 3 plus 3, so sum will become like 6, and I now will become 4. Okay, so then we are having the fourth iteration where we are having I equals 4, so sum equals 6 plus 4, so sum equals 10, and I equals 5 this time. So this iteration is going to continue until we reach I equals 10. Then at that point we are going to have the final value of sum, because in each iteration the sum is being updated. So let me illustrate it with an example. In the first iteration, sum will become 1. Why? Because I equals 1. Okay, I equals 1, sum will become 1. In the second iteration, I equals 2, and sum will become 3, because 2 plus 1, which is the value of the previous iteration of sum, will become 3, because we are trying to have the calculation of the sum of the natural numbers from 1 to 10. So now we added 1 and 2. In the next iteration, I equals 3 here, as you see. Then we are having the new value of sum equals to 6, meaning that the previous value of sum, which was 3 in the previous iteration, plus the current value of I, which is number 3, it will become 6. So this way we are adding the values of I to a new variable called sum. So first of all, we are adding number 1, we store the value, then we add on number 2, then we add on number 3, then we add on number 4, and it is going to continue until the last iteration where we add on number 10 to the value of sum. So from number 1 to 10, the sum, when we run the code, will become number 55 following this logic. But if we want to do it with hand manually, it's very hard. But using this code, it's very easy now to even calculate the sum of numbers from 1 to 100. So when I run the code now, because I modified 10 to 100, it will become 5050. The sum of numbers from 1 to 100. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about while loops. So while loops are going to be used for different purposes. We can have loops like for loops, and we can have another type of loops that is while loops. Usually when we don't know how many times we're going to do the repetition, it's better to continue better to implement actually the while loop. So now here I'm having an example here for you. I would like to write a program to have a countdown. So I would like to print numbers from 1 to 5. In order to do that, first of all, I need to initialize my iterating variable. So I is my iterating variable that is initialized to be 1 using this assignment operator. Okay. Then in order to actually implement a while loop, we are going to write down the while keyword, and inside parentheses we're going to write down the condition. So we would like to continue this while loop as long as I is less than or equal to 5. Okay, and when this condition is met, we're going to execute this part of the code actually. And whenever we're going to enter this while loop, first of all, we're going to print I, and then we are going to increment the value of I by 1 unit. Let me illustrate it with an example. So here is my iterating variable I initialized to be 1 in the first iteration. So 1 is less than or equal to 5. Yes, it is true. So in the first iteration, first of all, in the first iteration, we are going to print 1. Okay, and then when I run the code, you see this output. So we are going to print 1, and in the next line we are going to increment the value of I by 1 unit. So I, it's like equals I plus 1. So I already is 1, and we are adding another 1 unit to it, so it will become 2, and 2 is assigned to be the new value of I. Okay, so we go up again, so we check this condition. Now I equals 2. 2 is less than or equal to 5. Yes, so we are going to, in the second iteration, we are going to have the print of number 2, and I equals I plus 1 again, and this time we are going to have 2 plus 1, which will be 3. So this part is finished. We go up for another iteration. 3 is less than 5. Yes, we are going to print 3, and then we are going to increment it by 1 unit, so it will become 4. And then 4 is less than 5. We are going to print 4, increment it by another 1 unit. It will become 5. 5 is less than or equal to 5. Yes. So we are going to print 5. We are going to increment by 1 unit. We are going to increment it by 1 unit. So it will become 6. 6. Is it less than 5? No. So this condition is not passed, and the program is terminated. And when we look at the output, we are going to see I is 1, 2, 3, 4, and 5. We also could change this condition. For example, we could have I equals 5, for example, and we change this condition. So we would like to continue as long as I is greater than or equal to 0. And in each iteration, we are going to reduce 1 unit from I. This way, it means that we are going to start with I equals 5. 5 is greater than 0. Yes. So we print 5. We reduce 1 unit. So it's 4. 4 is greater than 0. Print 4. It will become 3. 3 is greater than 0. Yes. So we print 3, and we are going to reduce it by another 1 unit. So it is going to continue as long as I equals until I equals 0. So this way we are going to have a countdown from 5 to 0. The previous example was to have a count up actually from 0 to 5. Now we are having a countdown from 5 to 0. So we see that here by changing some minor modification, by having some minor modification in the code, we can reach to a totally different program. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to discuss about while loops in R programming language. So here we are going to discuss while loops. Before we discussed about the for loops. However, while loops are going to be... Hello everybody and welcome to this video. In today's video, we're going to write a program to print even numbers from 2 to 10 using a while loop. So in order to do that, first of all, we need to have the initialization of our iterating variable, which is I, and number 2 is assigned to it. So because we would like to have the print of even numbers from 2 to 10, this is why the starting point is 2, and we are going to assign number 2 to the variable I. Then we are having a while loop, and this is the condition of our while loop. So this while loop is going to continue until I is less than or equal to 10. Because the ending point is 10, this is why we are going to continue this while loop as long as I is less than or equal to 10. And then we are going to have this part of the code being executed when this condition is passed. Okay, so we are going to have the print of I in the first iteration. Then we are going to increment its value by 2 units. Why by 2 units? Because even numbers are going to be 2, 4, 6, 8, and 10. So there are differences between two even numbers that are 2, not 1. Because if we add 2 plus 1, if we add 1 plus 2, it will become 3, which is an odd number. It's not an even number. So in order to get another even number starting from number 2, we need to add 2 units in each iteration. Okay. So when I run this code, we see that 2, 4, 6, 8, and 10. These are the numbers that are being printed in the output. So these are the numbers that are being printed in the output that are even numbers from 2 to 10, as we expected. But how does it work? So let me illustrate it here with details. So in the first iteration, I equals 2. So we're going to print number 2. Okay. And then increment the I variable by 2 units. So I will become 4. Then in the second iteration, we are going to have I equals 4. So we print 4, we increment it by 20 units, it will become 6. Then in the third iteration, we are going to have I equals 6. So we print the 6, and we're going to have I equals 8 now. Okay, we increment it by 2 units. So and finally in the last iteration, which is the fourth iteration, we're going to have I equals 8. So we print 8. Therefore I now equals 10. Okay, and sorry, it was not the last iteration. The fifth iteration is the last iteration. So the fifth iteration, we're going to have I equals 5. Then we're going to print number 10. Increment the value of I by 2 units, so it will become 12. But we are not going to continue this while loop. Why? Because now I equals 12. So 12, is it less than 10? No, it's not going to pass this condition. So we're not going to have another iteration. Okay. So in this video, we learned how to have a while loop to print even numbers from 2 to 10. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to talk about functions in R. What is a function? When we would like to do something repetitive, we need to define a function in order to avoid repetition. For example, you want to calculate the square of a number. You don't need to do the calculation over and over again. You can instead define a function inside of which you do the calculation only once, and whenever you would like to do the calculation of a square of a number, you call the function instead of redoing all the calculation. Okay, so let me illustrate it with a practical example here for you. Here is a function that I am defining that is called square, and whenever this function is called, what happens is the following. So you see here, the name of my function is a square. In order to define a function, I am writing down the function keyword. Okay. So now this tells the compiler that the square that is defined here is the name of a function that I am defining. And inside parentheses, you see that I have one parameter, or let's say one variable called x. And this parameter is required whenever we would like to call the square function. Okay. And whenever this square function is called, this part of the code is being executed. It is going to return x to the power of 2. So it is going to calculate the square of the variable x that we passed when we wanted to call the square function. Okay. So let's see how we can do it. Now I am calling the square function with number 5. This number 5 is going to be equal to x. Okay, so this 5, when we are calling the square function, this 5 is assigned to the variable x, and then this function is going to return x to the power of 2, which is 5 to the power of 2. So the output is assigned to the result variable, and here I am printing the result variable. So looking at the output, you see that the square of 5 is 25. So this is the message I'm putting there. The square of 5 is, then I'm printing the result, which is the output of the square function with the value 5. Now, if I want to have the square of number 10, for example, I run the code now. I see that it's now, let me revise this part also. So now it says the square of 10 is 100. And for example, I can have here, let's say the print square of 7, for example. Okay, so I run the code now. Instead of having the result variable, because here I was calling the square function with number 10, assigning the result to the result variable, and then I was printing it here. But here I'm directly calling the square function with number 7. So this 7 is assigned to variable x. For the square function, 7 to the power of 2 is 49, and we are printing 49. So the output of this function call is 49, and because it's inside a print function, it is going to print 49 in the output for us. Okay. So instead of calculating the x to the power of 2 times, I'm simply calling the square function 2 times. I can call it many times, but this helps us to have a better code that is more improved in terms of readability. So you don't have to actually go through writing it again and again and again. So now what we could do is to work with functions with default argument. So now we see that here in the previous example, we were having a function with one argument that was called x. But now here I'm having a function that is called greet. So I'm creating a function called greet. In order to create that, I'm calling the function keyword. And inside parentheses, as always, we are supposed to put arguments. And we can have functions with no argument. I'm going to discuss that also as well. But here I'm having a default argument, meaning that I'm having a function that is called greet, and we are assigning the guest string to its argument that is called name. And whenever this greet function is called, it is going to print hello, and then the name that is assigned to it whenever this greet function is called. So let me illustrate it with an example. First of all, I call the greet function with no argument. You see that I am having no argument inside the parentheses, so nothing is passed. In this case, when nothing is passed, this guest keyword is going to by default assign to the string name, and then we are saying hello guest. So we see that when I run the code, we are having hello guest. But when I call the greet function one more time here, and this time I'm passing Alice string as an argument. So this Alice now is assigned to name, and then we are having hello, and then call the name variable, which is having the Alice string. So hello Alice is being shown in the output. Basically what's happening here is that this is a function with default argument. So how can we identify a function with default argument? Whenever there is an argument inside the parentheses of the function while we're defining it, and we're having the equal sign, meaning that there is something being assigned by default to the argument of that function. Meaning that whenever I call the greet function with no argument, this guest string is going to be assigned to the name variable, and hello guest is going to be printed in the output. However, if I call this function with a string myself, like Alice, this Alice instead of the guest is going to be assigned to the name variable. Okay, and then we are having hello Alice. So this is basically how we can have a function with default argument. So now I would like to define a new function called greet1. In this case, I'm having a function with no argument, okay? And whenever this function is called, basically it is going to print the let's say hello word string, okay? So now I try to call the greet1 function. I run the code one more time here. And here, as you see, when I run the code here, I'm having the, let me have this keyword here. I run the code as you see it here. So yeah, whenever I call the greet1 function, so this is how we can call the greet1 function. And greet1 function is initialized to be a function, and you see nothing is inside the parentheses. So this is a function with no argument. Okay, and whenever this function is called, basically it is going to print this message for me, hello world. Okay, so this is the call of the function. So in this video, we learned about a simple function to calculate the square of a number. So it was having one argument, and we tested it through two examples. Then we discussed about a function with default argument, where we are having guest to be assigned by default to the function variable argument. And if we are calling the function with no argument, this default argument is going to be used. But if we are calling the function with an argument ourselves, so this argument itself is going to be passed to be assigned to the name variable. And finally, we created a new function called greet1, and it has no argument. So whenever this function greet1 is called, it's going to print this message for us in the output, as we see it here in the output. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about functions with multiple arguments. So here I have a function that is called a rectangle stats, that is declared here. You see, this is the rectangle stats. In order to create a function in R, we learned that we need to have the function keyword. So the compiler knows that the rectangle stats is a function. And here inside the parentheses, we are supposed to put the arguments of the function. So here we are having two arguments, length and width. Okay, so whenever this rectangle stats is called, we need to have two arguments inside the parentheses. Basically, with these two arguments, length and width, we are going to calculate the area of the rectangle and the perimeter of the rectangle. And these are the formula for calculating that. Length multiplied by 2, it's the area of a perimeter. And then 2 multiplied by length plus width is the formula for calculating the perimeter of a rectangle. Basically, after that, after having the calculation of area and perimeter, we are going to print the output. So we are going to say area, and then this is the message that I'm putting here, and then the perimeter here, and then the area and the perimeter that we calculated just here, they are putting there, so we are pasting them in the output. So now basically this function, wherever it's called, it's going to calculate area, perimeter, and print its values, okay, their values, let's say. And now, how do we call the function? So now here, in order to call the function, I write down the name of the function, which is rectangle stats. Then inside parentheses, we are having two arguments, 4 and 5, meaning that I'm calling the rectangle stats, and this number 4 is assigned to the length because this is the first argument, and the second argument is number 5, which is assigned to the width. Okay. And then this function is going to calculate everything itself, the length multiplied by width. So the area is calculated, and then the perimeter is being calculated. Finally, they are going to be printed in the output that we see here. So area is 20 and perimeter is 18. So what is the usefulness of a function? Actually, we defined this function because we didn't want to do redo the calculation every time that we want to deal with a new rectangle, let's say. So otherwise, we had to do the calculation of the area and the perimeter of a rectangle with the length of 4 and 5 one time. Then whenever we are having another rectangle, we had to also recalculate the area and perimeter. But now here we are having the calculation inside the function, and whenever I have a new rectangle and I would like to calculate its area and perimeter, simply I call the function one more time. So this is the first rectangle. The second rectangle, I can have the call of the function, and then I put new numbers, for example 5 and 8. So this is my new rectangle with the length of 5 and width of 8. Therefore this is going to rerun everything in the function. So the area is 40 and perimeter is 26. Instead of doing this, so writing these 3 lines one time for this rectangle and another time for this rectangle, meaning that 6 lines of code should have been written, I only have 2 lines. Okay, so we see that the readability of the code is being increased. Why? Because we don't have repetition in the code. So, and this is a small example. If you're having your development code, you may have multiple functions, and using the functions will lead to have like hundreds of lines that are being reduced because you don't want to recalculate everything. Okay, now if I have a new rectangle, so rectangle stats, and this time it's like 8 and 10. So length is 8 and width is 10. So I run this code and we see that the area is 80 and perimeter is 36. So this is why we need functions. And in this example, we solved an example functions with multiple arguments. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to talk about functions with conditional logics. So let's say conditional logic in functions. First of all, I would like to have a function that is called check even odd. So this function is going to check if a number is even or odd. And we would like to create this function. So this is the name that we assign to this function. We use the function keyword, and inside parentheses, we are having the argument for calling this check even odd function. So whenever we need to call this function, we need to have one argument. And this function is going to be executed. This part of the function is going to be executed whenever this function is called. So if we check that number that is passed to this function is divided by 2 and the remainder of this division equals 0, it means that that number is an even number. This is the definition of an even number. If this is true, it's going to execute this part, meaning that it is going to print that number in the output and say this message, that number is even. Okay. Otherwise, if this condition is not true, meaning that if a number is divided by 2 and the remainder of this division using the modulus operator, we can measure that, is not equal to 0, we are going to go to the else part and saying that, okay, this number is an odd number. For example, number 10, if it's divided by 2, the remainder of this division equals 0. This means that number 10 is an even number. So it's going to say 10 is even in the output. So this is 10 and is even message is being printed afterwards. But if we are dividing 11 by 2, the remainder of this division is not equal to 0. So this condition is not true. Therefore, this part of the code is not executed. This part exactly, this blue part. Okay. Then the compiler goes for the else part, and then it's going to print this part saying that, okay, 11 is odd. Okay, so now I call the function check even odd, and I have the argument which is number 7. So whenever I call this check even odd function with the argument 7, this 7 is assigned to the num variable, and we are having the execution of the function. So 7 divided by 2, the remainder of this division equals 0. No, therefore that statement is not true. We go to the else part saying that 7 is odd, and looking at the output, we see that 7 is odd is being printed in the output. Okay, then we call the function one more time. We call the function with number 10. So we call this function 10 now is assigned to the num variable. 10 divided by 2, the remainder of this division equals 0. Yes, so this part of the code is executed only. It says 10 is even. So 10 is even is being printed in the output as you see it here. So this is basically how this function is working. And this function is a good example of conditional logic in functions. Now let's define another function. So this is a function with multiple conditions. In this example, we're going to have a function called grade assigner, and we need one argument called score whenever we call this grade assigner function. Basically what's happening here, whenever this function, this part of the code is executed, so we check to see if the score is greater than or equal to 90, it's going to return grade A. If it's greater than or equal to 80, else if, it's going to return B. If it's greater than or equal to 70, it's going to return C. Greater or equal than 60, it's going to return grade D. Otherwise, if the score is not passing any of these conditions, it's going to return F. This is the else part. Okay, so now I call the grade assigner function with the number 85. So 85 is assigned to the score variable, and basically what's happening here is the following. So 85, is it greater than 90? No, so this statement is not true. This part is not executed. Then it goes to the next condition. 85 is greater than 80? Yes, so return B. So it is going to return B, and this is why we see B in the output. So this is the message, your grade, and then the B is being printed in the output. But if I change this 85 to 95, so I run the code one more time, we see that 95, is it greater than 90? Yes, so return A. So we see that your grade is A. This is how it works actually. If I put down, for example, number 66, I run the code one more time, it says your grade is D. Why? Because it doesn't pass the first condition. 66 is not greater than 90. It's not greater than 80. It's not greater than 70. Is it greater than 60? Yes, so return D. So your grade is D. And if I enter a number that is not passing any of these conditions, so if I write number 40, for example, and I run the code one more time here, we see that your grade is F. So this is the else part. When neither of these conditions above is passed, it's going to go to the else part, and it's going to print the F for us in the output. So in this video, we learned conditional logic in functions. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to create and call a function in R. So here is my function called greet. So this is the name of function that I can choose myself. In order to let the compiler know that I'm dealing with a function, I use the function keyword. So whenever this greet function is called, this part of the code is going to be executed. So firstly, we name it, we call the function keyword, let's say, and then here we're going to put whatever the function is going to do after it is called. Okay, so whenever this greet function is called, it is going to print hello world message for us. Okay, and you see that when we are having the function here, the function call, to create this greet function, we have nothing in parentheses, meaning that we don't need any parameter or argument to call this greet function. And now in order to call the greet function, simply we write down its name with empty parentheses. Okay, so when I run this code, it is going to print hello world message for me because I call the greet function, and this part of the code is executed, which is going to print this hello world for me in the output. Now let's declare a function with parameters. We are having a function that is called square, and we are declaring it as a function, and we need one parameter, or let's say argument, whenever we are calling this square function. Why? Because there is a parameter inside the parentheses, meaning that whenever there is a parameter there inside the parentheses, whenever we call this square function, we need to pass that parameter as well. Basically, this function is going to return x multiplied by x. Okay, so for example, I call the square function and I pass number 4 as the argument. So x equals 4. And this function is going to return 4 multiplied by 4, which is 16. Okay. And I can have another call of the function, for example, square 5. So I run the code now, and it is going to calculate the 5 multiplied by 5. So a square function is called, 5 is assigned to x, and it is going to return 5 multiplied by 5, which is 25 in this case. So in this video, we learned how to create and call a function in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we are going to have two examples of loops in functions in R. So first of all, we're going to have a for loop inside a function in R. Here is my function that is called sum vector. And this function, in order to work, requires a vector to be passed as argument. Okay. So this is the name of the function, this is the declaration of the function, and this is the argument that is needed to call the function. So whenever this function is called, this part of the code is going to be executed. Number 0 is assigned to a variable called total. Okay. Then we are having a for loop. For each num is our iterating variable, in the vector that is passed to this function, assign the total plus that num to the total number in the for loop. Okay. This is going to help us to calculate the total numbers of a vector. So let me illustrate it with an example. I have a call of the sum vector function call, and then I'm passing this as the argument. So this is a vector starting at point 1, ending at point 5, meaning that this vector has numbers 1, 2, 3, 4, and 5. Okay, and I want to calculate their sum, 5 plus 4 plus 3 plus 2 plus 1, which is number, so 5 plus 4, it's 9, plus 3, 12, plus 2, 14, plus 1, 15. So this number 15, this is what we would like to calculate. So we call this function with this vector. So this 1 to 5 is assigned to the vector vec. So firstly, we are initializing the variable total to be 0. Then we are iterating through the numbers of this vector. So in the first iteration, num equals 1. 1 plus 0 is 1. Okay, we go for the next iteration. Then 2 plus 1 is 3. How come? In the first iteration, let me write it down. We are having total equals total plus num, and total was initialized to be 0 here. You see it here. So it's 0 plus 1 equals 1. Why 0 plus 1? Because total is 0 and num is in the first iteration num equals 1. So the new total is number 1. It's not 0 anymore. So we have the second iteration. Total equals now total plus num. So total from the previous iteration we calculated to be 1, and num in the second iteration equals 2, because we are iterating through the elements of the vector that is having these elements. Okay, plus 2. So now the new total equals 3. In the third iteration, we are going to continue this, in the fourth iteration, in the fifth iteration, until we are going to calculate the sum of all the elements in the vector, which is number 15. Okay, so this is basically how this function works with the for loop inside of it. So when I run this code, I call the same vector, sum vector function for this vector, and I see number 15 is in the output. So if I want, I can call this function one more time, and now instead of 1 to 5, I would like to know the sum of values inside a vector that is having values of 1 to 15. So we see that the sum is 120, as you see it here. Okay, now let's go and talk about a while loop inside a function. Now I have a function that is called countdown, and we are declaring the function with one argument. So whenever we call this function, we need to have one argument there. Okay, so I call the countdown function with number 3. So n equals 3 now. We check to see as long as this part of the code is going to be executed when this function is called. So as long as n is greater than 0, so while n is greater than 0, firstly print that n, which is in the first iteration number 3. So print number 3, then reduce that number by 1. So now 3 becomes 2, and then we go for the next iteration. N equals 2. 2 greater than 0, yes. Print 2, reduce by 1 unit, so it's now 1. So it was 3 firstly, then it became 2, then it became 1, and after that we reduce it to be 0. 0 is greater than 0, no, so this condition is not passed anymore. We are not going to enter this loop, and we see that the prints are shown here in the output. So these are the numbers, these are the countdown numbers, 3, 2, and 1, as we see here. So this is an example of having a while loop inside a function. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about global and local variables. So here I have a function that is called show scope, and here I have a variable that is called x. Okay, I initialize the variable x to be 10. So this is what we call global because it is accessible from anywhere in the code. It's not specific to a specific part of the code. Okay, then I have a function that is called showScape. I initialize it and I have no argument for calling this function. Whenever this function is called, this part of the code is going to be executed. And we are assigning number 5 to a variable that is called x, and this is a local variable. Why? Because this x is declared inside the show scope function, so it is local for this function. It's not global because it's not accessible any other part of the code, in any other parts of the code. It's only accessible inside this show scope function. Okay, so now this function, whenever it's called, it is going to initialize a variable x to be 5, and then it is going to print this variable x for us in the output. So first of all, I'm going to call the showScape function. When I call the showScape function, 5 is assigned to x, and this x is being printed as a local variable. So local x equals 5, as you see here. However, when I have the print of the x variable directly in the code here without calling the showScope function, I see that this x variable is being printed, which is the global x to be equal to 10. So in this video, we learned about local and global variables in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about vectors in R. First of all, we're going to learn how to create a numeric vector. So here is my vector called numVec, and in order to create that, I have the C, and inside parentheses I have the elements. So 1, 3, 5, 7, and 9. These are the elements that I want to be assigned to my vector that is called numVec. And because these are all numeric values, we call it a numeric vector. Then I print this message, numeric vector, and I print the numVec vector. So when I run the code, I see this part in the output. So numeric vector, the message is being shown, and the numbers that we assign to our numeric vector is also being shown in the output. Then we would like to create a character vector. So this is my character vector. So this is called char_vec, and then here I have 3 strings that are being separated by a comma. So apple, banana, and cherry. Note that when we are having elements that are strings in a vector, we need to put quotes there. So these are the quotes that inside which we write down our strings. So cherry, banana, and apple are assigned to char vec. We print the character vector and then we print the char vec in the output. So the character vector, this message is being shown here, and then we are having apple, banana, and cherry being printed in the output as we assigned them initially. We are having another type of vector that is called logical vector, and in which we are going to have Boolean values there. So either true or false. So true, false, true, false, true, true. So true, false, true, true. These 4 elements are assigned to our logical vector. So we show this message, we print this message, logical vector, and then we print the log vec. And in the output, we are having a logical vector. This message is being shown, and then the values that we assigned, these are the Boolean values, true, false, true, true. All of them are being printed in the output. Then we would like to create a sequence vector in R. In order to create a sequence vector, simply we are having the starting point and ending point. They are being separated by a colon here. So starting from 1, ending at 10, we are going to assign all these numbers from 1 to 10 to a sequence vector here. So we print this message sequence vector, and then we print the sec vec in the output. So looking at the output, we are having the sequence vector, and we are having from number 1 to 10. If we want to have from 1 to 20, simply I write down 1 to 20 here, okay? And finally, when we would like to have a vector with repetition function, simply we can have a vector like this one. Let's see in the output. So 1, 2, 1, 2, and 1, 2. So the values that are 1 and 2 being assigned to this vector 3 times. In order to do that, we can write down 1, 2, 1, 2, 1, 2. Okay, but an easier method is to use the rep function. Then we would like to have 2 elements in the parentheses. Firstly, we're going to have what are the numbers that we want to be repeated, 1 and 2. Okay, so these are the 2 elements that we want to be repeated. And then separating it by a comma from the second part of the parentheses, how many times we would like it to be repeated. So 3 times. I would like these values 1 and 2 being repeated 3 times. Okay, so this is why we are having 1, 2, 1, 2, and 1, 2. So all of this is assigned to a rep vector, and then we print it in the output. If I want 1, 2 to be repeated 5 times, I assign 5 2 times, and I run the code one more time. So we see that here we are having 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. So 5 times it is being repeated. And instead of 1 and 2, if I want to have 1, 2, and 3, and I run the code one more time, I see 1, 2, 3 is being repeated 5 times. So 1, 2, 3, you see here, sorry. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So this is how actually we can have different types of vector in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to perform some mathematical operations in vectors in R programming language. So now I would like to declare 2 vectors, vec1 and vec2. The first one has these 4 elements, 1, 2, 3, and 4. And the second one has these 4 elements, 5, 6, 7, and 8. Now I would like to perform the first math operation, which is the element-wise addition. In order to do that, firstly I print this message, vector addition. Then simply I print vec1 plus vec2. So looking at the output, we are having vector addition, and this is the output that we see here, 6, 8, 10, and 12. But how do we calculate this? So the first element, which is 6, is the addition of the first element of the first vector and the first element of the second vector. So 1 plus 5, it's 6. Then we are having 2 plus 6. which is 8. Then we are having 3 plus 7, which is 10. Then we are having 4 plus 8, which is 12 that we see here in the output. So this is the element-wise addition. Then we can have the element-wise multiplication. And we are firstly printing this message, vector multiplication, and then we are having vec1 multiplied by vec2. So we see that 1 multiplied by 5, it's 5. 2 multiplied by 6, it's 12. 3 multiplied by 7, it's 21. And 4 multiplied by 8, it's 32. Then we would like to have the scalar operations, meaning that I would like to add a number to each element of my vector. Okay, so here I would like to have number 5 being added to each element of the vector 1. Okay, so this is the vector 1. Doing so, I have vec1 plus 5. We can, if we want to add number 10, we can write down number 10 here. So simply we write down 1 plus 5, it will be 6. 2 plus 5, it will be 7. 3 plus 5, it will be 8. And 4 plus 5, it will be 9, as we see here in the output. So this is the scalar operation. And finally, we would like to have the dot product of two vectors, meaning that I would like to have the multiplication of 1 plus 1 and 5. So I would like to multiply 1 by 5 plus 2 by 6 plus 3 by 7 plus 4 by 8. Okay. So it means that I would like to have like the vector multiplication, but all the numbers, they must be addition, meaning that, for example, I would like to have 1 multiplied by 5, okay, plus 2 multiplied by 6 plus 3 multiplied by 7 plus 4 multiplied by 8. So the output would be 6 plus 12 plus 21 plus 32. So the output would be 70. Okay, so this is the dot product of vector 1 and vector 2. Okay, for doing that, firstly we need to have the vec1 multiplied by vec2, which we calculated earlier. Why? Because we see that vec1, when it is multiplied by vec2, we are having the same numbers here. Okay, so 1 multiplied by 5, it will be 5, sorry. So we see that 5, 12, 21, and 32. So this is the multiplication of the first vector by the second vector as we are having it here. And if we calculate the sum of these numbers, we can calculate the dot product. Okay, so then after we are having the multiplication of vec1 and vec2, we are going to sum over all the elements, which are these ones. So the output will be 70, that is shown here in the output. So in this video, we learned how to perform math operations in vectors in R. So I would like to have element-wise addition, element-wise multiplication, scalar operations, and vector dot product. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to work with vectors in R. We're going to learn how to access a single element, how to access multiple elements of a vector, how to access with logical vector, and we're going to learn how to navigate indexing in vectors and how to have access for named vectors. First of all, I'm initializing my vector called vec, and these are the elements of my vector from 10 to 60. So 10, 20, 30, 40, 50, and 60. These are the elements of my vector. Now I would like to access the third element of this vector. In order to access the third element, simply I use the print function to print it in the output. Then I call the element with index 3 of the vector called a vec. Okay, so I write down the name of the vector, which is a vec, and inside the square brackets, I'm going to write down the number of the index that I'm looking for, which is the third element. If I want to have the access to the first element, I write down simply number 1 here. Okay, so I run the code. I see that third element is 30, that is being shown in the output. Then I would like to have access to multiple elements in a vector. In order to do that, we need to have the colon, okay? For example, I would like to access elements 2 through 4, okay? So this is the second element, third element, and the fourth element. From 2 to 4, these are the elements that I would like to have access to. In order to do that, firstly, I print this message, elements 2 through 4. Then I call the name of the vector, which is vec. Inside the square brackets, I'm going to write the starting point, which is index 2, because this is the second element. And then colon, after colon, I write down the ending point, which is index 4, because this is the fourth element that I'm looking for. Elements 2 through 4, okay? With index 2 through 4. So index 2 is the starting point and 4 is the ending point from the vector called vec. So when I run this code, it says elements 2 through 4 are 20, 30, and 40. Actually, if we're looking for elements from 1 to 4, simply I write down 1 here, okay? And I run the code. So let me modify this part as well. So I run the code and look at it in the output. So we see that 10, 20, 30, and 40. These are the elements from indexing 1 to 4. 10, 20, 30, and 40. So index 1, index 2, index 3, and index 4. Then I would like to have access to elements with a logical vector. What do we mean by that? In order to have access to certain elements with an if condition, for example, I want to print the elements, only the elements, let's say, that are larger than or greater than 30, okay? In order to do that, I call each element of the vector vec that is greater than 30 inside the square brackets of the vector vec, okay? So we write down the name of the vector here. Then here I write down the name, meaning that each element in that vector must be greater than 30 to be printed. So when I run the code, I see number 40, 50, and 60. These three values are being printed in the output because these are the elements in this vector that are greater than 30. Note that it's not greater than or equal to 30, okay? It's only greater than 30, so I'm having 40, 50, and 60 in the output. Then I would like to have the removal of one element. So I would like to exclude the first element, okay? In order to do that, simply write down the name of the vector, which is vec, and then -1, meaning that I want to exclude the first element. In order to exclude the first element, I have 20, 30, 40, 50, and 60 being printed in the output. So vector, we write down the name of the vector, which is vec. Inside the square brackets, I have -1, meaning that the first element is being excluded and the rest of the elements are being printed here in the output. So 20, 30, 40, 50, and 60. And finally, I have a new element that is like this. So it's like a key value pair. I have 3 keys, A, B, and C. Each of the keys are assigned to a value that are 1, 2, and 3. So 1 is assigned to A, 2 is assigned to B, 3 is assigned to C. And these are assigned to a vector that is called named vec, okay? And I would like to access by name, meaning that I want to access the element, the value of the key that is B, okay? So as I mentioned, A, B, and C, these 3 are the key in our vector, and 1, 2, and 3, they are their corresponding values, okay? So I would like to know the value for the key B, okay? In order to do that, simply in the square brackets, in quotes, I write down the name of the key that I'm looking for, which is B in this case. And then I write down the name of the vector that is named vector. So when I run the code, it says that for B, we are having the value 2, which is correct. So for B, we are having the value 2. If I want to know the value of the key C, which is number 3, I write down C here. I go up, I run the code one more time. I see that the value 3 is being printed here in the output. And this is the message, access by name. So access by name, C is 3. So in this video, we learned how to have access to elements of a vector in different ways. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to learn about vectors function. Okay, well, let's say a vector functions. So here is my vector called vec, and these are the elements of my vector: 5, 2, 8, 1, 9, and 3. So I have 6 elements there. Firstly, I would like to perform basic statistical functions. I would like to have some calculation for basic statistical methods for my vector. So in order to do that, firstly, I would like to calculate the sum. I write down the name of the vector, which is vec, and then I put the name of this vector actually in the parentheses of the sum function. So there is a function called sum. It can help us to calculate the sum of all elements in vector vec. Okay, so then I call the sum function inside parentheses. I write down the name of the vec, and when I run the code, I see number 28 is being shown here in the output. So the sum is 28. Then in order to calculate the mean of a vector, I simply call the mean function for the vector vec. Okay, inside the parentheses we write down the name of a vector, and then after that we have the call of the mean function for this vector. So this is the message that is being printed here, mean, and the mean or let's say the average of this vector is 4.66 approximately. Then I would like to calculate the median of the vector vec. I call the median function for the vector vec. Okay, and when I look at the output, it says the median is number 4 that is shown here in the output. So median function is going to calculate the median of this vector. And then we can have the calculation of the standard deviation using the SD function for the vector vec. And it is going to calculate the standard deviation for us, 3.26 approximately. Then what if we want to have the sort function? So I would like to actually sort my vector. In order to sort my vector, the thing that we can do is to call the sort function for the vector vec, and looking at the output, we see that here was my vector 5, 2, 8, 1, 9, 3. But looking at the output, we are having 1, 2, 3, 5, 8, 9. So this is the actually sorted version of my vector that is called vec. And now how can we reverse the sorted vector? In order to reverse it, I call again the sort function for the vector vec, but there is a second part in parentheses, inside the parentheses. I need to separate the first part, which is the call of the name of the vector vec, with a comma from the second part. And the second part is this part, decreasing equals true. This way we can firstly sort the vector and then show it in the decreasing order. Or let's say we are directly sorting the vector in the decreasing order, because we are saying that decreasing true. Okay, if we want to sort it in increasing order, we call directly sort for the vector vec. In the reverse order, we can have the sort for the vector and decreasing equals true. So looking at the output, we see that this was the sorted vector. This is the reversed sorted vector, 9, 8, 5, 3, 2, 1. Okay. Now we can have the discussion over the length and unique values of a vector. We can have the vector properties, for example. Here, in order to have the calculation of the length of a vector, simply we call the length function for the vector vec, and we see that this is the length of my vector, 6. Why? Because I have 6 elements there. So 1, 2, 3, 4, 5, 6. So 6 elements are there in my vector. Okay, so this is the length of my vector. This is how we can calculate it using the length function. And finally, imagine that we are having a new vector that consists of these numbers 1, 2, 2, 3. And I would like to find only the unique numbers. So you see that 2 is being repeated 2 times. I only want the unique values. Okay, in order to have that, we need to call the unique function. And looking at the output, we see that number 1, 2, 3, these are the numbers that are unique values of the vector with these numbers 1, 2, 2, 3. Okay, so in this video, we learned about vector functions and we learned how to work with them. Namely, we learned how to use the basic statistical functions, sorting functions, and vector properties functions. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to manipulate a vector in R. So first of all, I am creating a vector called vec, and these are the elements of my vector. 1, 2, 3, NA, 5, and 6. So this means that I don't have any number for the fourth element of my vector called vec. Okay. So now I would like to handle this missing value. So I have a missing value in my vector here. Okay, and I want to handle it. So firstly, I print the original vector vec. So we see it here. This is the original vector. 1, 2, 3, NA, 5, 6. Okay. Then I would like to remove the missing values. In order to do that, simply I have the na.omit syntax for the vector vec. Okay. Looking at the output, we see that now the missing value is being removed from the vector. So 1, 2, 3, NA, 5, 6. Now it's 1, 2, 3, 5, 6. Okay. So now we are having na.omit to remove all the missing values of the vector vec. And all of this is in the print function to have it in the output. Now, what if I want to replace the missing values with 0? In order to do that, I call the replace function for the vector called vec, and we check to see if there is any NA or missing value in the vector vec. If so, replace it with 0. Okay, so we call the replace function for the vector vec. We check to see if there is any missing value for the vector vec. If so, replace it with 0. Okay, and all of this is inside the print function, so we see it here in the output. Now, looking at the output, replace missing values with 0. So I see 1, 2, 3, 0, 5, 6. Instead of NA, I have 0, 5, 6 in the output. Okay. Now, what if I want to append value to a vector? In order to do that, I call the append function for the vector vec. So I want to append a value to the vector called vec. And I want to append number 7 to this vector. So I call the append function for the vector called vec and to append number 7. So I print it in the output. I see that the number 7 is being appended to the vector. So 1, 2, 3, NA, 5, 6, 7. And 7 is being appended to the vector. Then how can we combine vectors? In order to combine vectors, this is my first vector called vec1. The elements are 1, 2, 3. This is the second vector called vec2, and these are the elements 4, 5, 6. I want to combine them. In order to combine them, I call the combine, or let's say C function, and I have the vec1 comma vec2. This way, I'm going to combine vector 1 and vector 2 and print them. Looking at the output, I see numbers are 1, 2, 3, 4, 5, 6. So 1, 2, 3 comes from the first vector, 4, 5, 6 comes from the second vector. And we see that here 1, 2, 3, 4, 5, 6, these numbers are being printed here in the output. And then finally, I would like to have two new vectors, short vector and long vector. So the short vector has two elements, 1 and 2. The long vector has 4 elements, 10, 20, 30, and 40. Now I would like to do vector recycling. Okay, so let's see the output first. I'm having 11, 22, 31, and 42. And this is the recycled vector addition. Okay, in order to do that, I call the short vector and the long vector, and I have the addition sign in between them. So I'm adding the vector, the short vector, and to the long vector. Okay, but what's happened here is that this first vector has only 2 values, but the second vector, which is the long vector, has 4 elements. Okay, so what's going to happen is that 1 is being added to 10 firstly, and 11 is being shown here. Then 2 is added to 20, so 22 is being shown here. Then again 1 is added to 30, so 31 is being shown here. And then 2 is being added to 40, so 42 is being shown here. So this is what we call recycle vector addition. So in this video we learned about vector manipulation. Thanks for watching. Hello everybody and welcome to this video. In today's video we are going to talk about vector creation and different vector types in R. So first of all, I would like to create an empty vector. In order to create that, I call the vector function, and then I have the length of this vector to be 5. Okay, so now I want to create a vector with 5 elements. Okay, and using this assignment operator, I'm assigning these 5 elements to the empty vector because I did not specify what the numbers are, what the elements are of this vector empty vec. It is going to be by default 0. Okay, this is why when I use the print function to print this empty vec, when I look at the output, we see that 5 zeros are being shown in the output. So if we are looking for creating an empty vector or vector with all the elements to be 0, simply we call the vector function and we are assigning the length to be whatever we want. Like if we want to have 5 elements, if we want to have 10 elements, we can modify that. But if we don't specify the elements, it is going to by default consider them to be 0. Then we would like to create vectors using the sequence function. So we call the function that is sec, or we have the name sequence. So sec stands for sequence. And in order to create my vector that is called sec1, I would like to have a vector that starts from number 1 and ends at number 10, and I would like to step in this vector to be 2. It means that the first number is number 1 with the step of 2, the second number is 3, the third number is 5, the fourth number is 7, and finally the last number is 9. So in this range I want to create a vector and I would like to increment the value of elements by 2. Okay, so 1 plus 2 it's 3, plus 2 it's 5, plus 2 it's 7, plus 2 it's 9. This is how I create my vector using the sequence function. Also, I can have the starting point and the ending point to create a sequence vector, exactly like before. But then I tell the compiler that I would like to have 5 elements in this range. And in order to have 5 elements in that range, I need to call length.out function. So firstly, I call the sequence function, starting point and ending point. We mention them here, and then we mention how many elements do we want to have in that range. Okay, and this is all assigned to sec2. And when we print it, we see that here the starting point is 0, the ending point is 1. And we are having in total 5 elements. So 0, 0.25, 0.5, 0.75, and number 1. So this was how we can create vectors using the sequence function. And finally, we would like to have a vector with mixed types. So in order to create a mixed type vector, we can have this C function, or combined, let's say, and then we are having these elements. So the first one is a numeric value, the second one is a string, the third one is a Boolean expression. So this is why we call it a mixed type vector. Why? Because there are different types of elements in one vector: numeric value, integer, string, and Boolean expression here. So all of this is assigned to a vector that is called mixed vec, and we are printing mixed vec in the output, and we see that these three elements are being shown in the output. So in this video, we learned how to create a vector of different types in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about vector operations. So in this video, firstly, we're going to create two vectors, and we're going to perform some arithmetic operations, and then finally we're going to talk about recycling operation with vectors in R. So first of all, I have two vectors being created, vector A and B. The first one contains these elements, these three elements, 1, 2, 3. The second one contains these elements, 4, 5, and 6. And now I would like to perform some arithmetic operations over these two vectors. So firstly, I would like to have A plus B. So vector A plus vector B. I would like to do that and assign it to a new vector called sum vector, and I print it here in the output. Looking at the output, this is my output, 5, 7, and 9. How do we calculate 5? So the first elements of both vectors are added to each other. So 1 plus 4 is 5, you see here. Then we are having 7, which is 2 plus 5. Then we are having number 9 here, which is 3 plus 6. So this is the sum of two vectors, let's say. Or let's say to add a vector by another one. Then we are calculating the difference. So I have B minus A, and we are having this vector, 3, 3, 3. These three elements are there. So 4 minus 1, it's 3. 5 minus 2, it's 3. 6 minus 3, it's 3. So this is the vector that we call diff vector, and we print it here in the output. Then we are having the multiplication vector, where we are having 1 multiplied by 4, it's 4. 2 multiplied by 5, it's 10. And 3 multiplied by 6, it's 18 here. Okay. And so all of this is assigned to product vector, and the product vector is being printed here in the output. Finally, we are having the vector B divided by vector A, meaning that, for example, 4 is divided by 1, so number 4 is there. 5 divided by 2, it's 2.5 is there, and 6 divided by 3, number 2 is there. So this is actually the vector, the division vector of B by A. Now let's move on to the next topic. We would like to talk about recycling. Now I have a vector that contains two elements, 1 and 2, that is called C. I have the vector D. There are 4 elements, 10, 20, 30, and 40. Now I would like to have the recycled sum of these two vectors, meaning that I want to add these two numbers to these 4 numbers. How do we do that? We simply write down C plus D and assign it to a new vector, and we print it here in the output. So this is the output. But how do we calculate it? So how do we reach to 11? Firstly, the first elements are added. So 1 plus 10, it's 11. Then we are having 2 plus 20, so it's 22. So 1 plus 30, it's 31. And 2 plus 40, it's 42. So this is how the recycled sum is calculated. So the first element, second element, first element, third element, second element, fourth element. Okay, this is how it is calculated. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about logical and comparison operators in R. So we're going to firstly work with comparison operators, and then we're going to combine them with logical conditions, and we're going to finally work with any and all functions. Let's get started. So this is my vector called X, and these are the elements of my vector: 5, 10, 15, and 20. So I created a vector named x, and these 4 elements are assigned to my vector x. Now I would like to make a comparison. How do we do that? For example, I would like to see if I can create a vector of all the elements of vector x that are larger than 10. But when I work with the comparison operator, it means that I will see the output in Boolean expressions. Let me put it this way. So now let me print this vector. So I created a vector called greater than 10, and what is being assigned to this vector is the following. For each element that is in the x vector that is larger than, or let's say greater than 10, we're going to have true or false output. So let me run the code one more time. So this is the output of the greater than 10 vector. So basically what we are doing is this. We check to see the first element of the vector x. Is it greater than 10? No. So this is false. And false is assigned to the first element of this vector. Number 10. Is it greater than 10? No. So it's false again. 15. Is it greater than 10? It's true. 20. Is it greater than 10? It's true again. So basically I am comparing all the elements in the vector x with a scalar number that is number 10. And the output, either true or false, is assigned to a new vector called greater than 10. So this is the output as we see here. Now I am creating a new vector that is called equal to 15. In this vector, I am checking to see if elements in the vector x equals 15 or not. If yes, the answer is true. If no, the answer is false. So now let me print this vector in the output and I run the code. So when I run the code, we see false, false, true, false. So what's happening here is the following. 5, the first element of the vector x. Is it equal to 15? No, it's false. So we are having the false in the output. 10 equals 15? No. So we see false is in the output. 15 equals 15? Yes, it's true. So true is in the output. 20 equals 15? No, it's not. So we're having the false in the output. Okay. So all of these false, false, true, false are assigned to a vector that is called equal to 15. So we are creating a Boolean expression, let's say vector. A vector with full of Booleans with this condition. Okay. The elements are decided based on this condition. If I change this condition, the vector will change. For example, if I check to see if x equals 20, we're going to have false, 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 and true. Why? Because neither 5, 10, or 15 equals 20. So we are having 3 false. And 20 equals 20. This is why we are having true in the output. Now, let's move on to the next part. The next part is combining logical conditions. So now, let me put it here. Okay. Now I would like to create a vector that is called logical AND. So I would like to now teach the AND operator as well. We check to see each element of the vector x if it passes both conditions at the same time. Okay, so we check to see if 5 is greater than 5 and it is less than 20. Will it pass the both conditions? So 5 is less than 20, that is true, but 5 is not greater than 5. 5 is greater than or equal to 5, but it doesn't say that. It says 5 is greater than 5. So we are not passing one condition. We are passing only this condition and not this condition. Because we are having an AND operator there, it's a rule that we need to have both conditions being passed and being respected. Otherwise, the output will be false. So we couldn't pass both conditions at the same time, so we are having false in the output. Okay. Number 10. Is it greater than 5 now? So when I run the code, 10, is it greater than 5? Yes, it's true. And is it less than 20? Yes, it's true. So both of the conditions are true. Therefore, the output is true. Number 15, is it greater than 5? It's true. Is it at the same time less than 20? Yes, so it's true. Number 20, is it greater than 5? It's true. And at the same time, is it less than 20? No, it's not true. Therefore, we are having an AND operator with a true and false. So the output will be false. So we are having false because one of the conditions is not passing. Now let's talk about the OR operator. So when we talk about OR operator, this is the OR operator sign that we see here in programming in R. When we're talking about the OR operator, it means that we are checking several conditions, multiple conditions, and either of them should be true. At least one of them, if it's true, the output is true, okay? So now, here I am creating a vector to check these two conditions using OR operator. We check to see if 5 equals 5, it's true, okay? But 5 equals 20, no. But this one is true. One condition is true, therefore the output is true. Okay, so this is the difference between AND operator and OR operator. In the OR operator, if one of the conditions is true, the output is true. We don't care about the others. 10 equals 5, no. 10 equals 20, no. So the output is false. 15 equals 5, no. 15 equals 20, no. The output is false. 20 equals 5, no. 20 equals 20, yes. So the output is true. So this is how actually we created the logical OR operator, and we're printing it here in the output. Now finally, let's talk about the any and all functions. Here we would like to create, let me just move this part to the here and change the name. So here we are having the any function. I am calling the any function for all the elements that is in the X vector. And I'm checking to see if I can find any element that is greater than 10. Yes, you can find it because these are two elements that are greater than 10. So this is why the output is true. So we check to see if we can find any elements in the vector X that is greater than 10. Yes, we are having these elements that are these two elements that are greater than 10. But if I have, for example, greater than 25 and I run the code, the output is false because there is no element in X that is greater than 25. Now let's work with the all function. All function is going to check all the elements. We call the all function to check all the elements of the vector X to see if all of the elements in the vector X is greater than 0. Is it true? Yes, because all the elements are greater than 0. Therefore, the output is also true. So this is how we can work with logical and comparison operators in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to learn about subsetting and filtering vectors in R. So first of all, I am creating a vector called vec, and the elements are A, B, C, D, and E. So now if I print my vector called vec and I run the code here, you will see that these elements are being shown in the output. A, B, C, D, E. So these are the elements of my vector V. Now I would like to access the first element of this vector. In order to access the first element of a vector, I can directly, like this, access the first element of the vector vec. So if I run the code now, I see that the first element, which is A, is being shown here. But how? So basically, I am calling the element with index 1, which is the first element of the vector vec inside the print function. This is why we see A in the output. So if I want to access the second element, I simply write down number 2 here for the vector that is called vec. So I run the code, I see B is in the output. So this is how we can directly access one element of a vector. But there is another way. Another way would be to call the first element of the vector that is called vec and assign it to a new vector, or let's say variable here, called first element, and then print this first element in the output. Okay, so now if I run the code, you will see that A is being shown here in the output. How? Because now I am having the call of the first element and assigning it to first element here, and then I'm printing it here in the output. If I want to have access to the, for example, third element, I write down number 3 here, run the code, and we see that C is shown here in the output. Now this is how we can access one element by position. Now if I want to have a subset of the vector, how can we do that? In order to do that, for example, I would like to have a subset from the element 2 through 4, meaning that B, C, and D, I would like to have them in a new set or in a new vector, let's say. So here I call the vector that is called a vec. In the brackets here, I have the elements index. So I want to have from index 2, or let's say from element 2 to element 4. Okay, so the starting point is 2 and the ending point is 4. Okay, so 2 to 4 of the vector vec is assigned to this subset 1. And now if I print this subset 1, so I print it here, I run the code, we see that B, C, and D, all of them are being shown here in the output as they are elements from index 2 to 4. If I want to have from 2 to 5, I run the code one more time. We see that B, C, D, and E are showing here in the output. So this is basically how we can create a subset from an existing vector. Now I am creating a new vector that is called numbers. And this vector has these elements: 10, 20, 30, 40, and 50. Now that I have these elements, I created my vector called numbers. So first of all, let me print this numbers vector. So I write down the name here, I run the code. We see that these are shown here in the output: 10, 20, 30, 40, and 50. So now that these are the elements of my vector numbers, I would like to print the numbers that are, let's say, divisible by 20. Okay. And in order to do that, I would like to create a new vector that is called even numbers. And this new vector can only hold values that are divisible by 20. Okay, so we are basically filtering our current vector. So what do we need to do? In order to do that, for all the elements of this numbers vector that are divided by 20, and the remainder of their division using the modulus operator equals to 0, meaning that that number, that element is divisible by 20. For example, 40 is this element, is divided by 20. The remainder of their division equals 0. Yes? Yes, of course. So 40 is divisible by 20, okay? So if I want to do the same thing, 20 is going to be the same. But if we are going to divide 50 by 20, the remainder of this division, is it equal to 0? No, it's not equal to 0. Therefore, it's not a number that we are looking for to be assigned to the even numbers vector. In order to set this filtering, we are going to say for all the elements in the numbers vector that are divided by 20 and the remainder of this division equals to 0, assign them to a new vector called even numbers. So here, now I want to print even numbers. I run the code, and 20 and 40, both of them are being shown in the output. So let's do it manually. 10 divided by 20, the remainder equals 0. No, so it's not assigned. 20 divided by 20, the remainder of this division equals 0. Yes, so 20 is assigned to even numbers. 30 divided by 20, the remainder of this division equals 0. No, it's not assigned. Next, 40 is divided by 20. The remainder of this division equals 0. Yes, so 40 is assigned. 50 is divided by 20. The remainder of this division equals 0. No. Therefore, 50 is not assigned. Now that we assigned 20 and 40 to the even numbers vector, we are printing it here in the output. Okay. So let's go to the use of which function. So now here I would like to have the prints of the position vector. But firstly, let's see how we are actually creating this position vector. So we would like to set a condition, meaning that we are going to use the which function. Let me run the code. We are going to use the which function, and for the, let me remove this also. Okay. So we are going to call the which function for the elements that are in the numbers vector that we created here. Okay. That are greater than 25. So basically this which function is going to tell us which indices of the elements that are in the numbers vector have a value greater than 25. So 10, is it greater than 25? No. 20, is it greater than 25? No. 30, is it greater than 25? Yes. So which, what is the index of this 30? It's number 3. So 3 is assigned to the positions. Okay. So using the which function, we are going to find which element has a value, for example, greater than 25. We are going to return its index. So 40, is it greater than 25? Yes. Its index is 4 because this is the fourth element, is assigned to position. 50, greater than 25. Yes. So 5 is assigned to the position. When we print the positions in the output, we see that 3, 4, and 5, all of them are being shown here in the output. So this is basically how we can have the use of which functions. Now let's do the negative indexing. So now if I run the code, we see that here the first element is not there anymore because my vector called vec had values from A to E, but in the output we are having B to E. So the first element, which is A, is not shown there. So what's wrong there? What's happening? In order to exclude elements, we can use the negative indexing. Okay, so I call the vector called vec with the index -1, meaning that it's going to exclude the first element. The element with index 1 is going to be excluded using the -1 index there, and is assigned to these without first, and without first is being shown here in the output. So if I run the code now you see that we are having -2, and instead of having the exclusion of the first element, which was A, we are having now the exclusion of the second element, which is B. So we are having A, C, D, E in the output. So this is how we can work with subsetting and filtering vectors in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to talk about named vectors. We're going to learn about assign names, access by name, modify names, and remove names. So first of all, I am creating my vector that is including names as well. So the name of my vector is is named vec, and these are the elements. Apple equals 10, banana equals 20, and cherry equals 15. You can see it as a key value pair. Okay, so these are my keys: apple, banana, and cherry, and values are 10, 20, and 15. Okay, so I have 3 elements there, and there are 3 key value pairs. Actually, all of them are assigned to a vector called named vector. So if I print it here in the output and I run the code one more time, you see this in the output. So apple 10, banana 20, and cherry 15. Okay, this is how we can access my vector. Now I would like to have access to one element of this vector based on its name. For example, I would like to access the value that is assigned to the key banana. In order to do that, simply we write down the name of the vector, which is named vec, and here I write down the name of the key that I'm looking for its value. Okay, all of this is assigned to banana count, and I use the print function to print the banana count here in the output. So if I run the code now, we see that banana is 20. So banana, this is what we were looking for, and its corresponding value, which is 20, is being shown here in the output. Next, we would like to modify names there. Okay, now I am having the named vec, which is the name of my vector with assigned names. Okay, and I call the names function for that to modify its key names. Okay, to modify apple, banana, and cherry. Now on the right hand side, I am assigning the new names for this vector. So let me print the vector now, named vec. I run the code here, and we see that A, B, C, 10, 20, and 15. All of them are shown here in the output. So named vector was having 3 key names: apple, banana, and cherry. Here I call the names function for the named vec, and on the right hand side I'm assigning the new names, and these new names are now shown here in the output. Okay, now I would like to remove the names. How can we do that? In order to remove the names, let me run the code here, and we see that if I run the code now, we see that only values are shown here in the output. How can we remove the names? So I would like to remove the name for the named vector. So I call the onName function for the named vector and assigning it to unnamed vec. Okay, so this is going to remove the names from the named vector and assigning it to a new vector called unnamed vec, and we are printing unnamed vec in the output that are 10, 20, and 50. So in this video we worked with named vectors. Thanks for watching. Hey everybody, and welcome back. In today's video we would like to perform some mathematical operations using vectors. In this video we learn how to declare 2 vectors and how to perform mathematical operations like element-wise addition, subtraction, multiplication, or division between these 2 vectors and assign them to a new vector called result. So here is my first vector that is called A, and these are the elements of the vector A. So 1, 2, 3 is assigned to a vector called A. Numbers 10, 20, and 30 are assigned to a vector called B, and then these 2 vectors that are now declared A and B, I would like to have the element-wise addition of them. Okay, and the element-wise addition means that the first element of the vector A is going to be added to the first element of vector B. The second element of vector A is added to the second element of vector B. The third element of vector A is going to be assigned to the third element of vector B. Okay, and all of them are going to be assigned to a vector called result. Then we print the result vector, which is 11, 22, and 33. So 11 comes from where? So 1 plus 10, it's 11, is the first element of the result vector. Then we are having 2 plus 20, which is 22. So 2 plus 20 is 22, the second element, and 3 plus 30, it will be 33. So it's the third element. So this is how basically we can have the element wise addition of two vectors. But if we, instead of having the plus, if we are having the negative sign, we're going to have the element wise subtraction. So if I run the code one more time, we see that 1 minus 10, it will be negative 9, 2 minus 20, negative 18, and 3 minus 30, it's negative 27. So it's element wise subtraction. Then we can have the element wise multiplication here. So when I run the code now, we are going to have 10, 40, and 90. So 1 multiplied by 10, it's 10. 2 multiplied by 20, it's 40. And 3 multiplied by 30, it's 90. And finally, if we want to have the element wise division, we simply have A divided by B there. So we run the code and we see that all the elements are going to be 0.1. Okay, so this is basically how we can have element wise mathematical operations. Thanks for watching. Hello everybody and welcome to this video. In today's video we are going to work with another example of for loops. So first of all, I have a vector of names that is called C. Okay, so C is a vector of names, and you see that inside parentheses I have 3 names: Alice, Bob, and Charlie. Okay, and this vector of names is being assigned to a variable called names. So names now is a vector of names, and it has 3. Hello everybody and welcome to this video. In today's video we are willing to write a program that modifies one element of a vector. So first of all, we are having our vector called scores. Then these are the elements of this vector: 10, 20, and 30 that are assigned to a vector called scores. Okay, so first of all I'm going to print scores vector. So when I run this code now, you see 10, 20, and 30 in the output, exactly the elements that are assigned to scores vector. Okay, but I would like to modify the first element of this scores, let's say, vector. So the first element has the numeric, is actually a numeric integer that is 10. Now I would like to modify it and put it to be 15. In order to do that, we simply write down the index of the element in the scores vector on the left hand side, and then number 15, for example, on the right hand side. So it's going to change the first element in the scores vector, and 15 is going to be assigned to the first element of the scores vector, and which is now number 10. Okay, so when we do that, and then if I print the scores vector one more time, we see that now it has 15, 20, and 30 instead of 10, 20, and 30. Okay, so basically this is how we can modify an element of a vector. But what if I want to modify the second element? So now I would like to modify the second element, and I want the second element to be, for example, 33. So now I run the code. I see that the first element remains unchanged, and the second element is now 33. The third element also remained unchanged. So we write down number 33 on the right hand side. It is going to be assigned to the second element of the scores vector. And when we reprint the vector one more time, we see that the modified version is out there. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to have another example of for loops in R programming language. So first of all, we would like to define a vector of names, and then we are going to print the names that are inside that vector one by one. So here I have the vector of names being initialized. So the name of my vector is names, and here we are having 3 names in our vector: Alice, Bob, and Charlie. Okay, and we are using the C function to combine values into a vector. So these are my values that are being combined into a vector, and they are being assigned using the assignment operator to names. Okay, this is the name of my variable, name of my vector. So now I would like to print the names one by one. Alice, I would like to print it. I would like to print Bob, and I would like to print Charlie. Okay. In order to do that, of course, we can do it manually, but we don't want to do that. It's not efficient. So we need to have a for loop. So we define a for loop for each name in names. So names is the name of my vector, and name is my iterating variable. It could be I, for example. Let me just put I here. It's easier. So this is my iterating variable. For each I in the names vector, in each iteration, okay, print this. Okay, and what is going to print is going to print hello, and then in the first iteration I equals Alice, the first name in the names vector. So hello Alice, in the next iteration hello Bob, in the next iteration hello Charlie. So you see that here we have all of them in the output: hello Alice, hello Bob, and hello Charlie. Okay, but what does this paste function do here? So if I remove the paste function, it's not going to work, and we're going to see errors. Why? Because we are having 2 strings here. So this is the first string, and this is the second string, and we would like to join them into one string. As you see here, a hello Alice is being printed as one string, but here they are separated. So I use the paste function to join multiple strings or variables together into one string. Okay, and then we have the print function to print them in the output. So hello Alice, hello Bob, and hello Charlie, they are being printed in the output. So in this video we learned how to define a vector of names, and we use the C function to combine values into a vector, and then we had a for loop for each I in the names vector. We are going to, in each iteration, print the elements of that vector. So I in the first iteration equals Alice, so we are going to have hello Alice. In the second iteration, I equals Bob, so we are going to have hello Bob. In the last iteration, I equals Charlie, so we are going to have hello Charlie. Thank you for watching. Hello everybody, welcome to this video. In today's video, we are going to learn how to access elements of a vector in R programming language. So first of all, this is my vector called fruits, and we see that these are the elements that are assigned to this vector fruits. So apple, banana, and cherry. These are the 3 elements that are assigned to my vector that is called fruits. Okay, and we know that when we want to declare a vector, we need to have the C function, or let's say keyword, and inside parentheses we write down the elements that we are looking for, and these are the elements actually that we want to be assigned to the vector, and each element is separated by a comma from the other one. And because these are the elements that are string, they are in the quotes, you see. So this is why we're having the quotes here. If it was just numerical vector, we could simply write down the numbers. Okay, now I would like to access only one element of this vector, and I would like to access this banana, which is the second element, in fact. Okay, so in order to access that, we simply write down the name of the vector and then the index of that element that we are looking for, which is 2, because banana is the second element and I'm looking for the second element of the fruits vector. Therefore I use the print function. So when I run this code, I see banana in the output. What if I want to have the access to the first element of the vector fruits? So when I put number 1 as the index of this one, I run the code one more time, so apple is being shown. So the number of index of the element, we need to write it down inside the parentheses, let's say the square brackets, and then it's going to call that specific element. Okay, and if we want to print the whole vector, we know that we simply need to call the fruits vector inside the print function. So this is why now we see the vector, the full elements of a vector in the output. Also, if I want to have another numeric vector, for example, just to clarify this point, we use the C, and then inside parentheses we write down 2, 5, 3, 8, for example. So each element is separated by a comma from the other one, but because they are numeric values, we simply write down the numbers. And here we were having the quotes because there we were having strings as the elements. So this is how it works. When you're having strings as elements, you need the quotes as well. Thank you for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to create a numeric vector in R. In order to create a numeric vector, simply on the left hand side, we write down the name of the vector. Okay, so in this case, I chose to have a vector with the name numbers. Then on the right hand side, we simply use the C, and inside parentheses, we put the numbers that we would like to be inside our vectors. This way, these 5 elements are assigned to a vector called numbers. And then when I print this numbers vector, I see those elements in the output. So if I want to have, for example, a vector with 8 values, so now if I run the code one more time, I see that I have 8 numbers in the output. So this is basically a simple example of how to create a vector, a numeric vector, let's say, that is called numbers. And we can have another one that is, for example, called my vector. Simply, this is the assignment operator. And then I use a C and then whatever I want. So 20, 10, 52, 5, 4, 87, for example. Okay, so this is my vector. And this is the vector that I just created called my vector, let's say, with the elements that are 20, 10, 52, 4, and 87. And then I use the print function to print the vector that I just created that is called my vector. And when I run the code one more time, I see the elements of the second vector that is called my vector in the output as well. Thanks for watching. Hey everybody, welcome to this video. In today's video, we would like to learn how to filter one vector in our programming language. So we can filter them with a condition, in fact. In this video, we learn how to filter a vector with a condition indeed. So here on the left hand side, the name of my vector, my original vector is X. And these are 4 elements of this vector, 5, 10, 15, and 20. So these 4 elements are assigned to a vector that is called X. Now I would like to filter based on one condition. And the condition is that I would like to keep all the elements that are greater than number 10. Okay, so I would like to keep only the elements that are greater than 10 in the X vector, and then assign them to a new vector called filtered, and then print the filtered vector. In order to do that, simply I write down for vector X, each X, meaning that each element that is greater than 10, then that is going to be assigned to a vector that is called filtered. Okay. So it means that, for example, this one is the name of the vector, and this in the square bracket we are having the indices, meaning that here the element if of the X vector, okay, if that element if is greater than 10, assign it to the filtered vector. If not, don't assign it, go for the next element, okay? So number 5, is it greater than 10? No, we're not going to assign it. 10, is it greater than 10? No, because we are looking for numbers that are greater than 10, not greater or equal, okay? Only greater than and equal. If we were having that, 10 would have been included, but because we're having only greater than, so 10, is it greater than 10? No, they're equal. They're not, it's not greater than the other one. Therefore, we're not going to assign that. So 15, is it greater than 10? Yes, it is going to be assigned to the filtered vector. 20, is it greater than 10? Yes, it's greater than 10. So we're going to assign it to the vector called filtered. And then we are going to print the filtered vector in the output. So 15 and 20, both of them are being printed in the output. So what if I change this condition? So I would like to print only the I would like to assign only the elements that are greater than 16 and assign them to the filtered vector. So when I run the code, I see only the number 20 in the output because this is the only element of the vector x that is greater than 16. Then this is the only element that is assigned to the filtered vector. So what if I change this? I put it 10 and now I have the greater than or equal to. Okay, so now 5, is it greater than or equal to 10? No. 10, is it greater than or equal to 10? Yes, so 10 is also assigned, then 15 and then 20. So basically this is how we can have the filtration of a vector with a condition. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to talk about how to create a list with different data types in R. So I have a list called myList, and in order to create it with different data types, I simply call the list function, and inside that I'm going to put different data types. So the first thing is that I have numbers that are from 1 to 5. I have text that has the string hello. I have flags that has these 3 Boolean variables. And I have a matrix that contains numbers from 1 to 4 and it has 2 rows. So let me print this myList so we can see it in the output. So this is my list. I have numbers, I have text, I have flags, and I have matrices. So my numbers are from 1 to 5 as we said here. So from 1 to 5, starting point is 1, the ending point is 5. I have the text that is hello. I have flags that has true, false, true. These are the Boolean expressions. And this is my matrix, numbers from 1 to 4 as we decided here, numbers from 1 to 4. And it has 2 rows only. So the first row and the second row. It has 2 columns as well. So this is my list. I created my list. Now I would like to learn how to access its element by an index. So I would like to return a sublist. Now I run the code. I see that here the numbers are being printed here. So this is my list. The full list is here. And this is my sublist numbers. How? So I call the myList and then here inside the brackets, I would like to access its first sublist, okay? And its first sublist is numbers. The second one is text, the third one is flags, and the fourth one is matrix. So these are the sublists of my list called myList, and I would like to access its first sublist, which is number 1. This is why I put number 1 there. So when I have this code, I will see this in the output. So 1, 2, 3, 4, 5, which is the first sublist of my original list. If I put, for example, 2 here, it is going to go for the second sublist, which is text. Okay. So I run the code. We see hello is being printed here in the output because text is the second sublist. So this is how we can access the elements of our list by index. Then we can also access its element by name. For example, I can name the sublist that I'm looking for. So I write down the name of the list, which is my list. Then in the quotes, I write down the name of the sublist. So the name of the sublist is text. So I put it here, I run the code, and we see hello is being printed here because this is the sublist text that I'm calling here, and it has the string hello. So I can, for example, write down flags, for example, flags, okay? And I run the code. So we see that the flag part is being shown here. So this is still the original list, and flag part is one part of it. So true, false, true. And we see that here, true, false, true, all of them are being shown here in the output. So this is how we can access its element by name. Also, we can directly access the elements using the $sign. How? We write down the name of the list, which is my list, then the $sign, and then we have the name of the sublist. So I run the code, and we see that here 1, 2, 3, 4, 5 is being shown here. Why? Because I call the first sublist, which is numbers. I could write down the name of the matrix, for example. This is the fourth sublist. So I run the code now. We see that here, this is the matrix that is being printed here. So we can also have the access to elements directly using the $sign. Then we are going to have with the double brackets as well. So I run the code now. Looking at the output, you see that this is being printed here, which is the flag part. Okay. So this flags is being shown here in the output. But how can I access that? I can access that directly with double brackets. Okay. So I can write down the name of the list, which is my list, then double bracket number 3. This is the first one, this is the second one, this is the third one, okay, third index, which is for flags, okay, and we see flags, true, false, true, its values are being shown here in the output. So this is another thing. Now, how can I add new elements to my list? So I run the code and I print one more time my list here. So now I comment the previous print, and we see that here we are having a new sublist. How? So I write down the name of the list, which is my list, the $sign saying that, okay, this is the name of the new sublist, which is new item. Okay, the new item is the name of the new sublist. Then I would like to assign letters from 1 to 3. Okay, so letters are from A, B, C. 1, 2, 3 are A, B, C. Okay. So these letters A, B, C are assigned to a new sublist in my list. Okay, so I print my list. All the previous sublists are being printed here. Now we are having a new sublist called new item, and it has these letters A, B, and C, as we anticipated actually. Then we are having the modification of the existing element. So here you see that the text sublist has the value hello, and now I would like to assign a hello word to it. So simply on the right hand side, I write down hello word, the thing that I would like to be assigned. Then I would like it to be assigned to the text sublist, which is here, okay, for the my list. So I run the code one more time now, and I see that here it's now hello word and it's not hello anymore. Okay, so the modification has been done. This is another thing. And then what we could do is that we could remove elements as well. So now if I run the code, you see that we don't see the flags anymore. Flags are removed. Okay, true, false, true. This part is removed. Okay, so let me first comment this part. I run the code. You see flags are here. Okay, but when I put this line of code and I run the code, you see that flags are removed. How? We assign null to the flags sublist from my list, and I run the code. And this is going to help us to remove one sublist. So in this video, we learned how to create a list, how to access its elements by index, by name, by elements directly, and how to add new elements, how to modify existing elements, and how to remove elements. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to combine two lists. So here is my first list called my list, and I call the list function to create sublists for my list. So the first sublist is numbers, the second sublist is text, the flags sublist is here, and then we are having the matrix sublist. Okay, so then after creating this list called my list, I print my list so we can see it here in the output. You see the sublist numbers has values from 1 to 5 as we decided here. 1 to 5. It has the string hello. It has the Boolean expressions true, false, true for the flags sublist. And then it has a matrix from 1 to 4 with 2 rows here. And the sublist is called matrix. So we are printing it here. Now what I would like to do is to combine this my list with a new list that has only one sublist called extra. Okay, and it has values from 10, 20, and 30. These three values. Okay, in order to combine them, firstly I call the my list, then I create the second list here. So I call the list function exactly like the above here. Then I write down the sublist name. So here, for example, there were numbers, text, flags. Here we are having one sublist called extra. And then on its right hand side, we are assigning its values 10, 20, and 30. Okay, so all of this is assigned to a new list called combined. And then here I am printing the combined. So the combined is going to have the everything that my list has, and also this list that we just created here. So we have numbers sublist, text sublist, flag sublist, and matrix sublist from the my list. Then we are having the extra sublist from the second list that we created here with the values that are 10, 20, and 30. So in this video, we learned how to combine two lists in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to create a list in R, how to apply lapply function to a list, how to convert a list to a vector, how to create an empty list, how to have a list with null values, and how to have list of functions. Okay, so first, in order to create a list, we call the list function. And whatever that we would like to have in our list, we put it here. So this is the first sublist that is called numbers, and it has values from 1 to 5. The second sublist is text, and hello is assigned to it. The third sublist is flags, and true, false, true. These Boolean expressions are assigned to it. And we are finally having a matrix in the end. That is called, this is actually the sublist called matrix, in which we are having actually a matrix from 1 to 4. So the numbers elements of that matrix are from 1 to 4, and then we are having 2 rows. So I print this my list, we see it here. So this is the first sublist, numbers from 1 to 5. Okay, as we discussed here, numbers is the name of the sublist, and numbers from 1 to 5 are assigned to it. We are having another sublist called text, and hello is assigned to it. We are having another sublist called flags, and true, false, true are assigned to it. another sublist called matrix, and these numbers are assigned to it 1, 2, 3, and 4. So these are the sublists in the list that I created that is called my list. Okay. Now I would like to apply the lapply function. Okay, so what happens if I run the code right now? So you see that it's going to give us the data types of each sublist. Okay, simply we call the lapply function for the my list and we call the class. So it's going to give us the data types of each sublist in the my list list. Okay, so it says that the sublist called numbers has integer values. The sublist called text, it has characters, flags are logical, and then we are having a matrix here in the matrix sublist. So this is how we can have the apply function. Then in order to convert a list to a vector, simply what we need to do is that we need to choose which part of this list we would like it to be converted. So for example, I would like numbers sublist from my list to become a vector. So I call the numbers sublist from the my list. Okay, and I put the $sign in between them. All of this is inside the parentheses, and we're saying on list. So it's going to convert it to a vector. And looking at the output, we see that we are having a vector from 1 to 5 that has values as exactly as the values of the numbers sublist. This is how we can convert a list to a vector, and we can do it only if all the elements are the same type. For example, here, all of them are integer. If one of them is integer, one of them is float, it's not possible. All of the elements must be of the same type. Okay. Now, let me show you how we can have an empty list. So here we learned how to create a list. So I put a name here. So in this case, I put my list. Then I call the list function, and inside parentheses, I'm going to put different values and sublists, etc. for my list. We do the same here. So on the left-hand side, I choose the name. So it is called empty list. On the right-hand side, we are having the list function being called, but nothing is inside the parentheses. Unlike here that we were having some information there. Here we have nothing in parentheses, so it's going to create an empty list and assign this name to it, empty list. So when I print the empty list, I run the code, we see that it's an empty list being printed here in the output. So nothing is being shown there. So this is how actually we can create an empty list. Then we can also have a named list with null values. So I call this list null list. I again call the list function. I have two sublists, A and B. So these are the sublists, like numbers, like text, like flags. These were also the sublists of the my list. And these A and B are the sublist of the null list. Okay, and nulls are assigned to them. Okay, so this is called null list, and I print the null list. So looking at the output, we see that for the sublist A and sublist B, all we have is null values. Okay, null values. Okay, this is how we can have a named list with null values. And finally, we would like to learn how to have a list of functions. Here I have a list that is called a fun list. I call the list function again. The first sublist is square, and this square is actually a sublist of the fun list, but also a function. So it is going to, whenever this square function is called, we need to have one parameter to be passed when we are calling this square function, and that parameter is going to be raised to the power of 2. Okay. Then we are having a new sublist called cube. That is also a function. So we see that here it's the function keyword. We understand that it's a function keyword. And inside parentheses, because we are having X, it means that we need one variable. It could be Y, it could be Z, whatever. So we need one variable when we call the cube function or sublist. And basically that parameter is going to be raised to the power of 3. So it is going to calculate the cube of a number or the square of a number. So these are two functions that, or let's say sublists, that are in the fun list. Okay, so now I would like to call the square. In order to do that, I write down the name of the function or the sublist and then separate it by a $sign from the name of the list, which is fun list. And I need, as we mentioned, because there is a parameter here inside the parentheses when we call the function, we need to have a parameter when we call the function. So I have the number 4. So I would like to calculate the square of number 4. I call the square function from the fun list. And basically what's going to happen is that it's going to pass this number 4 and call this square function. So x will be equal to 4 and 4 will be raised to the power of 2, which is number 16. So when I run the code, we see 16 is being printed here in the output. And if I want to call the cube function for number 4, so I call the cube function for number 4, it's going to raise 4 to the power of 3, which is number 64. And I can have the calculation of the cube of number 5, for example. I run the code one more time. We see that this number is 125. So this is basically how we can create a list, how we can use the apply function for each element, how to convert a list to a vector, create an empty list and named list with null values, and finally how to have a list of functions. Thanks for watching. Hello everyone and welcome to this video. In today's video we're going to learn about some matrix manipulation in R. So specifically we're going to learn how to add a new row, how to add a new column, how to remove the first row or any row that we are looking for, or how to remove any column and reshape our matrix. So first of all, we are declaring our matrix using the matrix function. The name of my matrix is D, and I'm having numbers from 1 to 12. So I have 12 elements in this matrix. They are from 1 to 12, meaning that they are 1, 2, 3, etc. until 12. And we are having 3 rows. So n row means that the number of rows we need to decide about it. So 12 divided by 4, the number of elements divided by the number of rows, it will result in the number 4, which is the number of columns. So first of all, we're going to print this matrix D. Looking at the output, we see that this is our matrix D. We see that there are 3 rows as expected and 4 columns, 1, 2, 3, and 4. So we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, and 12. So this is my matrix D. Now I would like to learn how to add a new row. So as you see here, we are having 3 rows only in this original matrix. But as you see here, I have the same matrix, but a new row is added. Row 4 is added and all the elements are 0. How can we do that? In order to do that, I'm using the rbind function, and then I'm having the numbers 0 there to be added, and I use a D here as to call for the rbind function. So I call the rbind function and D. So then I decide about the numbers that I would like to be included in the new row, and all of this is assigned to D with new row. Okay, so here I call the rbind function for the D matrix. Okay, and we are adding these values as the new row. Okay, so this is the row binding, in fact. So this rbind is the row binding function. It is going to be called for the matrix D that we initialized here, and then these are the values that are going to be added to as a new row for this matrix, and then we print this matrix here in the output. Looking at the output, we see that exactly a new row is added to the original D matrix, and all the values are 0 because we decided them to be 0. Then we are having the new column being added. So this new column that we would like to be added, we are going to add it to the matrix D. So this original matrix 3 rows and 4 columns. We're going to add a new column here. Then we are going to use the cbind function for the matrix D, and then these are the values that are going to be added for the new column 10, 20, and 30. All of this is assigned to a new name matrix called D with new col, and we print this in the output. So when I look at the output and compare this newly generated matrix compared to this one, we see that a new column number 5 is added, and the numbers that are in the new column are 10, 20, and 30. So this is how we can actually add a new column and add a new row so far. Then we would like to remove the first row. In order to do that, we simply call the D matrix, and we are having in the square bracket, we are going before comma, we are going to have the number -1. It's going to remove the first row of the matrix D, because when we are writing the number before the comma, okay, it means that we are dealing with rows. If I write it after the comma, it means that I'm dealing with the columns. So in this example, I'm dealing with rows. I would like to remove the first row. I type down -1. If I want to remove the second row, I type -2. If I want to remove the third row, I type -3, for example, for the D matrix. And all of this is assigned to a newly generated matrix called D minus row. So I print it in the output. And looking at the output, we see that now the third row is not there anymore here. So we see that it has been removed indeed. In order to remove the column, as we explained, after the comma, we are going to put the negative numbers. The first column, -1. If you want to remove the second column, -2, etc. And this is assigned to a matrix called D minus col. And then we are going to print that in the output. And looking at the output, we see that here now, instead of having the original D matrix with 4 columns, we are only having 3 columns. Okay, so the last column having 10, 11, and 12 are being removed from this. Okay, and now I would like to reshape my matrix, meaning that now I have 3 rows and 4 columns. I would like to have a matrix of 4 rows and 3 columns. So I would like to reshape it. I call the D matrix. I call the matrix function for the matrix D. And I mentioned that, okay, now I would like to have the number of rows to be equal to 4 and number of columns to be equal to 3. All of this is assigned to reshaped D matrix. Looking at the output, we see that now we are having 4 rows and 3 columns instead of having 3 rows and 4 columns. So in this video, we learned how to manipulate our matrix, how to add and remove rows and columns, and how to reshape our matrix. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about some special types of matrices in R. So first of all, we're going to discuss matrices that are like diagonal matrices. Meaning that I would like, for example, to have a matrix that is 3 by 3, and in the diagonal we're going to have only number 1. In order to do that, we are going to have this keyword diag, and inside parentheses, when we want to have the 3 by 3 identity matrix, we're going to put number 3 there. If we want it to be 4 by 4, we're going to put number 4 there. And this is assigned to diag matrix 1. So when I print this one, I see this in the output. So looking at the output, we see that it's a 3 by 3, 3 rows and 3 columns matrix. And we are having a diagonal of number 1. And so we are having number 1, number 1, and number 1, and the other elements are number 0. So this is basically how we can do the diagonal matrix, a 3 by 3 diagonal matrix that are having values of 1. Then we can have diagonal matrix with custom values. So I'm going to have, for example, the diag function to be called, and then for the C, I'm going to put these 3 numbers. So I would like to have a matrix that is 3 by 3 because I'm having 3 numbers here on the diagonal, meaning that it's a 3 by 3 matrix. If I put 4 numbers in the diagonal values, for the diagonal values, it means that it's a 4 by 4 matrix. So I would like a matrix that has the diagonal of 2, 4, and 6. So then after that, I print the diagonal matrix 2. So all of this is assigned to diagonal matrix 2, and then I print it. So when I look at the output here, you see that I have a matrix that has a diagonal of these numbers 2, 4, and 6, as we identified here. And because we chose 3 values, we are having a 3 by 3 matrix. So if I add another number, for example, number 8, and I run the code one more time, you see that now I have a 4 by 4 matrix. Why? Because I mentioned that I would like to have 4 values on the diagonal, meaning that it must be a 4 by 4 matrix to be able to have 4 values on the diagonal. So 2, 4, 6, and 8, all of them are being shown there in the diagonal. Then I would like to create a matrix of zeros. In order to do that, I call the matrix function. I put the value 0, and then after first comma, I'm going to have the number of rows, and after the second comma, I'm going to have the number of columns. All of this is assigned to 0 matrix. It is going to create a 3 by 3 matrix and put 0 for all the elements. Looking at the output, so all of this is assigned to 0 matrix, and then I print the 0 matrix in the output. So we see that everything in this 3 by 3 matrix is 0. So all the elements are having the value of 0. Then how can we have a matrix of ones? So I would like to have a 2 by 4 matrix, and all of the values I want to be 1. So I call the matrix function. I put number 1 there. So all the elements will be 1. And number of rows are 2. I chose to be 2. And then I have the number of columns to be 4. So I have 4 columns here, as you see, and 2 rows. And all of this is assigned to a matrix called a ones matrix. And then I print it here in the output. Looking at the output, we see exactly what we expected is being printed in the output. So in this video, we learned how to have a diagonal matrix. So we can have an identity matrix, we can have diagonal with custom values, and then we can have matrix of zeros and ones. Thanks for watching. Hello everybody, and welcome to this video. In this video, we are going to learn about some matrix functions. First of all, I have a matrix called E. I use the matrix function to generate randomly 9 values for my matrix E. So in order to generate random values, I have the R norm, and I write down number 9 there, meaning that I would like to have 9 values being generated. Then I'm having the number of rows to be 3. So we're going to have a random 3 by 3 matrix. Why 3 by 3? Because the number of rows equals 3. So we are having 9 elements divided by 3. It will result to 3 columns as well. So firstly, I print this matrix E in the output. So as you see here, matrix E is being printed 3 rows and 3 columns. Some of the numbers are negative and all of them are randomly generated. Then I would like to calculate the sum of each row. So I would like to know the sum of values in the first row, the sum of values in the second row, the sum of values in the third row. So I use the row sums for the E matrix. Looking at there, we see that these 3 numbers are being printed. So this is the number of the row sum of the first row, and this is the number of the sum of the second row, and this is the number of the sum of values in the third row. Okay, so we use the row sum and assign it to row sums variable, and we print it here in the output. Then I have the call sums for the E matrix, meaning that it is going to calculate the sum of matrix E, and you see it here in the output. So here, this number 3.21 is the sum of this number plus this number plus this number. So all the numbers in the first column. Okay,
So this number 1.83 is the sum of these three numbers, okay? This one, and this one. And then we are having this number, which is the sum of this number plus this number and this number, meaning that the three values that are in the last column. So this is also how we can calculate the sum of the columns. The first number is the sum of the values in the first column, this one for the second column, and this one for the third column. So next we would like to have the calculation of averages, or let's say the means of rows and means of columns. In order to calculate the means of each row, I call the row means function for the E matrix, and there we are going to assign it to row means and print it in the output. So we see that this is the number which is the mean of these three numbers, which is the first row. This is the mean of the second row values, and this is the mean of the third row values. Okay. Then we are having the row means function, column means function for the E matrix, and we are having these three values. So this number is the mean of the values in the first column, which is this one, and this one. This one is the mean of the values in the second column, which is this one, and this one. And then this number is the mean of the values in the third column, So these are these three numbers, okay? So this is the number which is the mean of this number, and this number. Please note that they are negative numbers. This is why we're having the mean as a negative number. So in this video, we learned how to generate randomly a matrix. Then we learned about how to calculate row and columns sum. And finally, we learned how to calculate row and column means. Thanks for watching.
Hello everybody and welcome to this video. In today's video, we're going to learn a little bit of matrix algebra. So firstly, we are going to create a matrix. We're going to calculate its inverse. We're going to verify its inverse, and we're going to know the matrix rank in the end. Okay, so now the name of my matrix is C. I call the matrix function to have a matrix with 2 rows and with these values. So I would like to have a matrix with 4 elements, so 2, 1, 4, and 3. In order to have the elements there, I use the C there, and I choose to have 2 rows. So 4 elements divided by 2, the result will be 2, which will be the number of columns. So firstly, I print the matrix C in the output. So we see that here I have a 2 by 2 matrix, and the elements are 2, 1, 4, 3, as we chose here, 2, 1, 4, 3. Now, if I want to calculate the inverse of the matrix, simply I call the solve function for the matrix C and assign the output to inv_C matrix. So when I print it, I see this one here in the output. So looking at the output, we see that here is the calculated inverse version of the matrix C. So this is how we can actually calculate the inverse of a matrix, by calling the solve function. And in order to verify that it's an inverse matrix, so it's the correct inverse matrix, simply we are going to have the round function for the matrix C, and we are going to have percentage star and percentage operator or sign, let's say modulus, multiplication, and again the modulus operator of the INVC. So basically we are multiplying these two matrices, matrix C and the inverse version of this matrix, and it is being assigned to a new matrix called identity. So this should result in an identity matrix. So when we print that in the output, we see that indeed we are having a matrix with the diagonal of 1 and 1. So it means that we could verify the inverse version of our matrix C. Okay.
Now, in order to calculate the rank of our matrix, we are simply going to call the QR function for the C matrix, and then the $ rank is going to calculate the rank of our matrix. It is assigned to matrix rank, so this is the name of our variable. And finally, we print that variable, so it's going to show this message in the output, which is number 2. So the rank of our matrix is number 2. So in this video, we learned about how to do some algebraic operations with our matrices. So we learned how to create a matrix, how to calculate its inverse, how to verify its inverse, and how to calculate the matrix rank. Thanks for watching.
Hello everybody and welcome to this video. In today's video we are going to learn about matrix mathematical operations in R. So first of all, we would like to create two matrices. The first one is called A. I call the matrix function to have numbers from 1 to 4, and I would like to have 2 rows. Okay, so when I mentioned that starting point is 1 and ending point is 4, it is going to include numbers 1, 2, 3, and 4. So there are 4 values. And when I specify that I would like to have 2 rows, 4 values in 2 rows, so 4 divided by 2, the compiler understands that we also have 2 columns. We don't need to necessarily declare it, but we can also do it if we want. Then I would like to have the second matrix that is called B. It starts from 5, ends at 8. So 5, 6, 7, 8. 4 values. The number of rows, we are having 2. So 4 divided by 2, we see that there are also 2 columns for matrix B as well. So then I print matrix A and B using the print function. So simply I write down matrix A message and matrix B message, and then I print matrix A and matrix B. So when I look at the output, this is the matrix A. So 1, 2, 3, 4, these are the values 1, 2, 3, 4. So 2 rows, this is the first row, this is the second row, this is the first column, and this is the second column. Then we are having the matrix B, and you see that 5, 6, 7, 8. So this is the first row, this is the second row, this is the first column, and this is the second column. So we created 2 matrices. Now I would like to have the matrix addition. So A plus B is going to give me the element-wise addition of the matrix, meaning that we are going to create a new matrix. So the first value is 6. That comes from the first value, first element, let's say, of matrix A plus the first element of the matrix B. So 1 plus 5, it's 6. Then we are having 2 plus 6, it is 8, as you see here in the new matrix. 3 plus 7, it's 10. 4 plus 8, it's 12, as you see it here in the output. So this is actually how we can have the matrix, the new matrix that is called matrix addition. So we are having this message firstly, and then A plus B. Then we are having this message, matrix subtraction, and A minus B is being printed in the output. So A minus B is going to result in this matrix. So A is this one and this is B. 1 minus 5, it will be minus 4. 2 minus 6, it will be minus 4. 3 minus 7, it will be minus 4. 4 minus 8, it will be minus 4. So we are having a new matrix that is created from the subtraction of A and B. Then we can have the element-wise multiplication. So here we are having A multiplied by B. So looking at the output, we are going to see the element-wise multiplication. So we are having number 5 here. So 1 multiplied by 5, it's 5. 2 multiplied by 6, it's 12. 3 multiplied by 7, it's 21. And 4 multiplied by 8, it's 32. So this is the element-wise multiplication. But we can have the matrix multiplications as well. So for that, we are going to have A and then the modulus operator star then the modulus operator again, then matrix B. This is going to help us to have the multiplication of two matrices, meaning that the matrix A is going to be multiplied by matrix B, not element-wise, the normal multiplication, which will result in this matrix as you see here. Okay, so this is basically how we can have it. So for example, to have number 23, we need to have 1 multiplied by 5, which will be 5, plus 3 multiplied by 6. So 3 by 6, it's 18, plus 5, it will be 23, as you see it here shown there. So this is how we can have math operations in matrices in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to have the scalar multiplication of a matrix exponentiation, element-wise, and then the comparison operations of two matrices. So first of all, I create the matrix A, calling the matrix function. I would like to have 2 rows, and I would like to have 4 elements there from 1 to 4. So starting point is 1, ending point is 4. So 1, 2, 3, 4. Okay. So meaning that I would like to have from 1 to 4, meaning that there are 4 elements, and we chose to have 2 rows. It means that we are going to have 2 columns as well, because the number of elements are 4, and then number of rows is 2. So 4 divided by 2, it's going to have 2 columns. Okay. Then I create my matrix B here. I call the matrix function. I call the rep function also to have the repetition of number 2 4 times. So I would like to have 4 number 2s. Okay. And then I choose the number of rows to be 2. So firstly, before doing anything, I print the matrix A and B. So looking at the output, this is matrix A. So number 1, 2, 3, and 4, all of them are there. And then I have the matrix B, which has 4 elements, and all of them are 2, as we decided here. And we are having 2 rows and 2 columns for both of the matrices. Now, I would like to have the scalar multiplication. In order to do that, we are having, for example, number 3 to be multiplied by matrix A. This is the matrix A. So number 3 is going to be multiplied to all the elements of matrix A, and the new matrix is going to be written like this. Okay, so we put it in the print function, so it's going to be printed in the output. So number 3 is multiplied by 1, the output will be 3, so we see it's there. Number 3 is multiplied by 2, the output is 6, it's there. Number 3 multiplied by 3, it's 9. Number 4 is multiplied by 3, it's 12. So this is the matrix that is created from the multiplication of scalar 3 by matrix A. Okay, so this is how we can have it in the output. Also, we can have the matrix exponentiation, meaning that, for example, we can raise the elements of matrix A, all of them, to the power of 2. So it's an element-wise operation. So, for example, here, number 1 to the power of 2, it's 1. 2 to the power of 2, it's 4. 3 to the power of 2, it's 9. And 4 to the power of 2, it's 16. So all of them are raised to the power of 2, element-wise. So this is how actually we can do it. We can have the A and then the hat sign and then number 2. We could have number 3, number 5 as we wish. So just remember that it's an element-wise operation, meaning that it's going to raise all the elements 1 by 1 to the power of 2. Okay. Now I would like to have the comparison operation between matrix A and B. So we would like to see if matrix A equals B or not. So this is the output actually. We are having false, false, true, and false, meaning that it is going to see if the first element of matrix A equals the first element of matrix B. Is it equal? No. So the output is false. So the second element of matrix A equals the second element of matrix B.
is it true? Yes, it's true. So we have the true in the output. So 3 equals 2. No, it's false. 4 equals 2. No, it's false. So it's going to compare the numbers one by one of each element to see if they are equal or not. If they are equal, it returns true, which is the case here. Otherwise, it's going to return false. So this is how we can have the comparison operation. Also, another example is being shown here. I would like to see if A is greater than B. So we see that the output is false, false, true, true. So let's see. So it says 1, is it greater than 2? No, so it's false. 2, is it greater than 2? No, so it's false. 3, is it greater than 2? Yes, it's true. So we are having a true in the output. And 4, is it greater than 2? Yes, so we are having the true in the output as well. So basically, this is how we can have the comparison operations as well, along with scalar multiplication and matrix exponentiation. Thank you for watching.
Hello everybody and welcome to this video. In today's video, we're going to learn how to access a single element, entire row, and entire column of a matrix. And also, we're going to learn how to have access to a submatrix and logical indexing. So firstly, I would like to create my matrix called mat, and I call the matrix function starting from 1 and ending at 12, and we're going to have 3 rows there. So I have 12 elements and I would like to have 3 rows. So 12 divided by 3, it will result in 4 columns. So we don't need to specify the number of columns if we indicate the number of elements, the elements actually. So, and also the number of rows. The compiler can calculate the number of elements divided by the number of rows. So it can itself calculate the number of columns itself, but we can also specify it if we want to. Simply, we can specify it like the number of rows here that we specified, okay? Then I print the mat matrix. So we see that we are having 3 rows and 4 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, and 12. So these are the elements of my matrix. Now I would like to access only a single element. So the element at row 2 and column 3. So the element at row 2, this is the entire row 2, and column 3. It will result in number 8. So if I want to access this number 8, simply I need to give this address to the compiler. So I would like to print the element that is at row 2, column 3 of the mat matrix. Okay, so this is how we give the address. So the element at row 2 and column 3 of the mat matrix, we're going to print that. So we see that here number 8 is being printed in the output. Okay, now I would like to access the entire row. I would like to have the access of the second row, and I would like to print all the elements in the second row. In order to do that, simply I call the second row, and after comma I put nothing because I would like to have the entire row for the mat matrix, and I'm going to print that. When I run this, we are going to have 2, 5, 8, 11, exactly the numbers that are in the second row of this matrix. Okay, what if I want to print the entire column? For example, column 3, the third column, I would like to print the entire column 3. So this is 7, 8, and 9. This is column 3. In order to access that, simply we are having the mat matrix being called. Before comma we put nothing because before comma it is for the row. After comma it's for the column. I put column 3. So I would like to have the values in column 3. I put column 3. I put number 3 there. If I want the numbers in column 4, I simply put number 4 there. So, and then all of this inside the parentheses of the print matrix. So we see that the third column is being printed in the output. So we are having 7, 8, and 9 in the output. Okay. Now I would like to have access to a submatrix for rows 1 and 2 and columns 2 and 3. So rows 1 and 2, so this is row 1, this is row 2, columns 2 and 3, meaning that I would like to create a new matrix with numbers 4, 7, 5, 8. So I would like to create a submatrix of the original matrix for the rows 1 and 2 and columns 2 and 3. Okay, so there are 4 elements there. Simply, in order to do that, we call the mat, which is the original matrix, and then we are having before comma, which is for rows. I put from 1 to 2 because I would like to have rows 1 and 2. So from 1, 1, okay, row 1 and row 2. And after comma, we put 2 and 3, which is going to be for columns 2 and 3. So columns 2 and 3. This way, we are going to have a submatrix with numbers that are both in row 1 and 2 and columns 2 and 3, meaning that 4, 7, and 5, 8, they are going to be printed in the output. So when we look at the output, the submatrix is here. So we are having 4, 7, 5, and 8. So this is the submatrix that we just created. And finally, we would like to have logical indexing. I would like to, for example, print the elements that are greater than 5. So I would like to print only the elements that are greater than 5. In order to do that, I call the mat matrix, and I would like to mention that for each element in the mat matrix that is greater than 5, print it for me in the output. So we see that all the numbers that are greater than 5 from the original matrix, they are being printed. So 6, 7, 8, 9, 10, 11, and 12, all of them are being printed in the output. So in this video, we learned how to access a matrix, for example, a single element, an entire row, an entire column, to access a submatrix, and how to do logical indexing. Thanks for watching.
Hello everybody and welcome to this video. In today's video, we're going to learn how to create a matrix with different fill pattern. So we can fill a matrix with filling it by row or by column. We're going to learn these two filling patterns in this video, and then we're going to learn about how to check matrix properties like the dimensions, number of rows, number of columns, and total elements. Let's dive in. So first of all, I would like to create my matrix by row to be filled by row. So this is the name that I choose, matrix by row. I call the matrix function. I want the starting point to be 1, the ending point to be 6. So from 1 to 6 are the elements of my matrix. I would like to have 2 rows. So this is the n row, meaning that number of rows. So I would like to have 2 rows. So how many columns will I have? So the number of elements. So I start from 1 to 6. So I will have 6 elements divided by the number of rows that I just chose here. It will be 3, so 3 will be the number of columns. So this the number of columns can be calculated through these two values by compiler automatically. Then I would like to mention that, okay, I would like to fill this matrix by a row. So I put by row equals true, meaning that I would like it to be filled by row. And if in case you would like it to be filled by column, simply you do the same thing, but here by row equals false. So it will fill them by column. So what do we mean fill by row and fill by column? So let's print these two matrices and look at the output. When I look at the output, the first matrix, which is the by row version, okay, these are the numbers 1, 2, 3, 4, 5, 6. So it will increment by row. So in the first row I have 1, then 2, then 3, and in the next row I will have 4, 5, and 6. Okay, but when I fill them by column, it means that 1 is the first element, then 2 is in the same column but next row. Then I have number 3 and 4, 5, and 6. So when I talk about filling it by row, it means that I will fill it from left to right in the incremental order. But when I say I would like to fill it by column, it will be in each column. Okay, so 1, 2, 3, 4, 5, 6. So this is what I mean by fill by row and fill by column. So this is how we can have it. Then we would like to have the check for matrix properties. In order to have the number of dimensions of a matrix, simply we call the dim function for each matrix that we want. So for example, here for the matrix by row, I call this function, and it's going to print this for us in the output. Sorry. So we are having 2 rows and 3 columns. So the first number is for the number of rows. The second number is the number of columns. But how can we see it in the output? Because I call the dim function in parentheses of the print function. Okay. So this is going to, the cat is going to print the output for us. So we see that dimensions, it's in quotes. So this is the message being shown here. And then I have the column. So you see the column, and then I separate it by a comma from the second part, in which I have the call of the dimension function still in the cat function. Okay. So we see 2 and 3 in the output, and \n is going to let the compiler knows to go to the next line when you're printing anything else. Then in order to understand the number of rows, I call the endRow function for any matrix that I want. So it's going to print number of rows, which is number 2, which is true. So number of rows, this is the message that I wrote in the column, in the code, sorry. And all of this is also inside the cat function. So number of rows of the matrix by row is number 2. We have the cat function number of columns here. This is the number of columns message, and then ncall is going to help us to find the number of columns of this matrix by row. So number of columns, it's 3, which is true. So we are having 2 rows and 3 columns, 1, 2, and 3. And then in order to understand the number of elements that are inside this matrix, simply we call the length function for the matrix, and we see that the total length is 6. So in this video, we learned how to fill a matrix by row and by column, and we learned how to check some matrix properties, namely dimensions, number of rows, number of columns, and length. Thanks for watching.
Hello everybody, and welcome to this video. In today's video, we would like to learn how to create matrices in R. So first of all, we are having our matrix 1. This is the name of the matrix that I am choosing there. And then I am calling the matrix function to create my matrix. Okay. So I would like the values to be from 1 to 9. And I would like to have 3 rows. So this is the end rows, in end row, meaning that we are having number of rows here. So it equals 3, and number of columns also it equals 3. So we are creating a 3 by 3 matrix that is filled with numbers from 1 to 9. It is assigned to matrix 1. And then I use the print function to have this message being shown firstly, which is here. Okay, 3 by 3 matrix from 1 to 9, and then I print matrix 1. So we see 1, 2, 3, 4, 5, 6, 7, 8, and 9. All of them are being shown here in the output. Okay, so then I would like to have the creation of a matrix with the specific row and column names. So here, as you see, we are having the column names as 1, 2, 3, and 1, 2, 3 to be the names of our rows, in fact. But now I would like to have their name modified and customized. Again, I call the matrix function. This time I would like to have these values in my matrix. So I use the C function to have these numbers for my matrix. Then I mention that I would like to have 2 rows. Okay, so when I have these numbers, so I have 6 values, and I would like to have 2 rows. Therefore, the compiler understands that we're going to have 3 columns. Okay, because the number of elements divided by 2. So 6 divided by 2, it will be 3. So there will be 3 columns there. So now how can we name the rows and columns? In order to name them, simply we are having the dimension names or dim names there. It equals a list in which we are going to have the name, the customized names for our columns and rows. So I use C to have row 1 and row 2. And then I use C again to have column 1, column 2, and column 3. Okay, so whenever you want to name them, firstly you need to name the rows and then the name to name the columns. And before you're putting the names inside parentheses, just go for the C keyword. It's going to help you to customize the names. And all of this on the right hand side, as you see here, all of this is assigned to matrix 2. Then I have the matrix with row and column names message being printed as you see it here. Okay. And then after that, we are having the print of matrix 2. So when I have the print of matrix 2, I see 2, 4, 3, 1, and 5, 7. So 2, 4, 3, 1, and 5, 7. Exactly the numbers that we specified there. So as you see, we are having 2 rows and we are having 3 columns exactly. And the names are exactly the ones that we decided. Okay, so row 1 and row 2. I could say, for example, student 1, then student 2 as the name of our column. So when I rerun the code, we see that student 1, this is the row for student 1, this is the row for student 2. Then it could be, for example, the first one could be math, for example, the second one could be X, the third one could be Y, for example, different subjects. And when I run the code, you see that student 1 in math, the score is 2, in X it's 3, in Y it's 5. And for student 2, the numbers are different. So basically, this is how we can create a matrix in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we would like to learn about a few functions for matrices. So we would like to learn about transpose, diagonal, determinant, inverse, and dimensions. How to calculate these for a matrix in R. So first of all, I'm creating my matrix that is called mat. And these are the values that I would like to have in my matrix. And I would like to have 3 rows. So how many values do I have here? So there are 9 values there divided by 3 rows that I want, meaning that it results into having number 3, which is the number of columns. So the compiler is going to calculate the number of columns this way. Number of elements divided by the number of rows that we specify, and it is going to understand 3 columns needs to be there. So first of all, I'm going to print the mat matrix. So we see that here is exactly what I wanted to have. So 2, 4, 3, for example, 2, 4, 3, 1, 5, 7, and 6, 8, and 9. So this is the original matrix. Now I would like to calculate the transpose of this matrix. Simply, in order to do that, I firstly print this message transpose in the output. Then I have the T function called for the mat matrix. So T function, and then inside parentheses, we write down the name of the matrix. It is going to calculate the transpose of the mat matrix. And all of this is inside the print function, so we are going to see the transpose of the matrix mat in the output. And the transpose means that, for example, we are having the first row here 2, 1, and 6. It becomes the first column 2, 1, and 6. So here the original matrix has the second row to be 4, 5, and 8. And here in the transposed version, we are having the 4, 5, and 8 as the second column. And also the last row became the last column in the transposed version. Now I would like to know the diagonal. In order to calculate the element, in order to know the elements in the diagonal, we are going to simply call the diag function, which is the simplified version of diagonal, for the mat matrix, and then we are going to print it in the output. So we call the diag function for the mat matrix, and all of this is inside the print function. So we're going to see it in the output. So these are the elements in the diagonal of my matrix 2, 5, and 9. So 2, 5, and 9, they are on the diagonal of my matrix mat, original matrix, and they are being shown here in the output. And in order to calculate the determinant of a matrix, simply we call the det function for the mat matrix. So if you have multiple matrices and you want to have, for example, the determinant of a matrix called X, you simply call the det function to calculate the determinant, and inside the parentheses you write down the name of your matrix, for example, X, Y, Z, whatever. So in this case, the name of my matrix is mat, so I put the name mat there in there. So det for mat matrix, and all of this inside is inside the print function. So we see the determinant is 44 being shown there in the output. And also, in order to inverse my matrix, which is valid for square matrices, or which is also the case for us, we are going to have the solve function to calculate the inverse of the mat matrix. So when we are looking at the output, we see that here is the calculation of the inverse version of the mat matrix in the output. So this is how it is being shown there in the output. And finally, in order to know the dimensions of my matrix mat, I call the dim or dim function coming from the dimensions for the mat matrix, and I print it in the output, and it says 3 and 3, meaning that it's a matrix of 3 by 3, meaning that 3 rows, as you see here, and 3 columns, 1, 2, and 3. So basically this is how the functions would work in matrix in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we are going to learn how to do column binding, row binding, and diagonal combination of two matrices. So here I create my matrix 1. I have numbers from 1 to 4, and I have 2 rows. So it will lead to a 2 column as well, because I have 4 elements here divided by number of rows, so the number of columns will be calculated to be 2. Then here the matrix 2 called mat2 is being created, numbers from 5 to 8, and 2 rows there. So I print these 2 matrices in the output. So I have 1, 2, 3, 4, and then I have 5, 6, 7, 8 as to be mat2. So this is the mat1. This is mat2, exactly as we wanted. Now I would like to combine them, let's say, by columns. What does it mean? It means that I would like to have first a new matrix. First I have 1, 2, 3, 4, and here I have 5, 6, 7, 8. Okay, so I have 2 rows but 4 columns. This is combined by columns. So looking at the output, I have, this is the new matrix, that is the combined version by columns of the first 2 matrices. So 1, 2, 3, 4, these are the elements of the first matrix, and then 5, 6, 7, 8, these are the elements from the second matrix. So you see that here I combine them by columns. How can I do that? So I have the C bind, which is combined by column. So column bind, let's say, of mat1 and mat2, and I print them, so I see them here in the output. So mat1 and mat2, as you recall, they are the names of our matrices. Then I would like to have the row binding. So row binding means that I have 1, 2, 3, 4, and then 5, 6, 7, 8. So I have 1, 2, 3, 4, and then 5, 6, and 7, 8. Okay, so this is the row binding as you see it here. So I have 4 rows now, and I have 2 columns. In order to have that, I have the R, which is row, R bind, and for mat1 and mat2, I print them, and you see it here in the output. And then I would like to have the diagonal combination. In order to have that, so firstly let's look at the output. So we are having 1, 2, 3, 4, which is mat1, the first matrix, and then 5, 6, 7, and 8, which are the elements of the second matrix. So this is the diagonal combination because the diagonal of the first matrix, which is 1 and 4, is aligned with the diagonal of the second matrix, which is 5 and 8. So we created a new matrix here, as you see, with the diagonal of the first matrix and the second matrix. Okay, so in order to do that, simply we are having the B DIAG, B diagonal for mat1 and mat2, and we call the matrix column. So this is the scope resolution of the B diagonal mat1 and mat2 for the matrix. And this is the actually calling the matrix package. We need that. Don't forget to do that. And all of this is inside the print function, meaning that we're going to print them in the output. So in this video, we learned how to create 2 matrices, how to have the combination of them by columns and by rows, and diagonal combinations. Thank you for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to create arrays in R. So firstly, I start with this example, and then I will go up and work with a 3-dimensional array. In order to create our array, we are having the values that are 5, 3, 8, 1, 9, and 2. So these are the values that I want to put in my array. So I call the array function, and I put these values as the values of my array. Then I separate the first part from the second part by a comma, and then I mentioned that I would like to have an array with dimensions of 2 rows and 3 columns. Okay, all of this that we created is assigned to an array called R2, and then I print R2. When I look at the output, I see the same numbers, 538192, 538192, and we see 2 rows here and 3 columns, as you see here. Okay, so this is basically how we can create 2-dimensional arrays in R. But now let me give you an example of a 3-dimensional array. So I commented this part, the print of the R2, and I run the code one more time, so we see the print of R1 only in the output. So this is one array only. Okay, so I would like to have a 3-dimensional array, meaning that I would like to have an array with the dimensions of 2 by 3 by 2. So 2 rows, 3 columns, and 2 layers, let's say. Okay, so you see 2 layers. This is the layer 1, as it is indicated here, and this is the layer 2. Okay, and we see in each layer we are having 2 rows, okay, and 3 columns. So 2 rows and 3 columns in each layer. Okay, so these are the dimensions of my array. So I write down dim equals 2, 3, and 2. 2 rows, 3 columns, and 2 layers. Then, in order to fill the array that we just created, we need to put some numbers. So I would like to have numbers from 1 to 12. So I write down 1 colon 12, meaning that I'm going to have numbers from 1 to 12. So 1, 2, 3, 4, 5, 6. These are in the first layer. And in the second layer, we are having 7, 8, 9, 10, 11, and 12. All of this is assigned to an array called R1, and we are printing the R1 in the output. Thanks for watching. Hey everybody, what's up? In today's video, we're going to learn how to convert a matrix to an array in R and how to combine vectors into arrays. So we're going to start with this example. I have a matrix called mat. Okay, this is the name of my matrix. It has 2 rows and the values are from 1 to 6, meaning that the values in this matrix are 1, 2, 3, 4, 5, 6. So these are 6 values that I would like to be assigned to my matrix. Okay, so the starting point is 1, then we are having the colon, then we are going to write down the ending point. So 6 values are there, and then I mentioned that the number of rows that I would like to have for this matrix is equal to 2, meaning that, okay, I have 6 elements and 2 rows, therefore 6 divided by 2, it means that there are going to be 3 columns. The compiler is going to calculate it automatically. So all of this matrix that is created is assigned to a matrix that is called mat. Then I would like to convert this matrix to an array in R. So we call the asArray function, and then inside parentheses we write down simply the name of our matrix. Then all of this is assigned to an array called R3, and we're printing R3 in the output. So we see 1, 2, 3, 4, 5, 6. We see that this matrix that we created from 1 to 6 with 2 rows, as we are having it here still, is now converted to an array, and we're printing the R3, and we see it here in the output. So this was the first part of this video. Now that I run the code one more time, I see the print of R4 in the output. You see here, this is the first layer and this is the second layer. Okay, so now I want to convert vectors into array. The first vector called vec1 has these values from 1 to 4. So 1, 2, 3, 4, these are the 4 elements of my vec1. So the starting point is 1, the ending point is 4. Then we are having the vec2, and the numbers are from 5 to 8. So the first number is 5, then 6, then 7, and then 8. So these are 2 vectors that I just created. Now I would like to have an array of these 2 vectors. So I call the array function for vec1 and vec2, and I mentioned that I would like to have dimensions of 2 by 2, so 2 rows, 2 columns, and 2 layers. So in the first layer, I'm going to have the vec1, and in the second layer, I'm going to have the vec2. And each vector has 4 elements, meaning that these 4 elements can be written in a 2 by 2 array. So 2 rows and 2 columns are sufficient for having the values of my vector. And I have 2 layers. In the first layer, I have the vec1, and in the second layer, I have the vec2. And then all of this is assigned to R4, and we see the print of R4 here in the output. So, and this is the R4. So 1, 2, 3, 4, these are the values of the vec1. 5, 6, 7, 8, and these are the values of the vec2. So this is how we can convert a matrix to an array and combine vectors into array. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to work with a 3-dimensional array. We're going to learn how to get the dimensions, get number of dimensions, get total elements, and view the structure of an array. And also we're going to label the rows and columns and tables and access single elements, entire row and entire table. So here is my 3-dimensional array. It has 2 rows, 3 columns, and 2 layers or tables, let's say. And the numbers are from 1 to 12, and these are the dimensions. And we created this array and assigned it the name of R1, and we print R1 in the output. So this is the R1. This is the first layer. This is the second layer. You see 2 rows for each layer and 3 columns for each layer. So this is my 3-dimensional array. Now I would like to know what is the dimensions of this array. Simply, in order to have that, I call the dim function for the R1, and I print it in the output. So we see 2, 3, 2. 2 is the number of rows. The second number is the number of columns, and the third number, if available, is the number of layers. So it's a 2 by 3 by 2 array that we are having it here. Okay, so if I print the array one more time. So this is the array. So this is the number of rows. In each layer, we are having 2 rows. You see, 2 rows. And in each layer, we are having 3 columns, okay? And we are having 2 layers, okay? So this is how we can get the dimensions. Then I have the run of the code, and we see that number 3 is being printed in the output. So this is the length of the dimensions, so the number of dimensions that this actually array has, and it has 3 dimensions, right? Because we are having 3 dimensions here. So 1 row, 1 dimension for rows, 1 dimension for columns, and 1 dimension for layers. Therefore, there are 3 dimensions for this array. This is why we call it 3-dimensional array. So now I would like to know R1 has how many dimensions. So I call the length function for the dimensions of the R1, and we see number 3 is being printed in the output. So this is how actually we can get the length, actually the number of dimensions of an array. So then what is next is that we can have the number of elements that exist in our array. So there are 12 elements. So 6 of which is shown in table 1, and the remaining ones are shown in table 2. So in total, there are 12 elements in this 3-dimensional array, and we see 12 is being printed in the output. And how we can get that 12 number? So we simply call the length function for the R1 for the array. Then we can have the view of the structure of our array, and we see it here in the output. So we see that this is the structure of my array, and we see that, for example, we are having the values to be integers. And then we see that here, this is the number of rows from 1 to 2, number of columns from 1 to 3, because we are having 3 columns, and number of layers or tables that are from 1 to 2. And next, we can start actually labeling the rows and the columns and the layers. So I run the code one more time. We see this is the table 1. You see now instead of 1 2 3 1 2, we are having an 1 2 here. So this is layer 1, layer 2. So we are having table 1 and table 2. Instead of 1 2 3 here, I'm having column from 1 to 2. Instead of 1 and 2 here, I'm having row 1 and row 2. Table 2, columns from 1 to 3, rows from 1 to 2. So basically, this is how we can label it. So how do we do it? Actually, this is the output. In order to do that, simply we are having a list of labels. So first row 1, row 2, because we're having 2 rows, column 1, column 2, and column 3, and then table 1 and table 3, table 1 and table 2. So these are the labels that I put inside a list and assign it to dimensions name. So we call the dim names function for array 1. Okay, and then we print again the array 1, and we see the array 1 is changed, and we are having these labels now in the output. Okay, so this is actually how we can do that. Then we would like to access a single element in my array. So I would like to have the access to this element. Okay, for that we need to give the address to the compiler. So I call the R1, then I mention that, okay, this is in the first table or in the second table. So this is in the first, number 3 is in the first table. So I write down number 1 here on the right side. Okay, then I mention, okay, this is in the first table. Is it in the first row? Yes. So I write down number 1 here. And which number is the number of columns? So this number 3 exists in column 2. So I write down 2 here. So in table 1, row 1, and column 2. Okay, so we give this address to the compiler for the array 1. So we see number 3 is being printed in the output. If I want to have, for example, the print of number 10, simply it is in table 2. So I write down table 2 here. Then it is in the second row and also the second column. So I simply write down number 2 here again, and I run the code, and we see number 10 is being printed here in the output. So this is how actually we can have the access to a single element of an array. And how are we able to print the entire row? For example, here, when I run the code, I see numbers from 7 to 11. So this first row of the layer 2 is being printed. So I tell the compiler to go and check the R1, the table 2, and the row 1, and I don't have any indication for the column. It means that I want to have this row, number 1 of the second layer, all the elements, okay, in column 1, column 2, and column 3. So I leave it empty. It is going to give me all the columns from row 1 in the table 2. Okay, so 7, 9, and 11, all of them are being printed in the output. And finally, how can we have the print of the entire table? So this is my original array. I want to have the print of the first table. Okay, so I call the R1. I put nothing for the rows. I put nothing for the columns, meaning that I would like to have all rows and columns for table 1. So we see that here, table 1 is being printed here in the output. So basically in this video, we learned many things about three-dimensional arrays. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to create a three-dimensional array, how to get elements that are greater than 5, how to modify a single element, how to modify entire column. We're going to learn element-wise operations, and we're going to learn operations between arrays. Okay, so we're going to learn these topics in this video. Firstly, let me explain how I create a three-dimensional array. So I call the array function, and these are the values from 1 to 12. So starting point is 1, and the ending point is 12. So 1, 2, 3, 4, 5 until 12 are the elements of my array. And then I would like to specify its element. So 2 rows, 3 columns, and 2 layers, or let's say tables. All of this is assigned the name of R1, and we print R1 in the output. So this is R1. When I run the code, we see R1 here in the output. This is the first layer, and this is the second layer, as we decided here. So 2 layers, and each layer has 2 rows and 3 columns. So 2 rows and 3 columns. Okay. So here you see that we are having number 1, 2, 3, 4, 5, 6 in the first layer, and then 7, 8, 9, 10, 11, and 12 in the second layer. So this is my three-dimensional array. Now I would like to have the elements that are greater than 5. So I run the code. I see that these elements that are greater than 5 are being printed here. So this is the conditional printing, or let's say filtering. So I would like to have the elements in the R1 that are greater than 5. And you can modify it, of course. You can print only the elements that are greater than or equal to 7, for example. Or let's say greater than 8. So I run the code one more time. I see that the elements that are greater than 8 is being printed. They are being printed here in the output. So this is the first thing that we wanted to learn in this video. Then we would like to learn how to modify a single element. So now you see that here is my original array. Okay. I would like to go for the first layer, first row, and the first column. I would like to modify this number. So first layer, first row, and the first column. So it will be number 1. I would like to assign number 10 to it, number 100 to it. So let me run the code one more time. When I run the code, you see the new version of the array is being printed, and that number 1 here is now transformed to be number 100. Okay, so how did we do that? Firstly, on the right hand side I have the number 1. On the left hand side I have the address of the element that I would like to be changed. So the first row, the first column of the first layer, I would like to assign number 100 to it. And then I print again the R1, so we see the modified version of the array in the output. Okay, so this is another thing. Then we would like to modify, let me make a copy here. So then we would like to modify the entire column. So let me comment this part. I run the code. You see this is the original array again. Okay, I would like to modify the entire column. So I run the code now. This is the new version of the, let me also comment this part so it will not be effective. So this is the modified version of the array. So this was the original one, this part, okay? And this is the modified version. And if you look more closely, you will see that this number 3 and 4, they have been replaced by numbers 50 and 60. So this is my actually updated array. So I modified the elements in the second row completely. How did we do that? In order to do that, simply we add the numbers that we would like to be replaced. So we would like to have number 50 and 60 now in the new version. In order to assign them to the second column of the first layer, simply we write down the name of the array. We leave the before first comma, we leave it empty because it's with the rows. We don't have to do anything with the rows. I would like to modify the entire column 2 in the first table. And you see that the entire column 2 in the first table is now modified. Okay, entire column 2. If I want to modify the entire column 3, simply I write number 3 here. I run the code and you see that 50 and 60, they are now assigned to the third column, which were having 5 and 6 originally. Okay, so this is another thing that we can do here. Then we would like to have the element wise operations. For example, we would like to have R1 to be added by number 5. Okay, so this is the original array, and this is the new version. And you see that this number is the first element and this was the first number. So number 1 plus 5, it's 6. Number 3 plus 5, it's 8. Number 5 plus 5, it's 10. And if you go through all the elements of this new array, you will see that they are the element, the original element in the first array, in the original array, plus number 5. So it is an element wise addition of number 5. Okay. The second thing is that we can have the multiplication as well. So I run the code. You see that this is my newly generated array, and all the elements of the original array is multiplied by 2 and then assigned here. For example, here in the second layer, of the original array, we have the first element to be 7. It is multiplied by 2 and we are having number 14 here. So then number 8 multiplied by 2, we are having number 16 here. 9 multiplied by 2, we are having 18 here. 10 multiplied by 2, we are having 20 here. So this is actually the element wise multiplication of number 2. We can have any number here, like multiplication of 5. For example, I run the code. You see that all the elements in the original array are multiplied by number 5 and are shown here. Okay, so this is another thing. And then you can calculate the logarithm of each element in the array. Okay, you see that the logarithm of each element in the original array is calculated and assigned here. So this is how also we can have that. We simply call the log function for the arr1, and that's going to help us to do the work. Then here I create a new array that is called arr2, and it is the same as the arr1. So it has numbers from 1 to 12, and the dimensions are 2, 3, and 2. And they must have the same dimensions when we would like to add two arrays. So here I have the arr1 plus arr2. I run the code, and here you see the output. So this is the arr1, and we are having an identical arr2 as well. So this one is added to that one, and you see that it's number 2. So 2 plus 2 is 4. 3 plus 3 it's 6, etc. So this is also basically how we can have the operations between arrays. Thank you for watching.
Hello everybody and welcome to this video. In today's video we're going to learn how to create a two-dimensional array in R. So my array's name is X. We are having the X on the left hand side. On the right hand side I call the array function, and this is what happens inside the parentheses. So we are having two parts that they are being separated by a comma. So starting point is 1 and the ending point is 6. And then on the after comma part, we are going to have the dimensions. We are going to tell the compiler to have the dimensions equal to C, 2, and 3, meaning that I would like to have 2 rows, okay, and 3 columns. So numbers from 1 to 6 should be divided into 2 rows and 3 columns. Okay, so when 2 multiplied by 3, it will be 6. So 6 values make sense to have for our array. So when I print the array X, we see that this is the first row, this is the second row as we expected here. And then we are having 3 columns. So this is the first column, second column, and the third column. And we see that numbers are from 1, 2, 3, 4, 5, and 6. So what if I want to have 3 rows and 3 columns? Would it be possible to have it from these numbers? No, because when we are having 3 rows and 3 columns, we need to have 9 elements, while we are having only 6 elements here. So I change the ending point and I put it to be 9. So when I run the code, we see that 1, 2, 3, 4, 5, 6, 7, 8, and 9. Previously we were having up until 6, so the last column would have been empty. But if we want to have some values, we need to put the starting point and ending point in accordance with the number of rows and columns. So this is the first row, this is the first row, second row, and the third row, and this is the first column, second column, and the third column. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to learn how to create an array in R programming language. So first of all, I need to name my array. I call it arr1. I could name it, for example, X. So I'll call it X. X is my array. Then in order to create an array, simply on the right hand side I call the array function, and then I mention in parentheses starting point, colon, the ending point. Okay, so it will be the 1 will be the starting point of our array, then we will have number 5 as the ending point of our array. Okay, so number 1 to 5, they are being assigned to our array called X, and then we're printing the values that are inside the array X. So we are having 1 to 5 in the output. So in case I want to have from 1 to 15, so I change this and I run the code one more time, and then we see in the output we are having from 1 to 15 in the output. So this is basically how we can create an array in R. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to learn how to create an array with strings. So the name of my array is X, as we see it on the left hand side. And then in order to create our array, we simply call the array function. And then we are having the strings. So this array needs actually not needs to, but this array has 4 elements. So Alice, Bob, Charlie, and Donna. So these are the 4 names that I would like to be assigned to our array called X, which is an array of strings. And then I would like to know its dimension. So the dimension is 2 by 2. So we are having 2 rows and 2 columns. Okay. So after that, after creating the array X, I print the array X. So when I run this code, we see that here the names are being printed: Alice, Bob, Charlie, and Dana. If I want to have, for example, 2 rows and 3 columns, we can also do that, but we need to add a few names, like 2 names there. Why? Because when we are having the 2 rows and 3 columns, 2 multiplied by 3 will be 6, meaning that we need to have 6 names, while we were having only 4 names. So I add 2 names, Reza and Shaheen, and I run the code one more time. So we see that now we are having 2 rows and 3 columns, column 1, column 2, and column 3. And we see that Reza and Shaheen, both of them are being added to this array of strings in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we are going to learn how to have an array being multiplied by a constant number. So first of all, I have an array that is called X. To create this array, I call the array function. The starting point and ending point, they are 1 and 6. So we're going to start from 1 and then we're going to finish at 6. And the dimensions are 2 and 3. So we are having 2 rows and 3 columns. Okay, so this is the way that I am organizing the array. So now when I run this code and I print the array X, we see array X is this one. So we are having 2 rows, as you see, and 3 columns: 1, 2, 3, 4, 5, and 6. So these are the elements of the array. Then I would like to multiply the elements of this array by a constant number, which is integer 10. Okay, so I write down the name of the array multiplied by 10, and it is going to be assigned to an array called result, and then I print the result array. So we see that here in the output, we are having now 10, 20, 30, 40, and 50, and 60. So the original elements of the original array X, they are being multiplied by 10. So this is why instead of 1, we are having 10, instead of 2, we are having 20, instead of 3, we are having 30, etc. until the end. We could have another constant. For example, I could have number 5. So when I run the code, we see that here we are having the elements multiplied by 5, for example, here. Or we could have the addition also. So element-wise addition, meaning that each element in the array X is going to be added by 5. So instead of having 1, now I'm having 6. Instead of having 2, I'm having 7. Instead of 3, I'm having 8, etc. until the end. So this is basically how we can have the element-wise mathematical operations in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we would like to learn how to change a specific value in a 2-dimensional array using in R programming language actually. So first of all, I need to initialize my array. My array is called X. I call the array function starting from number 1 ending at number 9. So starting point is 1 and ending point is 9, and the dimensions are 3 rows and 3 columns. Then I print the array X. Okay, so when I print this array, you see 1, 2, 3, 4, 5, 6, 7, 8, and 9. So starting from 1 ending at 9, we're having 3 rows and 3 columns as we specified here. Okay, so this is the number. Now I would like to modify a specific element in this array X. Which one? So I would like to modify the number that has this address, row 2, column 3. So this is the row 2, this is the row 2, and this is the column 3. So number 8, I would like to modify it. Okay, So if I want to modify number 8, firstly, I need to write down the name of the array, which is x, and then the address of that element, meaning that that element is in which row and which column. Then on the right hand side, I simply write down the value that I would like to be there instead of 8. So now I want to replace 8 with 99. So I put 99 on the right hand side. On the left hand side, I write down the address of that element in the X array and use the assignment operator. Then I use the print function to print the array X to see if everything is okay or not, if we did the modification or not. Looking at the output here, we see that 1, 2, 3, 4, 5, 6, and 7 instead of 8, we are having 99 now, and then number 9. So basically in this video, we learned how to modify that. So instead of 99, I could have 90, for example. I run the code one more time. We see that now the modified 8 is 90. But what if I want to modify number 5 and not number 8? So firstly, what is the value that I want to be assigned to number 5? Instead of 5, I would like to have number, for example, 50, okay? Now I need to give the address of number 5. So it's in the row 2 and column 2, okay? So row 2 and column 2 of the X array, okay? 50 is being assigned to the element in the X array with row 2 and column 2. So if I run the code now, we see that the modified element is there actually. So we don't have the 8 being modified anymore because we didn't do it. But we see that instead of number 5, we are having number 50 as we were expecting it here. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to have sum of each row in an array and also sum of each column in an array. So this is my array called X. I'm creating it and starting from 1 and ending at 9. And then the dimensions are 3 by 3, meaning that 3 rows and 3 columns. So when I run this code, you see the original array X is being printed using this line in the output. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the elements of our array X. Okay. Now I would like to have the sum of each row, meaning that I would like to have the sum of these 3 numbers and these 3 numbers and these 3 numbers. And then I would like to have the sum of each column, meaning that I would like to have 1, 2, 3, the sum of 4, 5, 6, the sum of 7, 8, and 9. But how can we do that? In order to do that, I have the apply function for the X array with the margin 1 and call the sum function because we would like to calculate the sum. When we are putting the margin to be equal to 1, it means that we want to have the sum of each row, margin equals 1, for the X array using the apply function. It is being assigned to a new array, let's say, with 1 row that is called row sums, and we print row sums. So we see that 12, 15, and 18 is being printed in the output. So 12 actually comes from the 1 plus 4 plus 7. 15 actually comes from the fact that we are adding 2 plus 5 plus 8. So this is the second row sum. And 3 plus 6 plus 9, it is going to be printed in 18 here. It is going to be shown as 18 here. So 18 is the sum of these 3 elements. Okay, so this is the sum of each row. Now I would like to calculate the sum of each column. Again, I call the apply function for the X array, use the sum function for margin equals 2, meaning that I would like to have the sum of each column for the X array using the apply function. It is going to be assigned to call sums and we are printing it in the output. So we see 6, 15, and 12, 24. So 6 comes from 1 plus 2 plus 3. 15 comes from 4 plus 5 plus 6, and 24 comes from 7, 8, and 9. Basically, this is how we can have the sum of each row and sum of each column. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to learn how to have the sum of values inside an array. in R programming language. So the array name is R. I call it X for the sake of simplicity. So this array is having numbers from 1 to 9, and it has 3 rows and 3 columns. Okay. So an array is created with 3 rows and 3 columns with numbers from 1 to 9. So first of all, let me print the value of X. So when I run the code, this is the value of X. This is my array. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the values. Okay, now I want to calculate the sum of all the values that are inside this array. Meaning that I would like to have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. What would be the output? The output will be 45. But how can we calculate it in code, actually using codes, not doing it manually? In order to do that, I call the sum function for the X array. So inside parentheses, we write down the name of our array. Okay. So the compiler is going to calculate the sum of all the elements that are inside the X array, and it is going to be assigned to a variable called total. And then I print this total variable, which is 45. So this is basically how we can calculate the sum of all the elements in an array. So if I change the dimensions also, so if I have, for example, 2 rows and 3 columns, and the starting point is from 1 to 6. Now, if I run the code, firstly, we see that the array is being modified. So we are having 2 rows and 3 columns. And also we are going to see that the sum is 21 because we are having only from 1 to 6. Thanks for watching.
Hello everyone and welcome to this video. In today's video, we are going to learn how to create data frames in R. So here is my data frame that I created in the output. You can see it in here in the terminal. I have 1, 2, 3, 4, and 5 columns. So ID, name, age, department, and salary. And for example, John is the name of one of my employees, for example. He is one person in this data frame. With the ID 1, he is 28 years old and works in the IT department with the salary of $75,000 per year. And then I have Lisa, 32 years old, in the HR department with the salary of $65,000. So this is my data frame, and we are going to learn how to create a data frame in R. In order to create a data frame, first of all, we need to name it. So this is the name of my data frame, employees. You can name it whatever you want. In order to create a data frame, we need to have data.frame. So this is what we need to call before creating a data frame. And whatever we put inside the parentheses is going to be part of our data frame. For example, I write down here IDs as the first column to be from 1 to 5. And then separated by a comma from the next row. Then I have the name of the next column to be name. Okay, this is the name of the next column. Then names are John, Lisa, Mark, Anna, and Tom. Then I create the column with respect to the age, where we have 28, 32, 45, 29, and 38. Then we have a column for department where we discuss IT, HR, finance, IT, and marketing. Then we have the salary. So here is how we can have our data frame. And then we are having the end of the data frame. And this is how I created my data frame. Finally, I use the print function to print the employees data frame. And as you see here in the output, we can simply see the data frame with IDs, names, age, department, and salary. Thanks for watching.
Hello everybody and welcome to this video. In today's video, we're going to write a program to sum of some values to calculate the sum of certain values until we reach a certain threshold using while loops. So for example, I would like to write down the sum of numbers until total exceeds 100. Okay. So now I have a variable called total. I initialize it to be 0, and I have my variable called num that is equal to 1 initially. Now what I would like to do is to have the while loop as long as the total is less than or equal to 100, we're going to enter this while loop. Okay, as long as this condition is true, we're going to enter this while loop. What we're going to do in this while loop is that we're going to calculate the value of total plus the value of num and assign it to be the new value of total, and then increment the value of num by 1 unit. For example, in the first iteration, total, the new value of total equals 0 plus 1. Why 0? Because the new total equals total plus num, and total initialized to be 0 and num equals 1. So now total equals 1. And then what we are going to do is to increment the value of num by 1 unit. As you see, it is being shown here. So it was already 1, and now we're incrementing it by 1, so it's now 2. So this is the first iteration. In the second iteration, total is going to be 1 plus 2. Why? Because the new total equals total plus num, and from the previous iteration we calculated the value of total, which was 1, so we are putting it here, and the new value of the num is calculated in the previous iteration, which was 2. So now total equals 3, and the new num equals 2 plus 1. So now it is equal to 3. In the next iteration, total equals 3 plus 3, which is now 6. Why? So the previous total plus the previous new, so it's now 6, and the new value of the num equals 3 plus 1, which is 4. And then we are going to continue this while loop until the value of total variable is less than or equal to 100. This is our threshold. Okay. And in each iteration, we are calculating the new value of total and the new value of num. Basically, in each iteration, we are incrementing the value of num by 1 unit. Okay. When this loop is finished, we are going to print the total sum, and we are going to know how many iterations we had. And for that, we need to have the value of num minus 1. Why the value of num minus 1? Because the num firstly was equal to 1. This is why we are reducing that 1 unit, and we would like to know how many iterations we did. So, and we are incrementing the value of num by 1 unit in each iteration. So the number of iteration equals the value of the final value of num minus the original value of num, which was 1. Okay, so in each iteration, we are incrementing its value by 1. This is why the number of iterations can be calculated as the final value of num minus the original value of num, which was number 1. So when we run the code, we see that we are going to stop at the sum of 105 after 14 iteration, meaning that we are going to have, for example, the value of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, etc., until we reach the 14th iteration, where we reach the sum of 105 in the end. This is basically how to define a threshold for our while loop. So we would like to continue as long as the total value is less than 100. Okay, so if I change the condition and now I would like to continue as long as while is less than 1000, the total is less than 1000, we can see that in the last iteration, after 45 iterations, we reached the sum of 135, and because 135 was not passing this condition to be less than or equal to 1000, we did not continue it anymore after 45 iterations. So basically, this is how to write a program to define a threshold for sum of values. Thanks for watching.
Hello everybody and welcome to this video. In today's video, we're going to learn how to have access to elements of a data frame. So here is my data frame created called employees. As you see here in the output, this is my data frame. I have 5 columns: ID, name, age, department, and salary. For example, I have the Mark with the ID 3 with the age 45 working in the finance department with a salary of $90,000 per year. So this is my data frame. I would like to learn how to access specific elements in this data frame. Okay, in order to create the data frame, we know that we can have the data frame keyword here, and inside parentheses we write down our data frame. On the left hand side, we are having the titles of our columns. So for example, I have the ID, name, age, department, and salary. As you see, this is the first column: ID, name, age, department, and salary. So these are the names of the column. On the right hand side, we see the values that are assigned in that columns. For example, we are having John as the name, then Lisa, Mark, Anna, and Tom. So we see that John, Lisa, Mark, Anna, and Tom. So after creating my data frame, now I would like to have access to the employee's name only and not anything else. Okay, and you see, looking at the R console, we can see the names here: John, Lisa, Mark, Anna, and Tom. But how can we do that? In order to have the access to a specific column, we write down the name of the data frame, okay, then the name of that column. My column's name is name, okay. So this is why I write down the name here. If the column's name I want to write down is, for example, age, I can write down age, for example, and I run the code one more time, and we see the ages that are being printed here in the output. So firstly, we write down the name of the data frame, then the $sign, then the name of the column that we want to have its result in the output. Okay. So now let me run the code one more time. Now we see the salaries in the output. We see here. Another way to have access to elements is to have double bracket notations. So I write down the name of the data frame, and then in the double bracket notation, we write down the name of the column that we are looking for, which is the salary. Okay. So salary is being printed here in the output. And this is another way. We can have the single bracket. Let me run the code now. So this way, you see that I call the data frame with single bracket of the department column, and it is going to return data frame for me. As you see here, it's exactly in the same format of the data frame as you see here. So we have the department. Then we have the IT, HR, finance, IT, and marketing. So these are the departments that we were having in the original data frame, okay? Then another method to access elements is that we can access by position. So I run the code, I go down, we see John, Lisa, Mark, Anna, and Tom, okay? All of them are being shown here in the output. But as we look at the data frame, we see that it was the second column. Okay, so I called the data in the second column. So we call the employees data frame, and then we have in the bracket before the comma is regarding the row. So I don't want to do anything with the rows, so I put it empty. But after comma, I write down the number of the column that I'm looking for. So I wanted to print the names, I write down the column 2. If I was looking for the ages, I simply could have written number 3 there. So I run the code one more time. I go there and we see that all the ages are being printed here in the output. So this was another way. Another way to work is to have the rows being printed in the output. As we saw in the previous example, we were printing one column, so the second column or the third column. Now I would like to have the third rows to be printed in the output. So all the information regarding the Mark is being printed in the output. So this is Mark with the ID 3, age 45, finance department with the salary of 90,000. So Mark is in row 3.
in order to print row 3 only, I call the name of the data frame again. Again, we are having the bracket here, but now that we would like to work with rows, I simply write down the third row, and after comma, because I don't have anything to do with the columns and I want all the information in the third row, I leave it empty. So we see that all the information with respect to Mark is being printed here in the output, as you see there. So let's go to next one. Then we can have the employees by condition as well. So I run the code. We see that certain information is being printed here, but how do we judge them? I wanted to show all the employees information who are older than 30 years old. Okay. So looking at the output, we have John, which is 28, and we have Anna, who is 29. So I don't want them. I want only employees that are filtered based on their age and they are older than 30 years old. How can we do that? So simply I call the data frame, then I write down all the ages in the data frame employee that are greater than 30, print the full row for me. This is why we are having in the bracket before the comma, because we would like to have the full row of them. Okay, so this is how actually we can have access and filtering based on age. For example, I can have the filtration based on the department people who are working only in HR, so that we can also do it. Then we can have, for example, the print of the first 2 rows or first n rows of our data frame. In order to do that, we call the head function for the employees data frame, and then after comma I write down number 2, meaning that I want to have the only 2 rows of the first 2 rows of the employees data frame. So looking at the output, we see that the first 2 rows are being printed here in the output. So this is another thing. And then let's do another call and access for the elements. Looking at the output, we see number 32 is being printed here in the output. So 32 comes from this part of the data frame. It means that I am accessing the element that is in the second row, first row, second row, and the third column. So first column, second column, and third column. Third column, second row. So this is the element. I'm specifically calling one element, which is the Lisa's age. In order to do that, I write down the name of the data frame. Then I mentioned go to row 2 and column 3 and print it here in the output for me, which is number 32, as you see it here in the output. And finally, what we could do here is to run the code one more time and look at the output. We see that here the name Anna is being printed here in the output. What's happening here is that we are calling the element that is stored in the name column of the employees data frame in the row 4. And this is going to return Anna for us in the output. Okay. So basically in this video, we not only learned how to create a data frame, we also learned multiple ways to have access to different elements of a data frame. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to modify a data frame. So here is my data frame being created and you see it here in the output. I have 5 columns: ID, name, age, department, and salary. And we see that the information of different people in a company, for example, Anna works in the IT department with the ID of 4, number 4, and she is 29 years old and she earns $80,000 per year. Okay, so this is the data frame that I created here. This is the name of my data frame that is called employee. Then in order to create the data frame, I call the data frame. And then here inside the parentheses, whatever I write down is going to be included in my data frame. On the left-hand side, we see the names of the columns like ID, name, age, department, and salary. And on the right-hand side, we see the values that are assigned to these columns. Let's say, for example, for the age
column that we have here, these are the values 28, 32, 45, 29, and 38. And these are the numbers that we are assigning to this age column. Finally, we print the employees data frame that we see it here in the output. Now I would like to make some modification for this employees data frame. Now I would like to add a new column. And you see here is my updated data frame. So as you see, the previous one was having these up until here. So these columns were included in the original data frame, but now I added these 3 columns. How can we do that? In order to do that, firstly, I want to add a new column that is called bonus. In order to add that, I call the employees data frame with a $sign, and then I name the new column. So bonus is the name of my new column, and I have a $sign there. And then before the $sign, I have the name of my data frame, which is employees. And then on the right hand side, I am adding numbers. So 5K, 3K, 7K, 6K, and 4K. So these are the elements that I want to be added under the bonus column in the employees data frame. So we see that after printing the new, after doing this modification, when I print the employees data frame, I see a new column being added called bonus. And these are its corresponding values, okay, in different rows. Okay, so this is how actually I can add a new column. Write down the name of the data frame, $sign, and write down the name of the column. And on the right hand side, write down the values that you want to assign to that column. So this is actually how we can add a new column. So now we have 2 more columns to discuss. I have a column called total comp. And in order to add that, again, we just learned, we write down the name of the data frame, $sign, the name of the new column. So total comp, okay? So this is how the new column is actually created. Now, how can I fill the values in this column based on the salary column and the bonus column? So I want, for example, to calculate this 80,000, which is the 70,000 plus the bonus. Okay, so salary plus bonus is the total comp. Okay, simply on the right hand side, we call the salary column of the employees data frame plus the bonus column of the employees data frame. Note the $sign as well. Okay, so this way for each row, it's going to add the salary and the bonus and assign it to this total comp corresponding row. Okay, so in this column is going to be filled by the values in each corresponding row. For example, 90,000 plus 70,000, it will be 97,000 as you see it here. Okay, so this is actually how I added the second column to my original data frame. And finally, I would like to have a new data frame that is called, a new column to my data frame that is called senior. So I call the data frame $sign, the name of the column that I want to be named, so which is senior. And in order to fill this senior column, I want to make sure that if the age of my employee is greater than 35, it means that they are a senior. Otherwise, they're not. So this column is going to be filled based on the age that we are having in the data frame. Okay. So in order to define this if-else condition, I call the if-else function for the age column of the employees data frame. And I say, okay, if that age is greater than 35, assign yes. Otherwise, assign no. Okay, so this is how this new column is created based on the values in the age column. So 28, is it greater than 35? No, so we have the no in the output. 32, is it greater than 35? No, so we have no in the output. 45, greater than 35? Yes. 29, greater than 35? No. And 38, greater than 35? Yes. So this is basically how we can add the new column. And in order to see this full new version of my data frame, I simply call the print function for the employees data frame so we can see the updated version. So in this video, we learned how to add new columns, how to calculate the values in a new column based on the values of two other columns. And also we learned how to calculate the values, how to assign values of a new column based on numbers, for example, of another existing column in the data frame. Thanks for watching. Hello everybody and welcome to this video. In today's video, first of all, we're going to learn how to create a data frame, and then we learn how to modify the data frame. In order to create a data frame, we're going to name it. For example, I name it to be employees. Then I call the data frame function. Then whatever I put inside the parentheses is going to be in my data frame. So let me show you the data frame in the output first. So you see we are having 6 columns: ID, name, age, department, and salary. And each column is filled with certain values and information. Now I have this data frame, the same data frame that is called employees. I want to create it. So for the ID column, the first column, I'm having the values from 1 to 5. So you see in the ID column, we're having from 1 to 5. For the name column, we are having these names, and all of them are shown here. And then the same for the age, department, and salary. So we assign some values to different columns, and then we print the employees data frame that we see here in the output. Now I want to do some modification to this data frame. The first thing that I would like to do is that I would like to assign the salary of the first employee to be 78,000. Okay, so what I do here, so let me comment these parts first and run the code one more time. So when I run the code now, you see that the first person, you see this is the first row of the employees data frame, and we are targeting the salary column. So in the first row, which is this part, go for the salary column. So it will be this number, okay, of the employees data frame, assuming that if you have multiple data frames, you need to name it. So the compiler knows exactly which data frame you would like to modify. Instead of having 75,000, I would like to have 78,000. So then after that, I print my employees data frame one more time, and we see that the salary is now $78,000. So we see that here we could modify the salary that is shown in the first row, okay, from the employees data frame. So this is how we can modify a specific value in our data frame. The second way of doing it is that when I run the code now, looking at the output, we can observe that the salaries have changed for certain rows. So what I'm doing here is that I'm telling the compiler to modify the salary of people who are working in the IT department. So we have 2 people working in the IT department: John, who works in the IT department, and Anna, who works in the IT department. John earns 75,000 and Anna earns 80,000. So when I look at the updated data frame, I click here, I see that now instead of 75,000, John earns 82,500, and Anna, instead of having 80,000, now Anna has $88,000. So how did we modify these two numbers? In order to do that, simply we are telling the compiler to go for the salary column of the employees data frame, and when in the department column of the employees data frame, it is the value equals IT, meaning that that person works in the IT department, saying that okay, go to the department department column of the employees data frame, okay, and if the value in the department column equals IT, okay, then replace their salary
by this number. So whatever they earn currently, multiply it by 1.1, okay? And assign it to the salary of the employees that have the department equal IT. Okay, so let me say it one more time. So we tell the compiler that assign the salary of people who work in the IT department to be multiplied by 1.1, the current value to be multiplied by 1.1, and assign the new number to people who work in the IT department salaries of the employees data frame. Okay, so in other words, what we are doing is that we are having people working in the IT department with a certain salary. We want to give them the increase of salary by 1.1. Okay, and we are basically telling the compiler, okay, multiply the current salary of the employees department who work in the IT department by this number and assign it to exactly same people. Okay, so this is basically what's happening here. And after that, what other modification that we could have here, so let me run the code one more time, is that in the original data frame, the first column is called ID. The second column is called employee ID. So we renamed the first column. How can we do that? In order to rename a column, on the right hand side, we write down the new name that we would like to be assigned, so employee ID. On the left hand side, we tell the compiler, okay, go for the employees data frame, call the names function for the employees data frame whose column equals ID, change it to employee ID. Okay, so we call the employees data frame using the names function. So names function is going to help us to recall the name and rename actually the column. So call the names function for the employees data frame, and in the employees data frame, the column's name that is equal to ID, assign employee ID now. Okay, and then we are printing the employees data frame again. So we see that here the original one was having the ID as the first column. Now it has employee ID as the first column. So basically in this video, we learned how to create a data frame, how to modify data in our data frame. For example, change a specific value, conditional modification, and rename columns. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to remove data from our data frame. So here is my original data frame. It has 5 rows and 6 columns. So I'm having name, age, it has 5 columns: name, ID, name, age, department, and salary. So these are my columns, and this is my data frame. For example, this is the information about employees of a company. For example, Lisa works there with the ID 2, who is 32 years old and works in the HR department, and the salary is $65,000. Okay, so this is the information that we have. Now, here is how I create this data frame. I call it employees. We can call it whatever we want. We call the data frame function, and inside parentheses are the information regarding my data frame. For example, these are the columns: name, age, ID, department, and salary. And on the right hand side, you see the values that are assigned to each column correspondingly. So after that, I print the employees data frame. So we see the employees data frame print in the output, this one. Now I would like to do some modification. Now, the first thing is that I would like to remove a specific row from my data frame. In particular, I would like to remove the third row. So the third row is the information regarding this employee, Mark, who works in the finance department with salary of $90,000. Okay. So looking at the output, we see that Mark is not there anymore. So we removed Mark. And how can we do that? Simply, we tell the compiler to go for the employees data frame, and in the brackets, we are having -3, meaning that the third row, we want it to be removed. And after comma, we leave it empty because that part is for the columns and we have nothing to do with the columns now. So on the left side of the comma is the part that we are going to discuss about the rows, and we are going to put -3 there because we want to remove the third row. If I wanted to remove the second row, simply we can put -2, for example. So we are removing the third column of the employees data frame and assign it to employees data frame. Okay, so we are updating our employees data frame. So when we print the employees data frame now, we see that the information for the third row has been removed. So we don't have anyone called Mark here in the output. Okay, so this is the first thing that we can do. And also the second thing that we can do here is to have, for example, a little bit of working with the data. For example, I would like to see information of people who work in this company and who are only under 30 years old. I would like to see only this information, not anything else. Okay, only information regarding people whose age are less than 30. So here, looking at the original data frame, we see that we are having John 28 and we are having Anna 29. So these are two people who are less than 30 years old. Okay, so in order to let the compiler know how to filter, let's say, our original data frame, we simply mention that, okay, go for the age column of the employees data frame whose values are less than 30. Keep them for me from the employees data frame and assign it to the employees data frame. Okay, so basically we are removing any other information that exists in the employees data frame, and we are only keeping the information regarding the people whose age are less than 30. Okay, so let me say it one more time. So people whose age, whose values, let's say, in the employees data frame, the values in the age column that are less than 30, we would like to keep them and assign them to be employees data frame. Okay, and now the new employees data frame has only 2 rows because we removed any other information regarding the people who were not less than 30 years old. So basically in this video, we learned how to remove data from our data frame. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to select specific column and specific rows and columns in R from our data frame. So here is my data frame. I have these columns: ID, name, age, department, and salary, and each row represents information regarding one person. For example, the row with the ID 4, we are having Anna, who is 29 years old, working in the IT department with this much of salary. Okay, so in order to create that, I create the data frame here. The name of the data frame is employees, and these are the name of the columns that we are having here. And on the right hand side, we are having the values that are assigned to each row. Finally, we print the employees data frame as you see it here in the output. Now I would like to learn how to select a specific column from this original data frame. Imagine that I would like to create a new data frame in which I only have the column name and the column department. In order to do that, simply I call the employees data frame for the name and department columns. Okay, so this is the employees and we are having the brackets here. Before the comma is the data with respect to the rows. We don't want to deal with rows now. And after the comma is about the information with respect to the columns. Okay, so this is the part that we would like to work with because we would like to select specific columns. And we mentioned that we are directly working with the name and the department columns. Okay, all of this is assigned to a new data frame called minfo, and I print it. So this is the output. we see two columns, name and department. We see that John in IT, Lisa in HR, etc. until the end. If I was looking for example, ID and name, simply I could write down here ID and name here. So we are going to create a new data frame with these two columns only. So you see ID and name. All of the information is here. So this is how we can select a specific column. With respect to the, let me comment this part now. With respect to selecting specific rows and columns, here we would like to have the information with respect to the people who are working in the IT department. Okay, so I would like to create a new data frame from the employees data frame, and I would like to have the information of people who work in the department column, in the employees data frame who work in the IT department. So I would like to have information of people whose department is IT from the employees data frame. Okay, and what information do I need from people who work in IT department? I would like their name and their salary. Looking at the output, I see their name and their salary. So let me say it one more time. Now I would like to select specific rows and columns. I would like to have the information of people whose department is IT from the employees data frame, and I need information about their name and salary. Okay, all of this is assigned to the IT team data frame, and I print the IT team data frame and we see it here. So we see their name and their salary. If I wanted to have the information of people who work in the HR department, for example, I would like to know their name and their salary. I run the code. Now we see that one row is only in the output. Lisa, who works in the HR department, has the salary of $65,000 per year. So in this video, we learned how to select specific rows and columns from a data frame. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about advanced filtering methods in R, and here is my example. So here we are having a data frame. This is the information provided in the data frame. For example, John, who is 28 years old, who works in the IT department and has the salary of $75,000. We are having 5 people, and the name of the data frame is employees. Now we would like to learn how to perform advanced filtering. For example, the first one is that we would like to learn how to perform multiple conditions. Here I would like to only have the name of employees whose salary is greater than $70,000 per year and whose age is less than 35. Okay, so for the employees data frame, we mentioned people whose salary is greater than 70,000, and this is an AND operator. So this condition must be true and this condition must be true, and their age is less than 35. Okay, find these people and assign it to a new data frame called high earners, and then print these high earners data frame. In the output, we see that we are having 2 people, John and Anna, who are 28 and 29 years old respectively. Both of them work in the IT department and their salary is $75,000 and $80,000 per year respectively. So this is how we can have the multiple conditions. Then we would like to learn about the in operator. So here I create a vector called depths, and the vector consists of 2 strings, IT and finance. So these are 2 departments that we are assigning to the depths vector. And then what I would like to do is that I would like to have all the people who work in the IT or finance department in the output. So I call the employees data frame, original data frame, and we call for people whose department is inside the vector depths, meaning that is either IT or finance. This is assigned to a data frame called selected, and we print the selected in the output. And here we see that we are having 3 rows, John, Mark, and Anna, with their information. All of them are working either in IT or finance department. So this is how we can work with the in operator, as you see it here. So we created a vector and we mentioned, okay, if there are some people whose department is included in the depths vector, in fact. Then finally, we would like to have the subset function. We would like to work with the subset function. Here, we would like to have the print of the names of people whose age are less than 30. So go and find people who are less than 30 and return this information about those people who are less than 30. Tell me the name, department, and salary of people who are less than 30 years old. So I call the subset function for the employees data frame for the condition of age of less than 30. And we mentioned select this information for people who are passing this condition and assign it to a new data frame called young employees. Then print this young employees for me in the output. So we will see that in the output we are having 2 people, John and Anna, who work in the IT department, and their salary is these 2 values. So we see that name, department, and salary, their name, department, and salary are being printed for people who are less than 30 years old. In this video, we learned about advanced filtering methods in R, for example, multiple conditions, in operator, and subset function. Thanks for watching. Hello everybody, and welcome to this video. In today's video, you're going to learn about sorting a data frame in R. So here is my data frame. We are having 5 columns, and each row represents the data of one employee, and the name of my data frame is called employees. For example, here I have Tom with the age 38 years old, who works in the marketing department with this much of salary. Now, what I would like to do firstly is that I would like to sort by a single column. So I would like to sort this information based on the salary in ascending order. Okay, so you see that this is not sorted now. So in order to do that, we see that here I call the order for the employees data frame, and I mention inside parentheses that I would like it to be ordered or sorted based on the salary. Okay, and we see that here the output would be like this. So now it is sorted based on the salary in the ascending order. As you see, it starts from 65, 72, 75, 80, and 90. And we see that everything is now sorted out, while in the previous one, in the original one, it was not like that. So now we learned how to sort by a single column based on in the ascending order. Now, what if I want to have in the descending order? In order to have the descending order, I bring another example. Now I would like to sort based on age in the descending order. So the difference would be, again, I call the order function for the different column, but in order to make the ascending order to become a descending order, simply I have this negative sign here. This is going to help me to have the output in the descending order. Now I would like to have the sorting based on the age in the descending order. So we see that we start from 45, then go 38, 32, 29, and 28 in the output. So if I remove that negative sign there, so if I remove it here, now oops, sorry. So now if I remove this negative sign and I run the code, we see that here in the output, we are having the sorting based on the age in the ascending order. So starting from 28, we go for 45. So if you have the negative sign there, it is going to do the descending order. Otherwise, it is going to have the sorting in the ascending order. Now I would like to have the sorting based on two criteria. So I would like to first sort based on the department, and then based on the salary. Okay, so now I call the order function for the employees data frame. I write down first do the sorting based on the department, then do the sorting based on the salary. So looking at the output, we see that here we are having the finance because it starts with F in the alphabetic order. Then HR is there, then IT, and then marketing. So because this is a small example, we don't have multiple people in different departments. We only have 2 people in the IT department. So we see that everything is sorted in the alphabetical order based on their department. We can check it here. And then based on the salary. So within each department, we should have the sorting based on the salary as well. So this is why 75,000 for John is shown first, then 80,000 of Anna is shown second. Because after the department, because these 2 people work in the same department, IT, we are having the salary as the sorting, as the second sorting criteria. So in this video, we learned how to sort in descending order, in ascending order, and also based on 2 different criteria. Thanks for watching.